Welcome to our talk on the, perfect, it's right here, on the HERMES system. We have Peter Bloom presenting today. Peter's going to talk for around 30 to 35 minutes-ish, and we're going to leave questions to the end so we can get in as many as possible. If you're a virtual attendant, we have a Matrix channel specifically for this talk that you can find and post your questions there. I will be monitoring it as well as the AV crew. If you're in the room and have any burning, really important questions that are need to be said, Peter has let me know that you can feel free to shout it out. But other than that, we're looking forward to your talk, and take it away.
Thanks. Hello. How's it going? How's everybody? All right. Nice. Glad to see. It was a little cold in this room, so I was thinking we would have to huddle together for warmth, but the room is nice and full, so that's great. Thank you, everybody, for coming. As the person who introduced me said, my name is Peter Bloom, and I'm joining you from an organization called Rhizomatica. I'm also joining you from Mexico, where I live. So it's nice to be in New York again. I spoke at Hope with my partner, and our baby was here actually in, I don't know, it must have been like 12, 13 years ago, about some of the other work that we do around autonomous cellular networks. I don't know if anyone was here or remembers that talk. Yeah, cool. That was a fun one. So yeah, really happy to be back at Hope. It all kind of coincided nicely that I was up here. So just, yeah, happy to be here. Glad to see this event still going and going strong. And just nice to get, back in touch a bit with the hacker scene here in the U.S. A lot of our work, a lot of my time is spent outside of the U.S., so it's nice to be back. I grew up in Philadelphia, so right down the road. And so we're going to talk today about HERMES. HERMES is a technology that we, Rhizomatica, the organization I work with, has been developing since 2017, actually. It took us almost 10 of those years to come up with the acronym. But that really did take a lot of effort. But basically, it says it right there, High Frequency Emergency and Rural Multimedia Exchange System. And the purpose of that, secure long-distance data communication over HF radio. So Rhizomatica is an organization that I helped to start around 2009. And we've been working around the world with communities on different topics and issues of autonomy. So community autonomy, how can we help communities protect their territory, protect their culture, and just kind of do whatever it is that they want to be doing and not sort of have to submit themselves to, all the stuff that we're kind of used to around here, but that maybe they aren't. So yeah, we work around the world to support communities and movements with technology. And then we also, since a lot of that technology that we help develop lives in a sort of weird regulatory gray zone, we also work on the regulatory piece. If anyone was at Mallory's talk just now, some of that's pretty familiar to us as well, the ITU and these other places. And then finally, we try to work with the communities to help them sustain the technology over time. So we're not so interested in going and dropping in places and putting stuff and then hopefully it works. It's more working with the community to make sure that whatever it is we're doing with them, whatever they're trying to do, is something that they can sustain over a long period of time. So we don't really measure our success in how many radios were installed or how many lines of code were written, but was the longevity of the projects in the places that we're working. So we have some projects that have been around for over 10, almost 15 years that are fully just community run, like we have almost no even contact with them anymore, and they're still going. So that for us is the most gratifying part of our work. So Rhizomatica is a US-based nonprofit, but pretty much all of our work is outside of the US and around the world. So, okay, into the topic of the talk, HERMES. So we started HERMES in 2017. If any of you were at that talk many years ago, you'll know Rhizomatica, sort of our biggest project that we had at the time or that we were doing for a long time was helping a bunch of indigenous communities in southern Mexico build and operate a completely autonomous cellular telephone network. And we did that for a very long time. That work is now done by like our sister organization that we started together with the communities called Telecomunicaciones Indígenas Comunitarias in Spanish, because it's in a place where people speak Spanish. So we, around that same time that all that cellular work was going on, we started getting invited to ever more rural and isolated parts of the globe by people saying, look, we really want to put some technology in here, but we want it to protect our privacy. We want to protect, like, we don't want to just stick the internet in our community for a whole bunch of different reasons, right? So the kind of like theme of our work, the thread of our work over the years is more about communication than it is about the internet, right? There's a bit of like a tyranny of the internet sometimes, and I think it's important to try to push back on that. There's a lot of tools that have been developed that are part of all of the internet stack that we use, of course, but we try to not fall into we're just getting people connected to the internet. That's really not what we don't see that as our job, and that's not what we do. So we've been developing this technology. We're getting invited to these super far-flung places in the world, trying to set up these autonomous cellular networks, and it wasn't working well because there was too many trees, or the places were too far apart, or people were like, we don't want cellular telephones in our territory for whatever reason. So we hooked up and teamed up with a bunch of people who were working in the Amazon in Brazil, a bunch of researchers. And we kind of started by saying, well, we have this challenge with our cellular networks about how to do backhaul for our cellular network. And if we want to do backhaul, what that means is you put up the tower locally, you have your local signal and coverage. How do you get the information, a telephone call, a chat, whatever, out of that place back to wherever it can be interconnected to the rest of the network? That's the concept of backhaul. So what if we could do backhaul over HF radio? This was like the thing that sparked our interest and got us in touch with these folks in Brazil. Like, could we send an SMS? Could we send a text message from a local cellular network over an HF backhaul back to the telephone network? So we did that. We figured out how to do that, coded that, and that's kind of how the HERMES project started. Subsequently, we sort of removed the whole cellular piece from the HERMES work, and it's kind of its own standalone project at this point. So it's all open source. So our thing always has been, we do everything open, free software, open source software. If we can, hardware as well. Not always possible, but is a goal. And then I think the most important part for us is how do you get the technology to people that need it, that want it? So we've been working with a lot of different people in a lot of different places. There's some countries down here where we've done work. So again, a lot of my job and the folks on the team, some are developers, and some of us go and do trainings and bring technology to people that have asked us to come and join them. In the Amazon, of Brazil and Ecuador, so like deep in the jungle. We work with fishing people in Bangladesh who needed communication on their boats that go out way into the Bay of Bengal. We worked in Central African Republic even on a early warning system for communities that were being attacked by non-state armed actors so that they could warn each other when someone was coming. So that's just a handful of the places that we've worked and that we've done, but this technology is in use by people in communities for many, many different use cases and sort of types of situations. Okay, some technical stuff. I'm sure some of you will be happy about this. So this is a technology that's based on HF. So HF is high frequency, sometimes known as shortwave. If you want to raise your hand, if you're a ham or anyone who's involved in radio, okay, there we go, nice. What a surprise. Cool. Yeah, so some of the folks on our team are hams, some of us are not. I'm actually not. Don't hold that against me, please. But we, at a few years ago, realized that this technology was also super interesting for all of you ham folks out there, and have sort of created closer ties to that community as well, especially on some of the lower layer software that we're working on. But basically, the technical stuff is you need an HF transceiver, a radio of some sort, and you need a computer. Okay, normally we're using a Raspberry Pi. We can honestly use any other computer that we want. So we're taking the world of radio and the world of computers and smashing them together and making fun stuff happen over HF radio. We use UUCP. There's probably some older folks in the room that'll find that. Yeah, we'll get a chuckle out of people about UUCP. Yep, good old UUCP. And so it sort of acts almost like a BBS. It's pretty old school. again, we're not using the internet, right? We're passing digital information data over HF between stations, between radios. So we had to kind of come up with a whole architecture for how to do that. We didn't invent the concept of doing that, but we came up with our own sort of way to do it. And the purpose of that was to make it usable for everyday people that weren't experienced radio operators. So a lot of Hermes, well, it's all software at the end of the day, but a lot of it is software that's user-facing and just makes it easier. I want to send an email, I want to chat with somebody, I want to do whatever, just makes it a lot easier to do that. And I'll show you some screenshots in a second, but that's kind of the idea is I want to leave a message for someone, they're going to get back to me. That's sort of basic concept of messaging and exchange. So on each radio, there's actually a full email stack. So we're running like a complete email stack on every radio, and then you're able to do full email over Hermes if you want. And if you get to what we call a gateway station, which is just a Hermes radio that's plugged into the internet, it'll route your email out to wherever. So some people use, I don't know, WinLink or these other things. Those all work, it's great, but it's a little difficult for a normal person sometimes to set that stuff up. So this is all just ready to go inside of Hermes. We've also been working on, for the last like 2 or 3 years, the modem. And actually some of the folks that have supported us in that work are here from ARDC, so thank you for that. There are some open source modems. This is the modem, the thing that's, demodulating the signals. So we now have a fully open source modem that we can use. People are familiar with Vara. I don't know, see some heads nodding, a few. This is kind of a replacement for Vara that's completely open source. So this is called Mercury. You can download it, you can use it, you can do whatever you want. If you're interested in just that piece, so the Hermes stack is this full, it's got all this other stuff in it. If you just want the modem, you can use that. It's now working on Windows, Apple, and Linux, of course. So you can, if you go to mercury.hermes.radio, you can get more information about that, or if you just go to the Rhizomatica GitHub, all the code is there. And we'd love to hear from you if you're going to use it. And then, yeah, a bunch of different modulation possibilities with Mercury that I won't get too much into. So that's the technical stuff. This is a photo of one of the radios that we use. This is actually installed in a community in the Amazon of Ecuador. This radio, specific radio, it's sitting on a cabinet where there's a bunch of solar energy stuff. This radio is actually an open source hardware project out of India from a company called HF Signals. And they build a nice low power HF transceiver that has a Raspberry Pi in it, it has a screen in it. You can do PTT, which is push to talk. You can do all the Hermes stuff through the screen directly. And they're like $400. And you can buy them from HF Signals, which I encourage you to do if you want to play around with something cool. But you don't need this to use this radio with our software. You can really use any transceiver that has like a USB connection that can sort of be connected. You can also use an external sound card as well. That gets also like a little complicated, but you can certainly do it. And you just need to run the software on some computer. It could be a tablet, it can be a Raspberry Pi, it can be a desktop, whatever you want. So just, I just want to show you some photos, like photos of installations of radio equipment can be pretty boring, but just, we'll look at a few of them. So like that's, on the left, if you know about HF, that's just like a basic dipole antenna. It's just 2 wires, hanging out on top of a pole. Oops, there we go. And then here, like a lot of our work, as you can tell, is training people to use the technology. We're developing the technology, but we're also helping people implement it. So here on the right, we were in Colombia earlier in this year, and these folks are from a really incredible organization as an indigenous people's like Wardial. So basically they're like the local guard people for this whole indigenous territory where there's insurgents, there's government, there's a lot of crazy violence going on, and they're basically in charge of protecting the territory. So they asked us to help them strengthen the communication between all of their checkpoints that they have in their territory to keep all the bad guys out. So we're going to be implementing a Hermes project with them soon. And this is just us showing them what it is. So they said, look, we have this problem of how we put all of our checkpoints into communication with each other. They have some VHF radios that they don't have a way to program, and those are getting hacked by the bad guys, and so they're listening in on their communication. So we basically said, why don't we replace it, or at least create another more secure layer for you to talk over using HERMES. This is like one of the co-developers, Raphael on the left there. This is us. We were in Bangladesh. So again, this is like most of our work. That's not the development, is working with people, setting up these systems, training them about it, teaching them about it. And then they do what they need to do, and then they get in touch with us if they need additional help. This is a picture of what the interface looks like. This is gonna probably change soon, but it's just tries to make it, again, super simple for people. Press a button, it takes you to the thing that you want to do, you do it. So the usability piece and just allowing people to use this technology, which again has been sort of the domain of more experienced radio operators for a long time, is really important in terms of getting people to actually get value out of it that they want. So why did we do this? How did we do this? What are we looking for? And why did we sort of end up where we are? So we talk about these as the design principles. What were we trying to do? So as I said, we were working in super remote areas. So the issue of distance was really important to us. I'm sure there's a lot of people here that are playing around with Meshtastic, LoRa, all that stuff. Super cool, but that didn't have the range that we needed. So again, we're working in places that are sometimes very far apart from each other, and we needed something with distance. So I said minimum 100 kilometers here. That was sort of like the design goal. I would say almost all of the stations that we have go 300, 400, 800 kilometers between. Usually it's like more than we need, but it's nice to have the extra there. So long range, like actually long range. We don't want to rely on a satellite. There's no other network infrastructure of any sort around. And there's a lot of trees usually in the way, or mountains in the way, or all sorts of, geographical, topographical things that we need to deal with. So it needs to be able to go super far. That's one. Voice and data. We end up working with populations that are not always literate. So it's really nice for them to just be able to talk to each other. And this is a lesson we learned doing the cellular work as well, especially with the older folks in the communities. They just want to make a phone call. They're not texting. They're not chatting. They're just, I need to call my grandson. Great. Press this button and it works. So yeah, both voice and data. Low power usage for sort of obvious reasons. Again, a lot of the places we're working, there's no communication infrastructure, and there's generally no power infrastructure either. So we can't set up systems that use a ton of energy. So the output of the radios that we're using is like around 25 watts, and I think at max it's drawing like 9 amps when it's in transmission on 12 volts. So with a very simple cellular setup, solar setup, small panel, which are like harder to get than they used to be now. Everyone wants you to use these huge, massive panels. So yeah, one panel, one battery, one simple charge controller, and you got plenty of power for whatever you want to do. So the open part, of course, I already mentioned this. We just want it to be open. We want people to be able to use it, to people to be able to modify it, share it. We're, deeply in the world of open. So lastly, security. This is becoming also a more important part of the work. For those of you who, especially in this country, are ham radio operators, the security on terms of encryption is sort of a tough issue sometimes to unpack with folks. But in terms of where we're working, we do try to use as much encryption as we possibly can to keep people safe. And we're also not using ham radio frequencies. We're not in any way breaking any of those rules. So the thing with HF that's interesting, because of the way that HF propagates, which I'm going to talk about in a second, which might be repetitive for some of you, it's pretty hard to know where someone is transmitting from. It's more or less impossible to know who's receiving the signal. And then if you can also protect the actual payload, the actual thing that you're sending by encrypting it really well, it becomes a pretty secure way to do communication. So part of our work now is branching into, like I showed you, those folks from Colombia and other sort of like mission critical security stuff for social movements and other folks that are under attack for different reasons. So this is kind of how we got to where we are, why we're using this technology in the way that we are. Some challenges. So this is not without its challenges. The first one are frequency permits. Like I said, we're not using the ham frequencies. That's for amateur radio operators, not for the stuff that we're doing. So that usually means either the community decides to not get a license or not do a frequency permit because they don't care to, or that we have to go through some process in whatever country we're working in to do that. So, for example, we've had a lot of success with this in Ecuador because all of the indigenous nationalities were given an HF frequency years ago, so they don't need to apply for licenses. Or in Brazil, it's pretty easy to get one. But like the stuff we were doing in Bangladesh on the boats, took 6 months to get the permits. Thankfully, because of all the years of work on cellular and trying to get access to IMT spectrum and all these very, very valuable chunks of spectrum, we have lawyers and we do stuff at ITU. And like, if anyone can get the spectrum, not to brag, but I think it's us. Like we have a pretty good team that knows how to do this. So it's not always easy, but it is part of our work, and that's why we have the lawyers on the team and work with people locally who know about this to try to figure that part out. Like I said, there's some low, both digital and just functional literacy. So yeah, most of the people using this technology are novices. We get requests sometimes to like turn off a lot of the options of HERMES because they're even too much for users. So yeah, we have that issue that we're always dealing with. We're not dealing with skilled technical people most of the time. Importing equipment, that's always an adventure. I'll just leave it at that. And then expectations. So most people, if they're familiar with using a radio, they're kind of used to that part. Okay, I press the button, I talk, and then that's what it is. But this has this whole data part, this digital part on top of it or as part of it. So that sort of branches into this issue of expectations. What do people expect that to be like, right? And so if anyone's ever sent data over HF, especially on a tiny little 3 kilohertz voice channel, it's not the quickest thing in the world, right? So sometimes people are expecting, oh, we're going to put up this like magical HERMES system that's going to be able to pass data around and it's going to be instantaneous, and it isn't. It chugs along and it gets the data there. So it's not the fastest thing. So there's sometimes an expectation issue where it gets set up and everything's going. They're like, oh, this is like slower than we thought it was going to be. We said, well, yeah, there's some trade-offs. So those are some of the challenges that we have. I don't know. This might be like, what time is it? This might be too repetitive, but basically, just for folks that don't know, the HF band, right, is between 3 and 30 megahertz. People have been using these frequencies for a very, very long time to do voice communication and other types of communication. There's coordination in the band. I guess what I really want to say about HF from like a frequency and spectrum standpoint is there's some pretty well-defined users in there, and then there's a lot of empty space. I don't know why this turned off. Okay. There's a lot of empty space. So again, we're coming from an experience of trying to get access to cellular, 2G, and LTE spectrum that's hotly contested, and people spend billions of dollars on accessing for however many years, depending on your license. HF is like a little more of a, I don't know, it's less used. There's huge open spaces in the HF band that are available. So what ends up also happening is that when we talk to regulatory authorities to get a permit, they get a little confused sometimes. They're like, wait, but you're not amateur operators, but you're obviously not the Army or like an airline or the airport or whatever. Like, what are we supposed to do? And then they got to go find like, oh, what are the existing assignments that we have in the band? And there's like some old guy who doesn't come into the office anymore, who's the only one that knows, what are the actual frequencies or even how to do the licensing. So yeah, it can be a bit of an adventure, but that's what these frequencies are, 3 to 30 megahertz. So like right above the AM band. And those have this nice property, which is why we use it, which is skywave propagation. Again, this might be repetitive for some of you, but if it isn't, the really cool things about these frequencies is that, like we said, we want this long range. So we kind of got into a situation where doing line of sight communication, where one transceiver has to be able to see the other transceiver, was not a doable thing in the cases that we were working in because the territories were too big or there were things in between. And maybe the community didn't have money to put up a 60-meter tower, and et cetera, right? So we needed a way to basically get information far away, and that's where this skywave propagation. So in these frequencies at certain times of day, depending on the frequency, we can bounce off the ionosphere and kind of go pretty far, which is great. Again, we didn't invent any of this. This is something that people have known about for a really long time. But we're trying to take advantage of that in the situations that we're in. So where are we headed? This is like the next stage of where we're headed. Some of this, I don't even understand actually what some of this means because we're just coming up with it now. And the tech guys on the team gave it to me. But basically what we're trying to do is create, right now we're essentially doing station to station communication. We can do some broadcast, but there's a whole like layer of stuff that doesn't really exist in HF that would make it, that's why we're using the term Wi-Fi, to try to like imagine if we had all of the other pieces of the stack in place, addressing and all this stuff where we could like essentially mesh between different HF networks and route information in different ways. So this is what we're going to try to be working on probably starting next year, early next year. Right now we're finishing up a lot of the encryption work that we want to do, and then we're going to move into this. So yeah, trying to use like state-of-the-art stuff to do, like for example, the Raptor Q fountain codes for broadcasts. A lot of this is again super technical, but this is where we're going. If you're interested, we can talk more about it. I'm not super conversant in all of it. This one at the bottom, if any of you are familiar with Reticulum, we're also looking at NNCP. So I was saying we use UUCP. We're going to replace it with NNCP, which is very similar, but has way more security in it. Way more, it's encrypted, right? So that's where we're headed. We're going to continue working on this stuff. Like I said, we have the stuff that we're doing that's for the communities we work in, and then increasingly we also are working a lot with the amateur radio community on stuff that they're interested in. So it's kind of like these dual things that in our theory will support each other moving forward to kind of move the thing down towards ever better technology, increased usability, faster, more safe, and all of that. And then, yeah, like some of this more conceptual stuff, like how would we organize a bunch of these different networks together? So that's where we're going. Yeah, we're really excited. We have a great team of folks, most of whom are in Brazil doing all the coding, who have been part of the team for many years. And yeah, as far as we know, we're not going anywhere, and we're going to keep working on this and exploring all the fun stuff that that HF has to offer. So just like a quick little note, back to the regulatory piece. Like I said, we have some of these challenges. If we could do this, this would make our life easier. So one of them has to do with the expectations piece. Most of the time when we get a permit or a license, it's for a voice channel, like a tiny little 3 kilohertz voice channel. Right, so if you think about, I don't know, Wi-Fi, those channels are, 20 megahertz wide. We're talking about 3 kilohertz. So it's a very tiny, tiny little pipe that we're trying to send the data down, and it takes a while for it to pass from one end to the other. So one of the things that we're hopefully going to work on is convincing regulatory authorities to make it easier to, probably we're not going to be able to change the size of the channel, but rather allow us to bond channels together and sort of get contiguous channels right next to each other so we can do that, and that would increase the throughput of the system substantially. This other one, licensing frameworks that allow multiple HF subbands. So another thing that happens, as again, amateur radio users will know, there's times of the day where a certain frequency is working great and times of the day where it isn't. So what we'd like to build into the licenses is just to say, hey, we want to be able to use 2 or 3 different frequencies depending on the time of day. We actually got a license like this in Mexico for a project that we have in northern Mexico. So this would hopefully be like a test case that we can then prove to other regulatory authorities why this is important. And again, it's like, okay, you're going to give us 1 3 kilohertz channel. How about you give us 2 3 kilohertz channels and 2 different frequencies? It's not a huge ask, right? They're just sitting on tons and tons of spectrum that no one is using and no one is even asking for. So it's not a heavy lift really to say, hey, why don't you just give us like a smattering of different frequencies and different bands? And well, then there's the creating a spectrum commons and HF bands for civilian use. Yeah, we've made some efforts to talk more to the amateur radio folks who work on spectrum without too much success, honestly. But just thinking about, again, like in Wi-Fi, right? Wi-Fi has such high adoption, or even some of them, like there's unlicensed frequencies, right? So what if we imagine a world in which there's some unlicensed frequencies that people that are setting these stations up can use as if it were Wi-Fi? Now, again, the range piece introduces some issues into that, but this is something that we're trying to explore as well, just so that it makes it a little easier and these technologies can get into people's hands and they can use them without having to go through a whole regulatory circus. Yeah. So that's that's kind of where we'd like to see things go beyond just the technology. And I'll leave it there. And if people have any questions, now's the time. Thank you. Okay, why don't you go first? Go.
First one is for a particular region, what's your ratio of the HF stations to stations that's connected for
Sure.
Oh,
sorry. Do you want people to talk into the microphone? Sorry, there's people I think watching online, and I think they want us to. There's a microphone. Yeah. Sorry.
This first question is about the ratio of these stations, and per particular region, you've got a bunch of, I imagine, these remote stations. How many of these are gateways to the internet? And
Sure.
the second question is, I showed up here. My personal interest in your talk is due to like an overabundance of caution about potential disruptions to communication networks here in the United States. And I'm wondering, obviously, there's a lot of like licensing and issues that you just brought up. I was wondering how well you feel your project might apply to that kind of a situation in the U.S.
Sure. Yeah. So for the first question, the answer is it depends. I would say the biggest network that we have, that's like 90 stations that are all connected to the same gateway station, but most of those don't ever do data. They're just doing push to talk, and they don't need to go through the gateway station to be able to do that. So that would be the biggest one. I think the most we've ever had are 2 gateway stations for a single network that maybe had like 15 remote stations. It really depends. Again, so like part of it is based on the architecture, right? So like if you want to pass a message from station A to station B, like a data message, a digital message, most of the time we're setting it up that it's going through the gateway and then going back out to coordinate. Now, the main reason that we're doing that is a spectrum and a frequency thing. Like if we have one frequency and we have 50 stations, they're all using the same frequency. So we have to set up our own essentially like spectrum coordination thing whereby they're not interfering with each other. So in cases where we're not worried about that, messages can just go between stations. And the only reason you need to get back to the gateway station is if you're trying to get back to the internet somewhere. And otherwise, you don't need it, right? So it depends. Second question. Yeah, I mean, I think that there's already a very robust amateur community in the US, all of whom can use these same exact, like this is all, to spec for any amateur use. You can just turn off the encryption piece pretty easily. So that would be, like, if you imagine everything falls apart and turns off, people that already have radios, that already know what they're doing, are the most likely to probably pick up the slack. In terms of implementing something larger than that, I think what would be interesting would essentially be like HERMES repeaters stations in certain, geographical areas that people just could bounce signals off of and use. So we're thinking about doing that in some parts of the Amazon, actually. We mapped it out, and even for like the Brazilian Amazon, which is, I don't know, like half the size of the US or something, we don't actually need that many of these repeater towers. And then there's just a gateway, like you don't need to set up your own gateway. You can just use, an existing gateway that's within range of your station. Yeah. Oh, there's like a lineup by the. Go ahead, sir.
Is this a little bit of silver lining to the decline of shortwave broadcast stations, that it's become, do you find it much easier to like get channels in these bands, whereas previously, I can imagine previous decades, it would have been a much harder tilt? But is this something you're seeing that, governments are willing to give up allocations in these
Mhm.
areas?
Not I don't like, again, even if all of those broadcast stations were still on the air, there's still plenty of room. So it's not a huge that's not a huge piece. Actually, what we're most interested in is using the broadcast stations to repeat. So we actually did a pilot, this was a long time ago, with the Brazilian HF station in the Amazon. So that would be a really cool gateway if we could use that with their, football field antenna arrays. So that's actually where we'd like to see things in terms of the broadcasters. But no, in terms of the spectrum and stuff, it doesn't really make a difference.
Great, thank you.
Thanks.
I've got a question from Suborbital on the Matrix chat. They say, thanks, Peter. So interesting. Could you say something about capacity for multiple calls, etc.? Are there congestion or jamming issues?
Mm-hmm. Yeah, so we talked a little bit about that. One of the things that we want to do in this is to try to deal with that issue. So again, if everyone's using the same frequency, there's going to be congestion and interference issues, just based on how radio works. So if we have more frequencies, we would be able to coordinate that better. But like I said, what we try to do is more like through scheduling. So saying, why don't these two stations will sync each other at this time, and we can actually in the Hermes interface from the gateway station, you can set up schedules and pretty like advanced scheduling, saying, okay, you're going to sync with this radio at this time, and then it just kind of like does a round robin and goes through all the stations and synchronizes to try to avoid that issue. But again, if everyone's using the same frequency, it's the same. If everyone comes on and starts talking at the same time, they'll just be talking over each other. Now, with the modem that we've been developing, if we tune it enough this is going to take some time. We're hoping that we'll be able to use different sort of more modern frequency division type stuff, whatever, time division, to be able to fit multiple concurrent calls onto the same frequency in a better way than we can do now. So yeah, we're definitely interested in moving forward on that.
I had two questions. First being, maybe you could speak more about importation to the U.S. Like, I'm an amateur extra. I can modify radios and sell like a ham radio to another amateur extra. So the FCC limits, who can have a radio or test it kind of that way. So I was wondering if you could speak to that. And then secondly, I just wanted to know at least briefly a little more about the power requirements of the radios.
Sure.
Whether, storage, batteries, something like that.
Yeah, so I shared this radio. You can see them on the desk there. This one. Again, this is a product that's made by another entity that isn't us. We just use it because it has everything that we want in a convenient package and it's inexpensive. So again, if you already have a radio, you just need to hook it up to a Raspberry Pi or a computer, and you can do the same thing that we're doing with probably much better performance than these low power radios. So I just imported 3 of these to the US last week, and I'm going to take them back to Mexico with me and then import them into Mexico. And at least for now, so there was the current administration in the US was supposedly getting rid of something called de minimis, which was basically if it's under a certain value, you don't really have to pay any taxes or duties on it. And I was expecting that when these radios came in, we would have to pay something, but we didn't. So the guys in India just stick it in a box with DHL, and then it just comes. And if you do need to pay something, you just do that with DHL. So the second piece was about power requirement.
Yeah, I think I'm more interested in the power draw. And
Sure.
What kind of battery you might use with it, because the infrastructure might not be there.
Sure. So yeah, one of the things
power.
that we liked about this radio as well, and most radios, honestly, they use 12 volts, right? So it's not that difficult to get a 12-volt battery. And most places, you can either schlep it there, or they already have one, or whatever. So even if you're just in a really bad situation, just connect it to your car or whatever. So it's 12 volts. And these radios, I think in listen mode, draw maybe an amp. And again, they're usually in listening mode. And then if you're transmitting, I think it's peaks out at 9 amps at 12 volts. So it's not massive amount of of energy. And again, I think this is where we get back to expectations too. It's like, well, how many minutes a day are you actually going to be transmitting something, right? And so again, most of the folks that we're working with, they're busy. They're not, their relationship to the technology and the relationship to communication technology isn't like everyone here who's on their phone every waking moment, including when they're in the bathroom, right? So the use of the system is generally less. It's not like 24 hours a day, someone's on there doing something. It's, we went out hunting and we came back in the afternoon and we're going to call the other village to see, you know, what's going on. So the power requirements are more about the amount of time that the system is being used versus how much it actually draws, right?
Thank you.
Cool. Yep.
Hey, thanks. Awesome talk. Another maybe more technical question. If you're not the right person, I can follow up. I'm curious. It looks like it's from an antenna perspective. You know, one of the challenges I know people have around like 6-7 megahertz is that you can't get local. Like you can only get stuff that's 100 kilometers away. And so I'm curious, like how much work you all have to put into sort of the topology of these networks of like, oh, I can talk across the Amazon, but I can't talk to the village next door.
Yeah.
And like how you handle that, or do you combine with like VHF and HF or any kind of thing, or like that? How does that work?
Yeah, so we're usually doing something called NVIS, which is near vertical incidence skywave. So instead of bouncing off the ionosphere at a certain angle, you're essentially, it's like shooting a gun straight up in the air. And so we're usually doing that. And yeah, I think honestly, the issue with the antennas is how much room that they take up. That's, yeah. So like when we work on boats, for example, like the project we did in Bangladesh, I didn't bring a picture, but these very large wooden boats, and it's like right at that absolute limit. Like it just goes all the way across the whole entire boat, this antenna. What I will say that's nice about antennas in general in HF, unsolicited, is they're really easy to make because of how big they are. So you just go to the hardware store, buy some, you know, electrical wire, some cable, and you can pretty much make an antenna out of that pretty easily. So what we do work on with communities is a lot of like how to make your own antenna and then how to test your antenna and make sure it's okay. But the actual making of it is quite simple. So it's very easy. There's no soldering most of the time. And sometimes I think, I'm not sure if it's in there, we use like a really nice antenna analyzer so people can see the SWR and all these different parameters on the antenna and play around and see how it works.
Fantastic work, really inspiring. I had a related question. Have you experimented at all with linking HF with UHF and VHF? Because, you know, channel bandwidth is much greater and you get higher throughput and get closer links. Have you worked at all with
we haven't. I mean, this comes up a lot, especially in conversations with hams as well, like getting this all to interoperate somehow. That is not, I wouldn't say it's not on the radar, but it's a little further down the road. Again, just because of our specific use cases don't generally involve those other technologies. They could, but I think it's something to explore, but we haven't cracked that yet. But yeah, it's definitely on there. I think we're doing a little bit of integration with LoRa right now, just to get that to sort of have like extend the range of the local radio with LoRa or LoRaWAN or whatever we end up using. So people can connect to that and then use the HF to bridge. So thinking about basically what you're saying, kind of like using the HF as the backhaul, getting back to our like original thing that we thought about. But what does that local network look like? And our original conception was the cellular stuff, but yeah, maybe it's a VHF network, maybe it's a LoRa network. So yeah, we're trying to get there.
Thanks a lot.
Hey, do you use have you looked into using any of the techniques used by LoRa on HF, and what's achievable within ISM or unlicensed bands and within, you know, legal, unlicensed, effective radio power?
Yeah, I guess I don't think I'm the best qualified to answer that exactly, but there's some technical challenges with doing that. But I can ask someone on the team who could probably better answer that for you. I think right now, like I said, we're trying to bridge between them, but not like bring them inside necessarily of, but just have a way for them to talk to each other somehow.
And how much range can you achieve without any licensed bands, just using ISM bands? I know there's a 13.5 megahertz band, for example.
I'm not. I don't know. I mean, I don't. This is the same range as any of the other frequencies, I would say. Yeah. Does someone else want to help me answer that question? I'm not totally sure if I understand your question, to be honest.
Like what? Still be line of sight. Okay. Yeah, that's I was curious if it's possible to what you can achieve without having any without having to get a license.
I see what you're saying. Just because you're like maintaining a yeah. I don't know, to be honest.
Yeah.
Okay. Sorry.
Hey.
Hello.
Yeah, great project. Got a few questions. I'll just ask one. I don't want to hog the mic.
Okay.
I think I'm back at the queue anyway. So you mentioned frequency schedules. So the HF band is relatively predictable. In day night. If it's daytime, I might use the the higher end of HF. Nighttime, I might use the lower end. There are some occasions where the band closes and it's just pants. So if you're using it as a real-time sort of live warning system, is there any sort of resilience built in? So if I wanted to get a message to my mate Dave, someone's come and hit you with a bat.
Right.
If the conditions are closed, Dave's probably going to get hit with a bat.
Right. Yeah. So I didn't put this on here, but yeah. So there's one major thing. If there's like any kind of solar stuff going on, a lot of these frequencies get knocked out. That happens. It usually doesn't last for that long. Yeah, nothing's perfect, I guess is the short answer to that question. Now, again, how would you? This is like coming in this next work that we're doing is a little bit about that. Like, okay, I'm going to try you on a bunch of different channels at the same time. And then we're going to figure out what the best channel is for this moment. And we're going to talk on that channel. Again, like the technical piece of it is solvable, but then you get right back into the regulatory piece, which is at a certain point, probably, unless we create this commons that we want to do, there's going to be a defined, even if it's not just one, it's going to be a defined set of frequencies. Sure. So if for whatever reason those are all out at the same time, yeah. Now, again, what you have to understand is, and I'm not like condoning this per se, but we work with a lot of communities that don't give a shit about any of the licensing stuff, just to be honest. They're like, we're out in the middle of nowhere. No one helps us do anything ever. And like, frankly, there's some guy in the Capitol who's like pissed off that but like, so we show them, we're like, look, scan all the frequencies, see where there's stuff, and don't use those frequencies. Like, as long as you're not interfering with anybody, that's already a good step. And so sometimes they want to test it out first before they go and get the license and all that. So again, since this project is about autonomy, that's like our thing that we're interested in as an organization. We're very tolerant of people having different views upon that, but understanding what the risks might be as well.
Sure. Okay. No, that's cool.
So,
Thank you.
yeah.
Sorry for the negative.
No,
questions.
not at all.
This is the British way.
No. Yeah. Yeah. I mean, again, nothing like you brought up the word resilience. I think that's a great word, right? I think it's a great concept. And I think that the folks like us who build networks in these very challenging places, that's always front of mind. And everything we do has to be resilient in some way because things are always breaking. It's just like this constant churn. So how do we make our networks more resilient? This is like a thing that we work on all the time. Because I mean, like insects crawl into I mean, it's just like never ending challenges. So, in terms of our infrastructures and our networks, we also need to be thinking about resiliency. So again, like the internet for me feels like a pretty, on one hand, very resilient network, but on the other hand, very vulnerable network. So if we have, layers and different architectures and infrastructures, that will automatically make us more resilient. And so, yes, there will be moments when HF just gets knocked out.
Thanks, mate.
Mm-hmm.
Cheers.
Thank you.
Okay, so I've got one question in the chat, but before that, we're basically at time. So I would encourage
2
anyone
minutes.
else, if they have questions, to write them in the Matrix chat or catch you after the talk. And Peter, I can set you up with the Matrix chat if you would like to field some other questions. But the last question we have is from SysOp in the chat. Thank you for waiting patiently on this. I'd love to run a local Hermes system in the hills of upstate New York. What would I need to get started, and where can I go for more information?
Great. Okay. So you can go to hermes.radio, which is a website, and you'll find the information you need there. You can also drop me an email. That's up on the screen here, peter@rhizomatica.org. And what you need to start is a radio. Ideally a radio that can easily interface with a computer. So there's many modern HF transceivers. You can just plug a USB into the back of them, and some sort of a computer. Whatever that computer is, doesn't make too much of a difference. So that's it. That's all you need to start. And we can, hold your hand for the rest. Cool. Thank you.
one of those USB-C. Hello, everyone. We are crowdsourcing USB-C HDMI dongle. If anyone has one in their bag, we would love to use it for an hour. Thank you very much.
Oh my goodness! Look at this.
Excellent. Okay. So for those watching the live stream, due to some technical difficulties, we are going to be unable to share the presenters' slides in the stream. But we will be speaking with the presenter to get those watching virtually the slide deck to follow along after the talk. We apologize for the inconvenience, and take it away.
Thank you so much. Thanks, guys, for waiting. Technical difficulties, but we're getting there. Thank you so much for spending this afternoon with me. I want to talk to you guys today about humanity's oldest technology, our language. And the book definition of language is that we convey information to each other. But language can be used in many different ways. We use language for expression. We use language to build relationships. We use language as to clarify our own thought. We use language for play. We use language for mental activities. In essence, we use language to do things. So in a way, I can reframe that we use language to accomplish our goals and to express intent. With this, it's kind of a little bit surprising that we have so many languages. And it's a very old story about how we had many, we used to speak one language, then we decided to construct a Tower of Babel, and then we've upset the god, and humanity was not able to accomplish something together because now we were speaking different languages. But it also captures, what I like about this story is that it captures something very human to us, that in order to accomplish things, we need to have the ability in order to express our intents in a very clear way. This is a book by Konrad Gessner. It was written in 1457, and it's one of our earliest documentation attempts to document various languages. He captures 55 languages. He also mentions invented languages of birds, and he also speaks about humans who speak two tongues at the same time. But what is very interesting is he tries to become very systematic, and he tries to get to a proto-language. He arrives to the conclusion that Hebrew was one of the earlier languages as a foundation, but he's trying to get to the more ground truths of what is actually becoming our foundation for expressing the thought. He's not the only speaker, he's not the only thinker who is trying to get to the essence of a universal language. Here works of Raymond Lull. He was living in Mallorca in 1300 something. And he invents a system in order to convert non-believers to Christianity. And his issue was that those non-believers spoke different languages. And he's like, well, can I create a system in order to convert them to Christianity in a way where it's very easy and accessible and understandable for them? So he's tinkering with this new way of expressing reasoning in a different way. Then, not long after him, Nicholas de Causa in Constantinople publishes a work, De Pace Fidei, and he's also tinkering with an idea of how can we express truths while allowing for this variability of different languages. After him, John Dee, not long after, in 1564, publishes Monas Hieroglyphica, where he's trying through the harmony of symbols try to express and unite ideas of astronomy, geometry, and theology using simplified notations. So all of them are trying to kind of grapple with this thought of a universal language, but from very different systems. Giordano Bruno in 1582 uses new combinatorial methods, kind of extending on the Lull's work of a universal system for organizing knowledge, again, allowing for variability and ambiguity of human language. Athanasius Kircher publishes in 1679 Turi's Babel, and he's trying to get back to the discussion of a proto-language. As I've mentioned, Lal creates this theory that Hebrew was a foundational language, but around that time, it's extremely fashionable to discuss Egyptian hieroglyphs as being the proto-language. So a lot of thinkers are kind of going down that way, and Kierkegaard is kind of leading the pack with a lot of his theories. And then we get Leibniz with his Arte Combinatorica, who kind of turns it around and he says, well, instead of us looking for a language kind of to rule them all, can we make reasoning itself a language and kind of reframe how do we frame thinking and how do we frame the arguments? I want to come back to Kierkegaard. I can talk about him for a really long time, so find me if you really want to geek out on him. He was a 17th century German Jesuit. A lot of people kind of tagged him as a polymath who knew everything and was wrong about everything. He published more than 40 books on various subjects, and he gets things in a completely wrong way. This is his unpublished manuscript. It's called Novum Hoc Inventum Qua Omnia Mundi Idiomata ad Annum Redundum. And he's talking about a new invention where he's trying to unify languages to one, but just using symbolic notation. And as we're looking at how people are approaching this, the thinking, it's definitely, and we're definitely heading to a way where we're trying to throw out and to eliminate words. And the man who finally brings this up and packages this idea is George Boole. In 1854, he publishes the work of The Laws of Thought, and it marks the moment where this century-long search for universal language becomes a universal symbolic notation for reasoning. He is producing this work in the time in Britain where everybody is very fascinated with mechanical machines, with automation, with the way of simplifying and mechanizing a lot of the things, including thinking. Mathematics is undergoing transition, philosophy is undergoing transition, and his work asks us, can human reasoning be written as a symbolic system governed by precise rules? And of course, we can answer absolutely yes. We, instead of one spoken language, humanity then begins to invent specialized notations. We have mathematics, we have musical notation, we have chemical formulas, we have botanical names. We're not replacing the language, but we're extending it, because each notation is designed for a specific purpose, and it becomes a very specialized way to express ideas that ordinary language is struggling sometimes to express, especially if the speaker doesn't have the ability to do that. If we're going to look at the examples of when we are using human languages, or when we're using notation removes the words that explain an idea and keep just the marks that are required to express something precisely. In a few symbols, we can replace entire paragraphs. Good notation doesn't necessarily save ink, it saves thought. It makes us much more efficient. And the man who actually made a talk about it is the inventor of APL in 1979. Kenneth Inverson first gives a talk during a Turing Award, and then he publishes this beautiful paper. I would encourage you to download a PDF if you want to read it further. And he titles it Notation as a Tool for Thought. And his statement is that programming, he's talking about first about how mathematics and mathematical expressions are help us think in a different way, and then he extends this to programming languages. And he's highlighting especially two properties. One is executability, so not only can we express things, we now can run them, and unambiguity, because we have to be very precise to make the machine to do the things that we want to do with it. He uses the APL to demonstrate some of the examples and to construct the proofs. And if you're following the reasoning, because I took you on a journey from the Tower of Babel through the human languages to George Boole and to all of these discussions, we're arriving now that's something unprecedented that is happening in the 20th century. Is those ideas around the universal language and those ideas about notation are kind of meeting in this perfect combination where we need to instruct machines to do things that we want them to do. On one hand, we using the language-like form to express intention. On the other hand, we're also using notation to be very precise and to be extremely economical about it. Once we solve that problem, though, another interesting thing that is happening is very similar to human languages. Programming languages are also expanding. So now instead of just having one, we're getting many. If you will look at the timeline, as the genealogy of human languages is kind of resembles a lot the programming languages. There are families, branches, shared ancestors. Some languages disappear, others become enormously influential. Unlike English and French, the programming languages don't evolve by accident. They evolve because someone thinks that, you know what, programming can be done in a better way and invents a language. Every language is trying to tackle the problem from a different way. And but just like human languages, there are people behind those languages, and the language reflects the method of how we're approaching the thinking and packaging the problem. The languages are created because of specific needs, whether it's businesses, universities, or the communities who are utilizing them. So I want to take you on a brief history of computer languages. For some, it's going to be a wonderful journey over the past. For some, it's hopefully going to be a little bit nostalgic. But to do this, I don't want to just throw code at your face. We're going to use a wonderful problem of a task of finding the brightest star, a small data set, and we're going to go over just languages just to see how different languages tackle the problem of searching for a star. I'm not going to, since we spoke about George Boole, I'm not going to show you the ones and zeros. It would have been too cliche. So we're going to start with assembly in the 1940s. The assembly language tries to give us an opportunity to give more, to avoid writing machine code, but doing it in a way where we can start referring to specific statements of moving instructions through the memory. In the 1950s, we finally get the first version of high-level language. We're getting Fortran, that stands for Formula Translator, and the initial one, the initial release had 32 statements, and we get such concepts as if, do, and go to. We're also getting a slightly better way of dealing with the data types. And it's actually extremely interesting that for more than 50 years, while we're undergoing so much innovation in how we're dealing with devices, Fortran still remains a backward compatible language back to the original. In 1958, John McCarty creates Lisp, that stands for Lisp Processing, and in order to accelerate some of the work around the artificial intelligence research. And the way Lisp differs from other languages, and you can see it very clearly on the screen, it starts dealing with lists, and that allows us to encapsulate information in the parentheses that is very easily displayed. Just a year later, we're getting ALGOL, algorithmic language, a language for specific scientific notation. It's widely used by American and European scientists. And ALGOL is worth showing because, again, it's catering to a very specific audience that enjoys reading the language in a very specific form. But we also can start seeing a very grammatical skeleton that is going to influence later on generations of other programming languages. For those who did not want to work in science, they rightfully called out that all of those languages lack input and output. And the work that was done by Grace Hopper and her team and Remington Rand Corporation first introduces Flowmatic and then introduces COBOL, where the language starts looking a little bit less like a mathematical notation, but starts introducing words, human words, where we can, where non-technical users can start operating, can start using machines for their needs. Also in a rebellion against just science community using the languages, the BASIC arrives in 1963, and it was designed initially for students. The language becomes interactive. It provides you with a much more immediate feedback. You can learn immediately. You can run and see what is wrong with if something is not working. And this simple feedback loop inspires a huge generation of all the other languages. In the 1970s, we see major development in programming languages, especially it probably starts with the language that is held for the next 50 years as a gold standard of what computer language should look like. C is what our world is currently kind of running. We have Unix, we have operating system, our compilers. It's close enough to the hardware, but abstract enough for us to write and operate in it. Developed in 1972. It's nicely named C because its predecessor was called B, which I always find is an adorable way of naming nomenclature, why we name things and how names come along. Around the same time, in Xerox Spark, Smalltalk arrives to the scene. It's a pure object-oriented language. It introduces a concept of us thinking of working with objects. So now if I package the information, if I package my data into an object way, I can call this object and interact with an object. So the different way of communicating with a machine. If the object exists, what else can I ask them to do? 1970s introduces another major language, structured query language known as SQL. We still use it heavily today, but I want to call out how beautifully and elegant this is. Like, I hope that looking at the screen, you guys can see how in just a couple of lines, just going back to see in just how nicely packaged it allows us to parse through the information, and it provides us with a different way of looking at working in the data structures. I'm going to speed through 1980s because that's the time when a lot of the programming languages, no new major paradigms are introduced, but a lot of existing programming languages are undergoing consolidation. And I kind of want to zip into the 1990s that obviously introduced internet. And with the arrival of the internet, we see the appearance of the languages that can now exist in browsers. So they start leaving specific machines and they start living on the internet. JavaScript is the language that reversed our constraints on the machine, and it's the language that started traveling in a short period of time to billions of people. Every web page became a program, and it's very interesting that JavaScript dominates our software, not because it's particularly beautiful, but just because it's so particularly simple and it lives in our browsers. No talk about programming languages can go without Python, especially right now. The readability of this language is striking. As I'm going through the slides, I hope you guys can get an appreciation of how easy it is to read, and of course, it becomes currently the language of science, education, and AI. We write so many things, and it's extremely readable. And as we move kind of in the early 2000s, and we start, our language needs to start working on various devices in different forms and shapes, we obviously get a whole long tail of other languages that are coming in, where we need to rethink and refactor on how we call hardware and how we prefer to articulate those things. in the end of the day, every language finds serious, but what changes is how we instruct the machines to do this task for us. And looking at the timeline of how those languages appear, it's easy to think that there is a competition, but in the end of the day, what happens is that languages become much more collaborative than competitive. Every generation borrows ideas from the previous one. Human languages borrow words. English borrows things from French, French borrows things from English, we steal from many other languages at the same time. Programming languages borrow concepts. Programming language can introduce a way we think about things, and then 20 years later, it can appear in another way of working. So in an essence, the history of programming languages is really the history of moving through ideas in terms of how we think about data structure and how do we think about working with knowledge and our ideas. If I had to recompress the history of programming languages in the 80 years of working with programming languages, I would probably choose this slide because it highlights that in the end of the day, programming languages are just a different way of thinking. Recursion changes how we think about repetition. Object change how we think about systems. Static typing changes about how we think about correctness. So it's just different approaches of just thinking about thinking in a way. Of course, all languages are not created equal. Just the same as it's happening with international communication, there are a handful of programming languages that dominate modern software, and together they account for an enormous proportion of software that we interact on a day-to-day basis. And then there is a long tail, hundreds of languages, some built for a specific industry, some built for a specific project, and some built just as an experiment. But I do want to highlight that popularity is not always equals influence, and I think we intuitively know this, but I think that seeing this as where, for example, alcohol isn't particularly popular today, but almost every modern language inherits its grammar and follows its rules, so it's always fascinating to see how the ideas just travel across time and manifest as we kind of trace back the systems that we're working every day. People who use code always like to have a discussion of what's the best programming language to use. And to me, it's a wrong question to ask. We shouldn't be asking if microscopes are better than violins. These are different tools, different mental tools. Every language is a compromise, and every language either chooses to become easier or it does other things harder. The question is what we're trying to do and where we are ready to achieve a compromise. And that's why we have hundreds of those, and it's beautiful in a way. A lot of languages that we use day to day are about solving problems, but we also have this beautiful body of esoteric languages. In fact, I think that there was supposed to be a talk right after this by Daniel Tompkin, who maintains the esoteric languages blog to document all of them. Unfortunately, I don't think that he's coming, but I do want to maybe capitalize on some of his work and highlight that the esoteric languages occupy the same space in programming languages like abstract art in painting. It's a very particular category that we use to experiment with around the provocative ideas. The languages are not necessarily practical, and we're not going to use them in order to achieve software, but those languages are used in order to entertain and explore ideas. And I just wanted to highlight certain favorites, obviously the ones that are being highlighted if you're going to Google for isolangs. But quoting Daniel Tompkin, the ambiguity of human languages is present in code, which is never fully escapes its status as human writing, even when it's machine generated. we bring to the code the access of our language. Because when we write programming languages and when we write with the programming languages, we bring our biases, we bring our beliefs, and it's the reason why I wanted for us to have this overview. Is just always fascinating to see why certain things happen a certain way, because there are always some humans behind the creations. Which brings us to a very interesting point in history, where after hundreds of languages, thousands of ideas, and millions of programmers, for the first time, humans may no longer be the primary authors of code. AI is increasingly generating the programs, and it raises very interesting questions. This is a talk that I think took place 1 or 2 months ago. And for those of you who can't see the title, it's Should AI Engineer Still Read Code in 2026? And to tell you the truth, I found the question to be very relevant and extremely provocative, and I really find it fascinating, because as I was preparing for this conversation with you today, it's on one hand, we have all these languages that reflect the way we think about problems, and on the other hand, the introduction of AI makes the work with computer code so much easier and accessible, and it definitely is accessible to a much larger volume of people. So on one hand, we are at this beautiful time of accessibility. On the other hand, it's fascinating whether using human language can we really understand the intent and really control and express this intent if we're writing with a code from scratch. This is another talk, and considering that we were a bit late, it's another video that I found interesting. It's titled "Reading Code is a Thing of the Past. Do this instead." And what I find is that the speaker for 30 minutes talks about how easy for him is to generate code, and then he stops in the middle around minute 8, and he says, well, if you're writing code to control any kind of machinery or that is going to interact with any kind of humans in a meaningful way, do not use generative. And he's bringing an example of like airplanes, medical devices, like basically things that matter. And you're like, oh, that's wonderful. So again, I think it's a fascinating time to explore, because does it make our job easier? For anybody who's writing code right now, the rate of production, we can't deny that it's so much easier compared to the past. On the second side is, do we really use now language as this thinking device of what we've discussed, with notation being a tool for thinking, computer language being a tool for thinking. I found this diagram from 2018, where the statement is that for people who are working with computer code, we spend so much more time reading code than writing it, because software is, in essence, a conversation. And that's what the argument this paper makes, that in the end of the day, every programmer is just trying to explain an idea and an intent to a machine, to his teammate, or to himself. And every programming language becomes a different way to express this intent, and it becomes almost a way to refine your ideas, and learning a language becomes a way to frame the ideas. And obviously, we become better programmers by reading so much other code. So if we're looking then back, for the last 70 years, I hope that we can and when I say we, I mean we as humans, and we see that programming languages are not just the curly braces and semicolons. It's the way how we try to frame certain problems and approach the resolution. I'm really wondering if how the production of modern software and also the way of working with various devices is going to be impacted. I found this image of a book that was published in mid-60s. I found it extremely ironic that it had the Tower of Babel on its cover, and I found it extremely adorable since we started the conversation with the Tower of Babel, and then for many centuries, humans tried to find the universal language. The search for universal language got them into the place where notation was a much more economical way of dealing with notation, and then we're back of using human languages, various human languages, in order to get to a different way of thinking. So. This is, I know that a lot of you guys are coming here today to have a conversation and to percolate on different concepts. So this is just, I feel like, is a very relevant idea for us to percolate on in terms of what do we use as mechanism for thinking, what do we use as mechanism for interaction with our numerous devices, and how does language help us to achieve those things. If you want to talk further, here's my email. Just email me. I would love to geek out with all of you because I don't have answers to this, but I hope you've enjoyed this tour across our collective history. So thank you so much. Do we take questions?
If you're able to send me a PDF presentation,
Yes.
I can put it in the matrix.
Yes.
I don't know if we're able to do that and field questions at the same time, but
I'm going to multitask.
okay, perfect.
Just give me your email.
Yeah, so it's whenever you're ready.
We're going to try and send the PDF presentation, but if you have a question,
Yeah. Thank you. So just like the last talk, if you have a question in the room, please go up to the mic in the center of the room, and I'll be bouncing between fielding the questions in the matrix chat as well as in the room. Did you have a preference on which you want to start with?
Either.
Okay. The first question in the room, go ahead.
Okay. Oops. Is Mike like? You mentioned the relationship between math and languages. Actually, remember that Lisp was designed based on Alonzo Church's lambda calculus. So Lisp actually comes from mathematics. And it does have a special sort of privileged place among languages because it introduced a number of features like if then else and recursion and other things, which were then applied because McCarthy was in the ALGOL committee, brought those into ALGOL, and then they found their way into other languages. Lisp has the unique feature that data and instructions can be equally manipulated. So the Zen cone for Lisp is the novice discovers that instructions can also be data. The expert discovers that data can also be instructions, or whatever. And the master realizes there's only data. So, but I think just to get your idea on that.
Thanks for sharing all of this. I think that
If you want to send the PDF,
yes.
I sent you an email. If you attach that, that's
Perfect. I will respond to your email in a second. I'm so happy that you're mentioning all of this because this is my way to digest this information. Because as you said, I went on this spree of just reading a lot about linguistics and then the history of programming languages. But you're bringing a very interesting piece, and I think that it circulates a lot in the security just your instructions versus data. And I didn't even go down that path, to tell you the truth, where I think I try to linguistics is fascinating because it's is just so still unresolved on how we acquire language and how we process it. And there's so many anecdotes in the linguistics. And I think that trying to reconcile how it relates to programming is where I spend most of the time. But as you said, mathematics notation and how it influenced both the creation of the programming languages and how we're introducing certain concepts just adds a completely different lens. And I just didn't go down. I have too big of a backlog on books on linguistics, but that's where I will be going next. So.
I'll have to email you on that.
Please,
but
please
I just
do.
mentioned too, many of the unique features of Python, unique features of Lisp have found their way into Python. So people, the difference in using Lisp and Python is no longer large enough, to drive people to learn Lisp unless they want to train their minds.
Have you seen somebody learning Lisp recently?
I know some people.
Really? That's
yes.
incredible. I think that outside the classroom, this is going to continue. And that's why when I was trying to find the title for the talk, I'm wondering if this will be still a hobby, because right now I'm seeing a lot of, and again, I'm dealing with a small sample set of just children of my friends, but looking at how they're using language just to generate things is just becoming extremely fascinating. So I'm not asking this question to be just sarcastic, but it's more like, I don't know if they will have a desire to do that, given that they're molding their language in a different way. And I'm wondering if they will get better at using just language in general or not.
Okay.
Thank you so much for the thoughts.
Hi, thank you. Two things. First of all, I noticed it didn't mention C++, so I think a lot of people will be very angry about that, but that's beside the point. My second question is how AI uses language. So a couple of days ago, so some researchers leaked how Anthropic, like Claude and GPT think in terms of chain of thoughts, right? So they noticed that at some point, some of the models stopped using coherent English and start to think in coherent English. So right now, AI is trained with human knowledge. That's why it uses English or Chinese if it's a Chinese model.
Yeah.
So I'm just thinking what do you see in terms of what AI language we'll use in the future? Because obviously, human language is not the most efficient thing in the language in the world. And at the same time, it's not it doesn't seem clear to me that mathematical notation would be how machine think in the future. So what do you see in terms of how AI would move as it becomes more and more advanced in terms of thinking in language?
I'll share with you my thoughts. I stumbled on Chomsky's work this year, and he's introduces the concept of generative grammar. It's funny. There's an expression that everybody wishes they would have read Chomsky, and no one wants to be reading Chomsky. Chomsky has this concept of generative grammar where he's talking about exactly what you're mentioning, the fuzzy logic, where at a point when he, again, to the extent that I can understand it, he's talking about this concept where when we talk to ourselves, we don't really use full expressed sentences. In fact, lots of people think in images. Lots of people think in concepts, in structures. So if you kind of open our brain and observe, it becomes like this mishmash of things. So maybe this is what's going into a certain extent where it's just there is at a point of the knowledge saturation. You find a different, much more efficient ways to traverse because the language is not an efficient way. But again, they're coming at it from the way we as humans acquire language. So maybe this is happening. Again, I think that's to make a parallel like this is just too premature. I think that we definitely need to see more of the things. That's my personal opinion, unless somebody else has a different perspective.
Thank you.
Thank you. Great question.
Hi, I'm curious about the myths. I really appreciate the historical, starting with the myth of Babel, or the story of Babel, because these myths are super important and they shape the myth of Prometheus is there's this whole thing about the risk of discovery and Pandora opening Pandora's box, and so yeah, I'm curious what the myth of Babel means to you and means for the the history of language. Like every culture kind of has its own myths, and like Chinese culture, there's like Shenong, which is like the original myth of like a figure elevated to a level of a deity, and this figure like tries every plant to see if they're like poisonous or not.
Yeah.
And it's like the origin of like medicine. So yeah, what does the like Babel mean to you for language?
You know how I stumble, like I didn't plan to go back to Babel, but this summer I came back to lots of works by Umberto Eco and his work on linguistics, and he has a book where he actually takes Babel as just our way as it just becomes a very nicely packaged metaphor for us to kind of look for this proto language, but also explains the diversity of languages and kind of claw to the myth of the universality of one language. So to me, I found the way of the way Umberto Eco packages a lot of the things extremely appealing. I think before it, as you said, hearing for the first time is the Tower of Babel, whether you come at it through religion or whether you come to it through secular education, it just becomes such a nice and appealing beautiful myth. Also with the works, I don't know if you seen, but the Carlos Slim, the billionaire from Mexico, who found the main telecommunication network in Latin America, he has a beautiful collection of the Tower of Babel works. And then you come into the museum and you see like 10 different depictions from 15th century, 16th century, 19th century. We just so fascinated with just that image. It's such a iconic image. But going back then to Eco, I really like that he's framing the Tower of Babel almost just as a way for us to just reconcile, to give us hope that there was a universal language or there is a proto language in the first place, which might not necessarily be the case. So at this point, it's just the way I interpret it, also in a similar way, it's just our symbolic way of unification. What do you think?
Well, when I think of Babel, it's like the things that come up are like hubris. That's why people were like struck and forced to like speak different languages and like be incomprehensible, or yeah, like the problems and like inherent in like translation and like the difficulty of like working across translation. But yeah, universal language, that is I appreciate that.
Definitely look up.
That is the origin. Yeah.
Eco on universal language. Good. I would highly recommend it if it interests you.
Cool.
Thanks for the question.
For any fans of Snow Crash in the room, I'm really enjoying this talk. Yeah. Okay. So for time, I have a lot of questions in the chat. I'm sorry to Aesthetics, if I'm saying that correctly. I can only get to your first question for time, and there's one last question we're going to take in the room, but your email is still on the slide. For my virtual chat peeps, I will get you the PDF after, and your last virtual chat question is, if I can pronounce this correctly, was your idea of evolution of programming languages inspired by Saussure's diachronic systems?
No, but can I get this in writing? Because it will lead me to it.
I think you're going to find a friend in this question asker. So
I was about to say, like, this is
aesthetics,
wonderful.
I highly encourage you to just email directly.
Please do.
I just want to get a sense at this conference about AI. I think it makes a lot of sense for code auditing. So if a human writes code and then using AI to check what you're doing, that you didn't make mistakes, that makes a hell of a lot of sense. But when you unleash generative AI, and what can generative AI do? It can see algos on the internet and Frankenstein them together. And by Frankensteining those component algorithms together, you end up with something that's not refactored, not using reuse, very hard to maintain. So the first question I have to ask, just a show of hands here, who in this room are experienced non-AI programmers? Okay, good. So we got like 75%. Who here thinks that Gen AI for code is sort of nonsense at this point? I mean, someday. Well, it's not going to give you a value add that the AI salesman would like you to believe, and someday I think we will have software that can do simulations of algorithms and possibly build a better algorithm than a human can. But right now, what I see when I look at the code from AI is just Frankenstein nonsense. That you're not. I'm sorry. Yeah. I programmed for 40 years. Yep. 30 here. Yep. To AI programming, it is a very valuable tool, but it needs to be checked. Yeah. It's a valuable tool. Yeah. Similar experience. Yeah, it's a valuable tool for auditing. It's fantastic for auditing. You're not going to go into 20,000 lines of code that's been written over 20 years. Let's say the Cyrus IMAP, and you're not going to find all the bugs as a human. But if you use AI, it can. Fantastic. So there's a definite quality improvement by using it for auditing, but using it for code generation, unleash it on its own, I think it becomes a nightmare what it produces. That's my 2 cents, and I was just getting a sense here if others are feeling that way. And maybe you haven't had a deal yet with the generated code, but you will. Do you find the language in generated code to be the issue? No, it's not just the language, it's the algorithms. It's the algorithms represented by the language. They're a mess. They're not refactoring. They're not doing code reuse. So it's hugely complex. And like when something breaks, and then you don't have continuity of support. My thinking is that's going to be a lot of the AI hucksters are saying that's going to be somebody else's problem. We won't have to worry about it. We just sold our tools. We're out of here. That's my problem with the whole AI scene. There's a gem of truth that it will improve quality. I think it really will improve quality if you use it to audit what the humans are doing. But using it for generative, I think it'll make a huge mess because they're thinking some of the people misusing it are thinking like, oh, this is a great way where you don't have to have a programmer. It's going to magically make an algorithm for you. Depends on the model. Like try Sol. Yeah.
That was cool. Thank you very much, Anna. Please direct all your questions to our email or the Matrix chat, and have a good rest of your conference.
Thank you so much. I'm so happy we made through the setup thing.
Hello, folks. Please pull up a seat, get comfortable. Welcome to Hope 26. To orient you, it is now 3 o'clock. This is the Gramercy room. If that's not where you expected to be, relocate yourself. We did have a programming change. The printed program says this is supposed to be a Cyber Resilience Act talk. That has been replaced with Against Chokepoints, Optical, Audio, and Wireless Mesh as a Community Software Bus by Matt Hargett. Please, we will be saving questions till the end. We do have a microphone in the middle of the room there. You can step up to that and ask your questions. If you can't make it to the microphone, try and flag me and I'll ask the question. Be respectful with any comments and questions you have. So thank you for attending, and I hand it over to Matt.
Thanks. Is there a thing I flip over here to? Is there a button? Push the button, Frank. Ooh, I gotta not do that. So just heads up, the projector is a little bit finicky. It blinks out every once in a while. So if you're epileptic, just turn your chair around and just hear my dulcet tones. Yeah, this is my name's Matt Hargett. I used to work in the computer security community for a number of years, and I've been to many other conferences, just not Hope, for no good reason. So I'm super pleased to be here. Thank you. Thank you. I started programming in 1984. My mom was a programmer. She got me into programming early. I live in San Francisco with my husband, who I've been with for 26 years, and our child, who's 11 years old and going into 6th grade in a couple of days. And so I'm here to talk to you about Against Chokepoints. And it's so fucking annoying. It's like right when I look at it too, so it makes me think, okay, I can't look that way. Yeah, my social here, and they'll be up again at the end of the sort of end of the talk. How many people here are old enough or enlightened enough to be familiar with the Fire Sign Theater? 1, 2, 3, 4, 5. All right, great. So if you don't know, this album is one of the first pop culture references to what we would now call a hacker ever. It's a comedy album. It's a concept comedy album about a guy who hacks a theme park, an amusement park. And it is funny and delightful and things like this. But I think we're all bozos on this bus. The bus that they are talking about is a computer bus. They were not technical, but they were at a university. They had access to mainframe manuals, and they plucked out all these words and sort of phrases. And I think in a lot of ways in the modern computing sort of landscape that we're all in, we are all bozos on the bus, and that bus is being handcuffed to cloud services and things like this. And so I'm going to save time at the end for deep technical questions that you might have. But if there's anything I'm saying that you're like, I have no fucking clue about what you just said, absolutely raise your hand and ask the question, and I'll try to clarify. But there's a big idea that I kind of had as I was having a lot of trouble getting my sort of mixed reality apps deployed onto various sort of XR and spatial sort of app stores. It was really a fucking nightmare. And I was like, you know what, this doesn't work. This way that the gatekeepers work on multiple levels doesn't work. There's a bunch of things about this I feel like aren't fulfilling their intent or promise. And so my goal got kind of bigger and broader, which is how do we make a community-owned software commons that spreads offline, in person, and remains useful even when networks are completely unreliable, extremely intermittent or untrustworthy, or censored networks, or there is no network for whatever reason that might be. And so there's a few influences that got me to this point. I'm going to talk about that before we talk about how this sort of manifested into a walking skeleton of a solution that I can do a demo for. So talking about the way things used to be. And this is not like a nostalgia trip, like back in my day, it was better than today. And that's not my intent, I assure you. But there are going to be some memories in the corner of my mind. So the first thing is that sneakernet, as it used to be called, where you would take a floppy and literally walk it over to the person next to you and put it in their floppy drive or whatever, was a sort of an indie business model of sorts. And there's two, being a lifelong gamer, as was my mom, there's two there's many success stories, and I don't mean to leave anybody out. Two that I really like are the Oliver twins, who were these brothers from the UK, and they wrote games on their ZX Spectrum. They would copy the floppies themselves, take it to the corner newsstand in a Ziploc bag and have the guy sell them. And then they would come back and say, how many did you sell? Okay, we'll take it and whatever. And I am not going to say like making $1 billion is always a good thing, but that they eventually became codemasters to make racing games, and they became billionaires from that. And it was from them that the UK tech computer press, or just the general press, coined this term bedroom coders. People like, you don't need an office, you don't need you don't need a degree. You can just make shit and put it out there and see if people like it or not. The other great example is Ken Williams, who was the founder of a company called Sierra Online. We'll see more about Sierra Online a little bit later. When they were making their first, not just games, but also utilities for the Apple II, they would literally load his brother's trunk up with floppies. He would drive up the California coast, go into every mom and pop shop, and when he would run out of discs to like to sell them, basically, he would just drive back and get some more, and then kind of go back. And that's how Sierra Online started. Makers of King's Quest, Leisure Suit Larry, et cetera, et cetera. And so it is like a humble beginnings sort of thing. And there's a UK side of it, an American side of it, and there's a whole APAC thing that's like this also. But I always find that very inspiring, because the thing I tell my child is, all you need is a couple of buddies. All you need is, and you can do things alone, but it's lonely. If you have a couple of buddies, so that when you're flagging or fatigued, someone is there to kind of lift things up. So the next kind of like big reference point or sort of inspiration from my past computing experience was FidoNet. And I assume everybody in here has the Jason Scott's BBS documentary memorized backwards and forwards. But if you have not seen the BBS documentary, you should. FidoNet was kind of a big deal. So it was one thing to get on a BBS in your hometown and talk to other like jackasses like in your area code. It was another one to be on the FidoNet echoes, pre-Usenet. So even if you happen to have an internet connection in 1984 or 5 or whatever, there was not like a standardized sort of forums to sort of come together on. And FidoNet kind of solved that problem. And when I was a kid, in my head, I always thought of like FidoNet, you would like read messages, make replies and whatever, and so would all the other users on your local BBS. They would upload those to a hub. The hubs would upload to each other. And in my head as a kid, I always pictured it as like dominoes falling West Coast to East Coast, back and forth. And it's not exactly how it works. But 8-year-old me was, that's what I kind of had in my head. And I thought that was the coolest fucking thing in the world, because all it is people cooperating. A couple people with computers and a modem and some copper line between them. So that's very interesting. And I think a thing in the modern world that we're accustomed to now is like instant replies. And like my messaging app has to have less than 50 milliseconds of latency because reasons. And I wonder if we don't actually need it to be, the latency to be that low. The other thing was there was a tool called PGP, Pretty Good Privacy. Maybe some of you have heard of it. I don't know if it's an ongoing concern or not. I don't track those kinds of things anymore. But there are these very interesting parties where you had a public and private key pair that you generated, and then people would sign your public key as an attestation. I met this person. They don't appear to be a sleeper agent. They're awake when I saw them. And that was very interesting. And again, it's this person-to-person in that times physical contact at the Cypherpunks meeting, sort of in the Bay Area, and it's kind of like the original two-factor, where it's like I can see your face, and you don't have all metal teeth, and there's probably not a Terminator endoskeleton underneath you, but also like just authentic discussion. And I saw people, I saw some people say like, I'm not going to sign your public key. I'm like, but I'm here, like I don't work for the feds or whatever. And they're like, I just don't like what you're saying, and that's fine too. You don't have to attest to anybody you don't want to. And then another really interesting sort of, again, input is some people might remember when strong cryptography, I hate how the term crypto means cryptocurrency now. Get off my lawn, yelling at clouds. So now I have to say it the long way every time so people don't get the wrong idea. But I'm going to shorten it for you all because I think you understand. Where strong crypto was considered a munition, like plastic explosives or a hand grenade or something like that, which was fucking ridiculous then. And it's like now it's like you would tell somebody that and they go like, what? Like, that's funny. Was that on Silicon Valley, the show? And they were like, sadly, it was very real. And so people that like to poke the bear had the shirts with the Perl code on it for RSA or whatever it was, or DES, that said this shirt is a munition, which was really funny at the time. But for people that were running a business like PGP, it's like, well, how do you get your strong cryptography out into the rest of the world? How do you export it? It's funny, I see it in the corner of my eye, and it's like, so they literally printed a book, because it turned out that if you printed a book of the source code and then someone scanned that in, it somehow didn't qualify as a munition, because that's how fucking dumb it was. That's how fucking stupid it was. And so you can probably find these books that were shipped internationally so people could sort of reconstitute the PGP binary, I think it was, not the source code actually, at that time. And it was printed in a way that was easy to OCR, optical character recognition, and stuff like that. And the thing that is one that's a funny workaround for an insane time, and which I feel like as a 50-year-old is like a perpetual thing every decade. There's like some new ridiculousness. But again, it was like, well, this medium isn't working, or there's a bottleneck or a choke point. How do we work around it? Well, we will literally print a book that someone can OCR. And something that is extremely specific to me, I'm sure that some people were, it would be, if someone here even knows what I'm talking about, like, I'll buy you dinner. But I worked in an internet provider in the mid-1990s, and we built that internet provider on Linux, actually, on like $1,000 PC or something like that. And lots of fun stories about early Linux and sending TCP/IP stack patches directly to Linus, because he was just a guy on an email. It was like, this fixes the kernel panic. Here you go. But there was this one evening where I would work late at the ISP, not because there was work to do, but because I would, I think we're past the statute of limitations now, but I would be on the Where's IRC channels, and I would fill up a 100 megabyte zip disk. I'm going to say a lot of octogenarian things right now. I would fill up a zip disk of Where's and then bike home at 5 in the morning, go to Hardee's, get a buttermilk biscuit, and then go home and then sleep until 1 p.m. and then sift through the Where's and delete the ones I didn't like and then do it all over again. But there was this one evening where around 9 or 10 p.m., it was after we had ordered our evening pizza, a bunch of people disappeared off of IRC. And in 1996, it might have been eternal September by that point, but there was a big scaling problem on internet relay chat where server splits were a common thing as load got high and this kind of stuff. So that wasn't uncommon. What was weird was that some web pages weren't loading, but some were. And that was weird. And then me being me, I started running trace routes and like going like, what's happening? And half of the internet wasn't reachable. from Central Illinois. And then we had customers calling like, hey, I can't get to ESPN.com or whatever the fuck people looked at back then. And we were like, we don't know either. So we're like talking to, was it Ameritech? Some telco. And like they weren't helpful at our. Next day we find out somebody like digging a ditch at night because they had to close off the highway, and that's why I was at night, basically like knocked over a telephone pole, and all it took was one. And what was interesting now to me is that routing didn't just route around it. There was some other problem. And I was not an admin like looking at BGP flap back then. That was beyond my capabilities at the time. So I don't know what happened, but things didn't reroute properly. There's some other stuff in like the 2000s with certain cable providers blocking ports or doing weird quality of service rules where certain applications on certain ports would get really shitty high latency service. Anybody can beat up that old dog, like yeah. But yeah, so kind of fast forwarding into kind of the sort of present day. And internet resilience is amazing. Like I try to like tell people like it's a miracle that all this stuff works together. And so many people have worked continuously across decades to make it this way. And I think that we can all point at the Great Firewall of China or like things like this or other sort of oppressive regimes that do stuff. But everything works until someone decides that it shouldn't. And so being handcuffed to cloud services is sort of one aspect of that. Cloud startup goes belly up. Do you get your data? No. And that's a bummer and annoying. But I have a couple of really specific experiences that are so mundane that it's weird that it's funny what I can get activated by. There's an independent theater in San Francisco where I live called the 4-Star Theater, and they were playing Napoleon Dynamite. And my daughter was old enough where I'm like, oh, she'll like this quirky, weird kind of movie. Let's buy a ticket or whatever. And for whatever reason, Cloudflare, and don't mean to pick on Cloudflare. I have friends that work at Cloudflare. For whatever reason, it decided I was a robot that day. On the same phone, on the same cellular network, I switched to Wi-Fi. I switched to my laptop. I could not buy a ticket to that theater that day. And the thing it's highlighted for me is, and I will bet $10,000 that the 4-Star Theater was not being actively targeted by Cloudflare that day. But it kind of went like, well, this can just happen at any time. And as a public company run by people with fiduciary responsibility in a country with a government that seems to be testing a lot of boundaries and waters, what else will not be accessible for how long? And Cloudflare does an amazing service where DDoSes and a lot of that stuff that would kill small businesses before are kind of a thing of the past. Not 100% hand waving, but they solved a very key problem and actively do it all the time against nation state actor attacks and things like this. So I don't want to just crap on them, but I just think that maybe the intersection of commerce and an open network is maybe incompatible at this point in time. The other interesting thing that happened, this is a lot more recently, is everything that you own is broadcasting all of the time. And this is logical. You're like, well, of course Wi-Fi broadcasts. It's like making the air molecules move like this a certain way, and then it gets picked up somewhere else. And I logically know that. What I didn't logically realize is that someone could just fit a drone with a sniffer and then run it across like an entire city, blocks and blocks and blocks. And there is this woman that went missing, and why it's a national news story, I don't know. I am kind of befuddled as to why it's still in the headlines when there seems to be more stuff going on that's more important. But they actually used these drones to try to find a Bluetooth emitter that was in her pacemaker. And that's how they're trying to track her down. And so now it's like in People Magazine, it's the New York Post, it was out in the open. And that was more shocking to me because it seems like it would like keep that on the down low, kind of. Like we don't want people to know we can just find any Bluetooth beacon anywhere. But no. And it's not brash, but it's interesting to me that someone didn't go, please don't write about this. They were like, yeah, everybody should know and be running scared. I don't know. I don't know what the intent was. So your portable computer, whatever form it comes in, is going to snitch on you in the gigahertz bands. And what can you do about that? And even if you disable the driver and whatever else, like all these things are embedded on your motherboard, whatever your motherboard is, a laptop or even a framework. Yeah. Oh, okay. Earlier when I was talking, it was loud. I felt like it was loud.
The slides are blinking, so we just want to make sure the HDMI is.
Yeah, we did all the jostling. Yeah. And I think you said an earlier speaker was slightly annoying. Believe me, no one is more annoyed than I am. But it is nobody in particular's fault as well, so it's all good. Yeah, let's go to the next one. And a specific thing that kind of came up as part of the mixed reality and spatial computing development that I was attempting to do and did have some good success with was on some of these older devices, browsers are maintained on a device until they aren't. And even if you can jailbreak the device, and even if you can produce a browser binary and get it signed as a drop-in replacement, which is technically feasible with enough determination, probably like for Oculus Go or Quest 1 or whatever, you could probably do that. But like, is it easier to try to like update the operating system browser with a injection thing, or is it easier just to sideload some other kind of runtime? I spent about 3 years in the WebXR community, giving feedback on standards and browsers to platform holders and stuff like that. And it was not a complete waste of time, but it was a complete waste of time. It's not as, I don't know how anyone can be successful in that technology stack right now. And it might be, I don't have the imagination. That's always a possibility. But also I feel like if there's only one browser, and again, this is a thing where Chromium team does a great job. They're doing the Lord's good work in so many ways, tirelessly. It's very technical. And now it's like running water. Everyone expects it to just happen, so no one appreciates it. So I mean, like crap on the Chromium team, but in terms of an open standard, when it's a monoculture open standard, it's not a monoculture of implementations for the most part. I'm using Firefox here, if it'll stay up long enough to see the icons. So this is not anybody's fault in particular. But we're in a little bit of a monoculture for what's supposed to be an open, vibrant sort of standard and stuff like this. And I feel like it's kind of not. And if there are independent browsers, they usually just like Chrome does it first, and then they kind of follow with a slightly different implementation. And I don't mean, it sounds bad. I'm sorry. I don't mean to denigrate anybody's good work in WebKit or at Mozilla or anything like that. That's just the way it feels to me, because that diversity of implementation that should yield a bunch of competition and better ideas is not what I was seeing, at least not with WebXR and WebGPU and WebNN. And then everybody knows about cloud stuff, and we can shit on cloud services all day long. When the server dies, your stuff dies. How do you get your data out? And with some services, there's ways you can do it. And actually, a great thing about LLM coding agents now is that you can just make a browser plugin for whatever specific web app you want, sniff all the REST requests, walk the DOM, whatever it is you need to do to get your data out. You can do that now, and there's not a centralized repository that can get takedown notice or anything like that. There is an interesting thing that happens with some of these online games in particular, is that the fans of the games are so passionate that they learn to reverse engineer just to keep the game alive. And it's so amazing and inspiring to me that florists, construction workers, whatever, just want to keep fucking playing the first Harry Potter game on PlayStation 1. There's literally 2 Discords for that particular, and whatever floats people's boats. But I think that data portability thing is a thing. And then last, is that I think more than any other time that I've been aware of computer security, I don't know how to win the game right now, and from a defender perspective. And I see people burning themselves out more to have outcomes than protect people and whatever and protect the net. But I think it's only going to kind of get worse. And I made this comment to somebody. It's like Battlestar Galactica, where none of the computers are networked. They talk on a phone because as soon as two computers can talk to each other, the Cylon virus can find a way to get in or whatever. And that's kind of what's happening right now. And it's not even like someone at some nation state needs to push a button to make it happen. These things are autonomous. They self-propagate. They self-adapt. And God bless any... What's that? They have a plan. They have a plan. So say we all, yes. Yeah, they have a plan. I don't know what the fuck to do. Like, God bless you all for... if anybody's doing that and you can jump out of bed every morning and be like, I'm going to, like, figure this out, I have complete respect for you. Like, I couldn't do it personally. And so just a quick summation of what we can't rely on, in my opinion, is I don't think we can rely on the internet being a thing anymore. And just the mode I would get in is if I was orange fuckface, what wouldn't I do? And I make a list of all the things I would do, and I go, all right, yeah, that's probably what I would do too, if I were an orange fuckface. And I guess this is kind of it's more like a ketchup and mustard sort of thing. Maybe I am. Am I turning into an orange fuckface? Okay. And then Wi-Fi is too loud. You can put Wi-Fi, your laptop Wi-Fi on low power and stuff like that. It actually, like, when you actually measure like what distance does it go to, it's a little too far. A drone can still get you. Bluetooth, regular Bluetooth is kind of a no-go if you think any of these things are really serious threats or whatever. But low energy Bluetooth at the whisper power setting probably is fine. And then you can do some wireless things in the same room, but not across like a giant mesh or anything like that. And then assumptions about ordered data. And so the ordered data thing comes up in the local first community. Is that right? Local first? Yeah, local first and edge first kind of communities, where it's like when we exchange these things called CRTs, these deltas, they need to be able to be applied in any order because they might arrive out of order. It's a little like a TCP fragmentation-ish sort of thing. And people have done a lot of hard thinking about algorithms and how to do that without too much memory. So low power, low memory devices can do that kind of data reassembly when you have really intermittent sort of connections to some of these services. But I would say that if your design needs a router, your design has a landlord. And you go like, oh, well, but on my ISP doesn't run Cloudflare. Well, your packets are going across copper, fiber, or carrier pigeon. Someone owns that medium, and someone can drive a tank up to any of those public companies' offices and say, here's what you're going to do right now. And I just, I don't mean to be like a doomer, but I don't know. Like, I feel like this is enough of a thing that I got motivated to start thinking about the solution. So how do we kind of build back better? I'm just going to get some props out of my that one, this one. I'm sorry. Hopefully the mastering engineer on the recording can do something. So I had this funny idea where, like, what do we do? And I started from almost zero on the research on this because I just wasn't involved in those communities, and no one can drink from all of the fire hoses. If you want to tell me I'm a lazy idiot, that's fine. I'm not going to drink from all the fire hoses. But it started off with QR codes, which means we can do human to human. You can hold this with a QR code on it. I can hold this, and I can point it at this, and we do this all the time with LinkedIn QR codes and whatever else. I'm not here to, you can, if you want to shut on me for saying LinkedIn is decent, that's fine. But what got more interesting is when I realized, oh, well, a lot of these devices have front-facing cameras, so you can actually face them towards each other and then get bidirectional information. and that's interesting, or I thought it was interesting. And then I got into the rabbit hole of motion QR codes and fountain codes. And so fountain codes are these QR codes that flash by at 60 frames per second or 30. It's really down to what the camera can pick up, not what the display can do. And then I thought, okay, this is getting back to this human to human, screen to camera, or speaker to microphone for data over audio, which is a thing. And if you miss the dulcet tones of 110 BPS negotiation, or if you had a US Robotics HST 16.8 with all of its like extra crackles and shit at the end to negotiate stuff, data over audio is as piercing to the ear. I've tried all kinds of things like, okay, just mix it Mixolydian notes and just put it in this range and whatever. And it still happens so fast that it like makes my eye twitch when it's happening because it's like not fun to hear. There's some subsonic and supersonic stuff, but then again, what can your speaker in your device do? What can your microphone in your device do? And the other cool thing is that if I have a screen that's large enough, I can multicast a fountain code to an entire room of people and just multicast a whole thing. And we'll talk later about what the transfer rates are like. There's a lot of academic white papers in this area, but it's all lab conditions. It's not real. And the main thing I found is when testing across like a matrix of devices that are, say, like 2018 era, like this iPhone XS here, or a MetaQuest 1 or whatever. And I'm not crapping on anybody. It was a good camera. They're all good cameras when they came out. That interoperability of the screen to camera is where the reality sort of kicks in. So I think Hacker News keeps having these posts about, I transferred 9 megabytes per second over iPhone 18 Pro or whatever the fuck it is. And I'm very interested in all of those things. I cannot reproduce anything that those people are saying. And maybe it's my fault. That's always possible. But there's a bunch of really interesting things about this, where you could walk around with a giant trench coat full of phones with animated QR codes and go like, what do you want? Like, I got Call of Duty over here and I got whatever. And we'll talk about payments in a second. I'll get to that later. Because there is a question, how do people eat as well? And so the thing I thought was neat about this idea is that it's physically scoped. It's user visible. It's channel agile. So it's like I can do QR codes one way, I can do QR codes two ways, I can do QR codes plus an audio channel for ACKs or metadata or retransmits and that kind of stuff. More than anything, one of the things with like the PGP key signing parties is that everybody was within punching distance. And so like, I remember Bluetooth hacking or exploits were like a thing, and me and a couple of other people were like, who would do that when someone could just beat the fuck out of you? That isn't, like, someone's gonna see you with it. And that was a Flipper Zero. If you don't have one, it's a really cute toy. I was very happy. I think it was on Kickstarter that I backed it on. So now these things can be very surreptitious, and also with LLMs that can also be headless, like, I'm scaring myself again. I'm gonna stop talking about that. So these are like verifiable properties. It's not magic privacy. You don't have to be a PhD in mathematics to understand how the cryptography works, or is there a factoring trick that makes this complicated set of keys and like handshakes and whatever. It's a lot simpler. That probably means that there's some like fundamental thing someone's gonna tell me like, here's why it won't work, and that's fine. But also we get into like a software and media commons. Excuse me. And so people like to beat up on NPM but not Cargo for some, and not that I hate Cargo. I use a lot of Rust. We'll talk about it, but like, NPM has the same gatekeeper problem, has the same continuity problem, has the same everything problem. And if Microsoft or GitHub/Microsoft hadn't bought NPM, the whole community would have had a problem when the NPM startup was not doing so great from a business perspective. Again, not picking on NPM in particular, but it seems to get the most news, and it's the most sort of topical in terms of supply chain attacks and this other kind of stuff. Not that these other ecosystems are invulnerable to supply chain attacks, but NPM seems to be the one that gets the most consistent news at the very least. And so in the same way that we had like a little container full of like 5 1/4 inch or 8 inch floppy disks if you're nasty, and you just had like this like Rolodex almost of like floppies, and then by the end of a school year, all of the friends at school that had the same computer and you had the same copies of everything because you shared everything with each other in that way. And so I think this is a really neat idea because applications or programs, music, video, photos, one of the things I'm not done with yet, so I can't demo today, is taking OpenStreetMaps and converting that into this format so that people can trade map diffs as deltas, wiki deltas, forum threads, or other kind of message boards / social sort of text streams, if you will, get traded hand to hand, kind of like mixtapes. And if you come up to somebody and like, oh, I've got the you know, if you go to trade and you enumerate each other's stuff and you go like, oh, you've got FemtoChat 1.2. Can I get FemtoChat? Yeah, let's just trade. Then you can be on FemtoChat 1.2 or kind of whatever it is. And so the example I give here is Mystery House. So I sprinkle my Sierra Online references in evenly. And if you don't know, Mystery House was the first graphical adventure game, and it was on the Apple I, I think, at first, actually, not just the Apple II. And those were on tapes originally. And it's a 50-year-old game, but if you don't know, spoiler alert. And then getting into some technical details, so going from the big idea sort of into some implementation details. One of the things that I thought was a good idea was to use WebAssembly bytecode as the sort of lingua franca for the how do you exchange these programs. And even the QR code sort of transfer part of the application is written in WebAssembly and can be updated. So there's a lot of parts of this that can be completely updated, totally out of band. There are no servers. And there's you can make absolute sure of it. Physically in the binary, there are no socket calls. It doesn't exist. Nothing is linked like that. And then the other thing besides WebAssembly, and I did choose an interpreter and not a JIT because JITs have all kinds of interpreters have attack surfaces too. JITs just seem to get you in trouble faster. So you can just trade those, and they're portable, they're inspectable, they're vendor free. There's no store, there's no signing, there's no gatekeeper, and I'm using the WASM micro runtime, which even runs on PyPicos. And everything I did was GPU first. It runs on efficiency CPU cores, and I wanted to push as much stuff off the CPU, thinking about battery life and that sort of stuff. And then assuming like I'm gonna say a modern media stack, which is HEVC and Opus, which even the iPhone XS can natively decode HEVC at very high bit rates, and it doesn't break a sweat. So can most of these watches, by the way. These can all decode HEVC. And so leading into the silicon that is from the last decade or so. And so it keeps flashing. So this is a real QR code. But if you put your phone at it, it won't say like open this because it's a binary. It's a broadly compressed. That's right. It's a broadly compressed WebAssembly binary that has a bunch of web GPU shader language text strings in it. And let me go here. Oh, and you can't hear it. The audio's not coming through. But that 2.1 kilobyte program that's transferred with one QR code, by the way. You don't need animated QR codes for that. This takes a bunch of the effects from the Future Crew Second Reality demo from the 1993 Finland demo competition, which changed my life at the time. And each face of this dodecahedron is one of the amazing linear algebra VGA effects that they had in that. And it's hard to see because it's so, this thing's fucking flashing. But even if it wasn't flashing, there's a bunch of vertex animations happening as well. And I was trying to figure out how much can I cram into 2 kilobytes and still have something going. And then you hear the music playing. That's the original Screen Tracker 3 music. The data is larger than 2 kilobytes for the Screen Tracker 3 music, but the player is not. And the player is mostly a GPU compute shader. It doesn't even run on the CPU. All right. Uh-oh. Where's my? I hate the way Macs do this. Thank you. Uh-oh. All right. Well, let's open it again in a new browser. I said earlier it's better than the old VGA days when when I told them how I was doing a presentation and my laptop would only display at 320 by 240, and the slides were like not having it. But anyway, I made a bunch of WebAssembly modules that are all based on W3C open standards. I've made WASI and WIT interfaces for all of this stuff to be able to do that. And so it's familiar APIs, but it's not using browser technology. Everything was written from scratch, mostly in Rust, some of it in Swift. And then payments, there are no payments. I feel like all the trappings of like BitChat or whatever is like, how do we get payments? Then you have centralized servers and whatever. And hey, if you want like Leisure Suit Larry 6 and you'll wash my car for it, fine. We can barter for it. Like the currency that takes place is up to us and what matters to us. And I have been like beating the shit out of this with fuzzers, and I have a long history of DEF CON and Black Hat talks about coverage-based fuzzing. I've unloaded everything with all barrels on this runtime to try to like really find like all of the problems. There are some adjacent projects like Freenet and BitChat, Secure Scuttlebutt, not my name. SSB it was called. I'm just flipping through this so we can get to have time for questions. There's a bunch of projects that are thinking in this area, but my main problem, the reason I was kept going with this instead of the stuff contributing to one of those projects more, and I may still do that, is that all of them assume a routable radio network of some kind or a routable internet of some kind as the basis. And you can kind of do offline QR stuff if your deltas are small enough. And I'm just flipping it around because I just like to be heretical. It's worked well for me so far. And so the whole thing is no radio by design. Networking is the add-on, maybe, not the other way around. But again, like I showed in my WASM modules thing, come on, baby. Oh, is it off now? Yeah, it's absent. It's not linked at all. Really forcing the function. And hey, if this like makes a new 4 kilobyte intro demo scene sort of runtime, and that's all it becomes, that's fine. That's fine by me. A little thing on fountain codes. Again, like this seems to come up in. It was on Slashdot. It was on Hacker News. I don't know who reads Hacker News, but someone brought it up to me. And they go like 500 kilobytes a second or whatever. When testing across a lot of different devices, a lot of different cameras, a lot of different displays, including anime QR codes on the watch, what I can get consistently in sunlight with 2 people holding it with a little bit of, realistic stuff there, about 20 kilobytes a second, which is still pretty fucking good, I think. Are you going to replicate the entire archive.org that way? No. But one device can't have enough storage to do that anyway. So I've talked to some people about this, but I have not open sourced this yet. I've been just kind of like chipping away at this, trying to really test the boundaries of it. So if anybody is interested in this at all, you can kick the tires with me, and I'm happy to like invite you to the GitHub repo, and we can discover the fatal flaw in it together. We're still all bozos, but we can be the bus. Thanks, everybody.
No online questions. Feel free to step up to the mic if you have any, or go ahead.
You mentioned like sneaker nets.
Uh-huh. Mhm.
We're talking about like phones and laptops. I guess when it's can do something
Like lowest common denominator. I mean, the other thing you could do is you could connect crossover cables. If you both have an Ethernet port, that would also be a no radio way to do that. But if it's like, cheese it's the feds, and you got to like rip it out of the port or whatever. Oh, I'm sorry. Sorry, everybody streaming at home. Yeah, so you could do this with crossover Ethernet between two laptops, and that would be shit tons faster. Absolutely. And if you're not at a protest or whatever, or whatever it is, if you're in a safe place where you're like, hey, we won't have to ruin our Ethernet ports by ripping these apart really fast, then yeah, that's a viable alternative. There's probably other alternatives too. But the motion QR code and the fountain code thing, I am not an NFT or cryptocurrency person, but that community has really been the ones that have been doing the most implementation work around fountain codes. And it is pretty neat because it just like looks like it's just like white noise, like you would see like after midnight on over-the-air television in a decade far, far away. But it transfers the goddamn data. It's kind of magic how well it does work because but yeah, there's crossover Ethernet is like a thing that you could do, but that's a person-to-person thing. Or are you going to carry a hub with you? Does it have battery power? Where do you plug it in? And so there's a bunch of just like conveniences and stuff like that. But I don't think I've found like the utopian only solution. And that's why audio as a fallback is a nice alternative also, because watches don't have a camera. And so how do you get the control channel bidirectionally? And so having this display QR codes and then listen for audio is one of the ways to kind of do that.
If somebody doesn't use the mic, you could repeat the question.
Oh, I'm sorry.
First. No, that's all right. Next question.
Oh, yeah. Okay. This is on. It struck me that this might be an interesting way to transmit data and applications through steganography. This could be something that you could hide in a steganographic context. In part, that would allow you to perhaps exchange things in public without it being obvious that you're doing something strange and weird.
Yeah.
Any thoughts or comments on that?
Yeah, I remember it was a few decades ago, so I can't remember who it was. But I think it was a black hat. There was a claim by somebody on CNN that eBay was full of JPEGs that had secret like stenographic codes in them, and it sounds very plausible. That's where I would, because it's in plain sight. Like a 3 Days of the Condor sort of reading a novel sort of thing. But then this guy does the amazing set of scripts where he pulled hundreds and hundreds of megabytes of eBay images, and there was jack shit. There's like nothing statistical. If it was in there, it was not easy to find. There's no statistical detectable stuff in the, I'm going to butcher this, the noise of the DCT or something like this. It was like literally 20 years ago. So, so that would be an interesting thing to do, but it's just pure overhead. So why have the overhead? Unless you were going to like, I'm going to leave this USB key here, and if the right person finds it, they'll know to decode this MP3 in a certain way or whatever. But steganography is, to me, is kind of like watermarking, same kind of stuff, where it's like it's not detectable until it is. And every audio watermarking, every image watermarking thing that's ever been developed has always been cracked. And it's just like a matter of time. But does it answer your question? I'm sorry. Oh yeah, sure, yeah. And actually, there's a bunch of it's interesting. There's a bunch of ad companies that are doing this with like looping videos on big screens, where you can point your camera at it, and you can't see the QR code, but it's there, and your phone can see it. So that's something I'm a little bit aware of. But yeah, yes, sir.
super interesting.
Oh, thank you.
I think, have you considered like changing like one-time pads?
The question is, have we considered exchanging one-time pads? And so there's a bunch of interesting things that can happen to exchange a nonce. There's a bunch of interesting things that can happen in that handshake. I haven't defined that, because you can just write whatever you want in WebAssembly, and for your application, or you can augment the sort of the way the QR codes get scanned or whatever. It's all just there for you to kind of modify. And I am just, as my friends Henry Strickland and Aaron will tell you, I'm just not educated enough to reason about most of that stuff. I do want to say one thing. I'm going to embarrass you, Henry, for a second here. Part of what made this easy, I'll say easy for me, was Henry and I used to do pair programming because he had bad RSI. And it seemed like every other year he would write a new interpreter runtime for reasons with a capital R. And it was one of those things where I'm like, oh yeah, you just write a runtime. It's just code. Like it's code that runs code. What's the big deal? But yeah, in terms of how to exchange a nonce or that kind of stuff, it's wide open because you just make a WebAssembly that does the math. And if you need big math, you can put it onto the GPU if that's what you have. But even a PyPico 2, I was actually pleasantly, it doesn't have a GPU in it, but I was actually pleasantly surprised by the amount of heavy cryptographic or big math that particular embedded device can do. But I've tried to kind of not have a strong opinion about that. If people want to bareback it and trade it out in the open with no crypto and no whatever, go with God, don't take any wood nickels and all that kind of stuff. Yeah.
We are out.
Yeah. You can ask me. You can ask me offline. Thank you, everybody.
Thank you, everybody. Thank you, Matt Hargett. Hello, folks. Welcome to Hope 26. This is the 4 p.m. show at the Gramercy, or a talk at the Gramercy. If you expected to be somewhere else, you need to figure out where that is. We are here for a Flushing Tech, 3 years of building hyper-local tech communities with William Houston. Please be respectful if you have questions and comments. We have a microphone in the middle of the room that you can use to ask questions, please, or you can wave at me and we'll try and get the questions in. Do you prefer questions be kept till at the end of the presentation? All right, so wait until the end and we will try and, if there is time, we will get to the questions. So thank you very much, folks, and welcome, William Houston.
Hey guys, it's very good to see you all. I have a very low voice, so I hope I project today. So my name is William, and thank you all for coming today. It's been a long day, lots of good talks. How many people have been to more than 3 talks? Okay, so that's most of you. How about 1 talk? 1 or less? Okay. So yeah, it's a long afternoon. So before we start, I'd like to invite all of us to just turn our attention inwards for a few moments and just observe your thoughts for a little bit. You can close your eyes if you want. I'm going to close my eyes. And then just gently turn your focus to your breathing and your body. And then without opening your eyes or anything, just think about and hold everyone in the room around you. And I hope that was as refreshing to you as it was for me. And what we just did there was created a space. Nothing particularly special about it, but we did create a space just now. And that was a special space. And we did it without anything. We did it just by creating something that everyone did together at the same time in the same place. And it's something that none of us, well, some of us might know each other, but most of us don't know each other. We're total strangers. So we're able to come together and create something out of nothing. So I just want to notice that because that is something that Flushing Tech tries to do a little differently. We try to, I'm gonna get in and talk about it, but we try to bring people together to create stuff, and in a way that would foster their relationship with everyone else around them, in a technical set, in a technology setting. So thanks for that. So today, I wish I could hold this. Anyways, so today, the hope for today, I'll try to get through these slides as quickly as possible because I've done a few of these talks and I found that I usually talk about the stuff that is not relevant. So hopefully I'll try to get through these slides and give you an idea about what we're doing at Flushing Tech, and then leave a lot of space for questions at the end. So for today,
the glitching is still happening, just so you know.
Okay.
Unfortunately, we're aware of it.
Okay, we'll bear it. So for today, I wanted to just do a quick recap about what flashing tech was. I did a sort of introductory talk last year at Hope. Did anyone come to that? Okay, great. We have 2 people. So I'll do a quick recap or a new introduction, and then I'll talk about what we've done since that year in a way that would give you some idea about what we've learned, some things that worked, some things that didn't, some things that surprised us, just to give you a sense of what we've been experiencing in our journey growing flashing tech. And then I'll ask folks to join our newsletter. It's pretty new, but the idea is, again, to just let the community know about how we're building flashing tech, and hopefully some parts of it you can take back to your own neighborhoods, to your own places, and implement some of them as your own ideas. So the newsletter is a good way to sort of like keep up to date, and then hopefully maybe inspire some of you to actually build out a flashing tech in your own neighborhood. So that's the plan. Let's see how it goes. But before we do that, a little bit about myself. My name is William. I'm an immigrant from Guyana, and I'm living in Flushing in Queens, which is why it's called Flashing Tech for now. By the way, how many people from out of town do we have today? Okay, great. So we have most people from out of town. That's going to be relevant in a little bit. Yeah, so I live in Flushing. I enjoy building stuff in my apartment. I'm very much of a tinkerer. I'm a DevOps engineer for about 20 years. And I still like doing DevOps. It's really just a hobby for me. And I'm the founder of Flashing Tech. And apparently, I'm some sort of like chairman now, because Flashing Tech, as you'll learn in the slides, is now a corporation, a nonprofit corporation. Some things that I like staying active. I like pondering the meaning of life. I spend a lot of time in my head. And I like spending time out in the world and participating in ways that are mutually impactful. Some of those places are like civic spaces, places where there's impact. Okay, that's enough about me, thank God. So to get into the talk, a year ago, I ran most of the hackathons that Flashing Tech runs. Hackathons are the main event for Flashing Tech. And a few weeks ago, I offered to co-host a new hackathon that we started in a different neighborhood than Flushing in Jamaica. And I didn't run it. And it was run by someone who was from Flushing, who went to Flushing and did a lot of hackathons, had a lot of fun. And he did it way better than most of the hackathons than I did. So that was a big turning point. It was something that worked. It was very surprising that it worked. And today I want to share how we got there, how we got to the point where I can sort of disappear and vanish, which is a good thing to do. So to get started, just talking a few slides about Flashing Tech. I'm going to go over what our mission is, what our vision is, and some of the things that we do and how we do them. And then I'll progress from there into how we've been progressing beyond that since last year, the stuff that we've built. So the mission for Flashing Tech is to build and nourish thriving tech communities in every neighborhood across the world, in a way that would sort of like grow organically, scale out organically. So Fleshing Tech focuses on ways that we can build very hyperlocal communities in a very simple way that anyone can do it, and hopefully that would sort of like allow it to grow and spread out into all the neighborhoods across the world organically. So that's the mission. And last year I talked about a couple of checklists, a couple of resources, a manifesto, a roadmap. I shared that with people, and I'll share that at the end, where you can actually use those resources that we've built up to help get Fleshing Tech across the world. So that was the mission, and the vision is very hard to explain. So here's an analogy. Hopefully that works. The vision is that we have a world at the end of all of this where everyone around the world is able to participate in our own technological future. And one of the ways of explaining this is think about Signal. Most of us, how many people use Signal here? Yeah, great, everyone. So when Signal becomes the norm outside of this room and across the world, privacy sort of like becomes a normal thing. It becomes normalized. And Nextcloud, any Nextcloud users? Okay, not so much. Nextcloud is a self-hosted version of cloud, where you can self-host your own data. And if that's normalized as well, then sort of like owning your own data becomes normal. So in the same sort of vein, the vision behind Fleshing Tech is that if every neighborhood, if everyone across the world sort of like came together and took real ownership of technology in a community setting, sort of like the whole world becomes normal for the whole world. So that's the vision that we're trying to build. Okay, so the vision, the journey so far, doing good on time, I think. Most of these slides I stole from last year. So we started small. The first few events were actually not hackathons. We started just meeting and trying to figure out what we want to do as a group of people in a neighborhood. So the first thing I did was just posted an ad on Meetup, I believe was the first thing I did, and just invited people to come together and we'll figure out what we want to do together. So there was no plan really, and that's how we started. And people came and eventually over time, we tried a couple things. We tried many things. We tried networking events, which was the norm for communities back in the day. Happy hours. I like drinking. Any drinkers there? Excellent. I'll try to grab a drink for each one of you. Lots of talks again, which was normal for tech communities back in those days. Panels and workshops. We still do workshops because it complements the hackathons really well, which is one thing that I learned. The hackathons are places where people come together and they just spend most of the time building stuff. But there's always this yearning to like still have a classroom style, come to a place, learn about something new from someone else. So the workshops are really good for that. Panels are also very nice, whereby especially professionals and experts get to share their thinking about stuff that is happening in the tech world. But we tried all those things, and the hackathons stuck out as one thing that really resonated with people. And I've been thinking about that for a long time, and it seems like one of the reasons it worked is because it's fun, it's energetic, and it's rewarding. But the thing that really made it work was that it happened every 2 weeks. It was very consistent. So if I was to like distill down Fleshing Tech into something that in its purest form, it would be that if you want to build a community around a very hyperlocal community, just come up with an activity that people really found fun, energetic, and rewarding and do it consistently, people are just going to naturally gravitate to it, and voila, you have a very thriving community. Okay, I think I had some water. Give me a second. Okay, so that's up to last year, and since last year, we put in a couple structures to sort of like lay the groundwork for growing beyond just those simple events. Again, fleshing tech is just the idea that you can just bring people together to do an activity without, like, anyone should be able to do it. So no professional organizers, no community organizers, no special skills required. So up until last year, all of that worked just naturally. And I'll go into little details about how we did it, and you'll see how very minimal and very minimal the stuff that we did was. But that works up to a certain point, and then there's sort of like, okay, so everyone is coming consistently all the time, and they're having a lot of fun. But at some point, you want to grow beyond that. You want to grow into other neighborhoods, which is something that the community wants as well. They want to see what, like Fleshing, people who come to Fleshing want to see what people in Brooklyn likes building, what they're like working on. So the community also wants to grow. But for that to happen, it seems like we needed structures to sort of like add some guardrails so that we can do that in a sustainable way. So that's where we're at in the journey right now. We created some structures to sort of allow us to grow. Okay, so, oh God. So I talked about the hackathons, and the hackathons are the main event that sort of like helped Fleshing Tech become what it is today, out of all the other activities that we tried. Again, I think I spoke about this just now. The hackathons are very minimal. They're very low pressure. They're very casual. They're just a fun space for people to come, to learn new things, to build stuff that they're interested in building, and to meet other like-minded people to sort of like just grow their connections. But the main part of it seems like it was very important for it to be consistent every 2 weeks. And this is what I mean by very bare bones. This is the agenda for the hackathons. I've been to hackathons and other technical events where there were several steps that you had to go through. There were preparation steps. There were like upscaling steps. There were like team building steps. I shied away from all of that because I wanted to get people to build stuff right away. And that worked. That's one thing that worked. And it also surprised me is that people prefer to just get to the laptops as quickly as possible. So this is what the agenda looks like. First, we would brainstorm some ideas. So pretty much, if this was a hackathon, I would come up here and I would ask for folks who just walked in, spend 5 minutes asking what sort of ideas that they want to build, put it up on a board. And this is brainstorming. This is not what we're going to build as yet. And after we get all the ideas on a board, then we can start forming teams. Who wants to build these ideas? And I would just ask people to raise their hand. That was in the past. Now we have apps to do that. We built an app during our hackathon. I'll show you that later to help with that. But just ask people if any of these ideas resonate with them, and form teams and start building. And the building takes up most of the time. Takes up an hour and a half usually. And then after they build for an hour and a half, then they spend 5, 10, 15 minutes presenting, asking questions, demoing what they've done, stuff they've learned, and really like having a two-way conversation with everyone else about what they built. And then afterwards, there's time for networking. So that's it. That's what hackathons are. And I think anyone should be able to do that if they wanted to. Okay, we're doing time. So this is something that Claude told me to include some stats about how far we've come. So I put them in. I think one useful stat was that we started with just 3 to 5 people. And I think anyone who starts a group, when you get 3 to 5 people, it's a little off-putting. But I thought that was great because it showed that there was some interest, and 3 to 5 people, you can only go uphill from there, hopefully. And now we have like 15 to 20 people, which sounds kind of small still, but considering that these hackathons are in very small localities in a neighborhood, and these are people who come back consistently, it's a very good number. It's also a good number where it's not overcrowded, where everyone sort of like have a many-to-many relationship and connection. We've done more than 60 hackathons over 3 years, which I think validates the idea pretty well. But the main thing that I'm really excited about is that we've done more than 300 projects. And each one of these projects is, so again, when we start a hackathon, we ask people to put up some ideas to build, form some teams around it, and then they go off and they build it. So that's one project. And when people form their groups and they build these ideas, that is somebody who comes to the hackathon on that day learning something new, or that is somebody who meets someone new that they can reconnect with if they have questions about some technology thing. So the projects are sort of like the product. And we've done 300, and it seems to be growing really fast. Okay. So this is what I talked about earlier. This is the app that we built initially to help people get started. Get started with thinking about what ideas they want to build. And at the end of the hackathon, voting on which idea was more everyone liked. So we built an app for that. And pretty much you just enter your ideas, and at the end of the hackathon, everyone just goes into the app and give it a thumbs up or a thumbs down. That's why it's called Vote. And the person who built it during a hackathon. And the hackathons are only 2 hours, so you don't have a lot of time to spend to come up with a good name. So you just said Vote with 2 T's. So that's why it's called Vote. There's a QR code up there. I hesitated to put it there because it's like on a free tier account, and it's probably going to get DOSed if all you guys opened it, but it's there. Give it a shot. If you're lucky, let me know. But it's really good. And I hope you can see some of the projects there. I didn't get a chance to first of all, I always forget to take photos at hackathons about people projects. So I don't have a lot of those. But in the app, we have a couple projects. So if you get in, definitely look at the projects. Okay. So that's Flushing Tech and hackathons. Now we're getting into how far we've come, and sort of like I'm going to share some experiences, so you can take them back and try them out yourselves. So from last year, Flushing Tech was just very bare bones. It was very scrappy. We were still experimenting with a lot of things. It was just one neighborhood, and there was little to no structure. There was a good question at the end of last year's talk about if there was governance, and there really wasn't. Everyone sort of like stepped up into their own roles. If they wanted to take care of social media marketing, they would do that themselves. And that worked for a long time. That worked for a year, for 2 years before that talk. And then over the last year, a couple things changed so that we can sort of grow Flashing Tech a little bit. We created a 501 nonprofit corporation. And that was mainly done so that we can, first of all, for credibility, so that we can form partnerships with people who would be vital to help us grow beyond one neighborhood. Because if you're going into Flushing was easy for me because I already had a lot of connections. I had a lot of people that I already knew in Flushing. But a 501c would have helped me sort of like reach out into neighborhoods that I had no connections with. It would give me that sort of credibility. So that's why we formed that. And as a result of that, we had to create a board. So now we have a board of directors, which is one thing I learned, and it might be obvious to a lot of people now, is that starting an organization like this here, building up teams that can help you build it early on is super helpful. It would have made my life a lot more easier if I just did this in the beginning. So if anyone here wants to start something like that, I highly recommend building up a board or just like a group of people to like help support you, and give you strategic advice early on. And so we're able to expand Flushing into 3 neighborhoods now, and hopefully growing more. Okay. Yeah, like I said, the 501c3 was for to form partnerships beyond Flushing, and also to help with fundraising. It's also one of the hardest things that I've ever done at Flushing. So brace yourselves. That was surprising for me. I thought you would just point and click and it would just happen. Not so at all. But the surprising thing was that as I expanded beyond Flushing, most partners didn't really care about the sort of like official structure of a 501. All they really cared about was how many people come to your event and do they come consistently. So that was surprising, but we'll still keep the 501. But that's one thing I learned is that if you want to build a community like this in your own area, think about prioritize building consistent, recurring people, because that's the most valuable thing when you want to expand, when you want to go out and really build better things for your community. That's what partners really look for, in my experience. Another thing is that since forming a 501c3 was so hard, initially I thought that I would build Flushing Tech, share all my experiences in documents, talks like this here, and allow everyone to just go out into the world and form your own 501c3s. But like I said, it's not for the faint of heart. So one thing that I learned that might change is that Flushing Tech might actually become sort of an umbrella where all the other chapters around the world in all the neighborhoods might take those 501c3 benefits from. Just a thought. So the 501c3 was one of the first steps to growth over the last year. Also, we built up a board, which is very helpful strategically, and also in nonprofit land. Those are the guys who provide important connections and lots of valuable resources to grow your organization. And the main thing that really helped Flushing Tech was that all except one person went to the hackathons, participated in some way in Flushing Tech. So they sort of like knew exactly what Flushing Tech was like. They experienced it, and so they were able to like give back to to Flushing Tech serving on the board. And the idea behind the board is to keep it in the same spirit as the hackathons themselves. We don't want to get into a place where it's too, again, the hackathons were fun. And I think that resonated with a lot of people who participated. And we want to keep that energy going on the board level as well. So we have certain norms in the board that would allow us to maintain that same spirit. And so far it works. At first I thought it would hinder or slow down initiatives, but it seems like if you set your mind to that, it's a model that works. In addition to the board, we started building advisory boards, and these are people who go to the hackathons very consistently. They like giving back. And the advisory board is a group of people who would advise the board of directors. So that's a little bit about what we've been doing. In addition to those structures at 501, the board, once we had those in place, we were able to do another really cool thing over the last year, which was actually encourage the spread of Flushing Tech to other neighborhoods. Is this still glitching?
But it's not.
Okay. Excellent.
It's not just you.
Okay. Oh, there he goes. Okay. So this is a graphic of what I envision Flushing Tech to be and how it might grow throughout the world, starting from one neighborhood and then spreading to other neighborhoods organically. Okay, so right now we're in Flushing, and that's where we started off. And over the last year, we started moving into another neighborhood, Jamaica, which was organized by, I wish I had pictures. There was really good pictures of the guy who hosts Jamaica Tech, Spencer, who was also a participant of the hackathons at Flushing. And this seems to be a working model for expanding out beyond neighborhoods, is that if you take people who come to the host sort of like Flushing Tech hackathons, they sort of experience it, and then they go back to their own neighborhoods, and they're able to organize the same thing in their own neighborhoods. And that's what Spencer did. He came to Flushing for a long time. He really enjoyed himself. He wanted to improve his own public speaking and leadership skills. So he decided to take the chance and go ahead and do something like Flushing Tech in Jamaica. So now we have Jamaica Tech, and that also runs bi-weekly. And one of the surprising things after we started doing that was that we found that, so Flushing Tech was the sort of ground zero. That's where everyone from the tri-state area came. People from as far as Connecticut came to Flushing Tech, and Jamaica. But when Jamaica Tech started, they stopped coming to Flushing and they started going to Jamaica Tech. So that was a really cool and surprising thing that we learned. And it just validates that people want these places close to their homes. Next up, we're looking at Richmond Hill, which is also in southern Queens. By the way, any Jamaica or Richmond Hill people here? Excellent. Yeah, Jamaica's fun. I really like the area. Richmond Hill is in the plans because, again, somebody that goes to Flushing Tech wants to do something in his own neighborhood. So he's going to give it a shot. One of the places that I'm more excited about is outside of Queens. So Richmond Hill, Jamaica, they're all in Queens. And Bronxville seems like a very nice place to start Flushing Tech Hackathon because it's very I'm trying to hit all these underserved areas to see what I can learn from starting something from scratch without any resources at all. And Brownsville seems like a very good place to start at. So I'm excited to start that and see what we can learn. The problem is that since it's so underserved, no one comes to Flushing Tech, or they don't have any equivalent near Brownsville as yet. So I can't ask anyone from Brownsville coming to Flushing Tech to start it in Brownsville. This is one of the exceptions to that sort of trend. I'll probably have to start it myself or ask someone who doesn't live in Brownsville to start it. And again, we'll learn and see what we learn from that. So I'm excited to try Brownsville. So we did the 501c3. We built up a board, and all these structures were in place, and they'll continue helping us grow. But one thing that surprised me was while all of this was happening, the community was also sort of like organically evolving itself. People were coming to the hackathons, and they were building their projects, they were putting it on GitHub, and they were self-promoting themselves. They were using these projects to like better their own lives, better their own connections. They were posting it on LinkedIn, on their social media, and sharing it with employers, businesses, friends, people who they like sharing these things with. And they were just doing that without me having to specifically make any specific environmental changes for that to happen. The hackathons are just very bare bones, where people just come, they build stuff for an hour and a half, and then they leave. And I think that's what allows people to like take that and make it work for themselves. And one of the ways that they seem to do that is by promoting themselves on their own. Also, like I mentioned just now, the hackathons seem like a very fertile ground for local businesses seeking talent to come. And the community just organically started to notice that and to facilitate that. So there's a lot of useful connections being made in the hackathons without me or anyone else specifically having to do that, make any sort of like activities or processes to like facilitate that. People also started their own businesses just naturally from the hackathons without, again, any sort of prodding or any sort of like encouragement. So I guess the thing that surprised me here, what I learned is that I don't have to build everything. People, once you bring them together, you get them doing stuff that they like, they'll build the stuff that they need for themselves. Okay. So that's where the journey sort of ends right now. One thing that we're looking at as the board and the rest of the community is taking, so the hackathons are still very fun, scrappy places where people come, they build stuff. But there are places where people can also build impactful, rewarding stuff for their own communities. So we're thinking about creating a feedback loop where people would come to the hackathons and they would be able to like build stuff for their local communities. We're thinking about nonprofits or even small businesses in the area. So we're thinking that businesses and local organizations would get connected to talent, and the participants, the guys building the stuff who likes engineering, they would get experience and connections. So some sort of like some play on that is what we're thinking about coming up next. And I'm excited to see what that turns into. One of the things that I learned building Flushing Tech is that I can have all these ideas, but when I actually put it in front of the community, they turn it into something else. So that's it. Like I mentioned in the beginning, last year I shared a bunch of a roadmap, some checklists, the event descriptions, a bunch of resources for anyone to start their own community in their own neighborhoods, and that's still available. I'll leave some QR codes towards the end where you can sign up for the newsletter, and I'll be in contact. Just like we expanded to other neighborhoods, Flushing Tech is always here to help support any other neighborhoods that want to give it a try. So I encourage anyone to give it a shot. Here are the QR codes for the newsletter. Like I said, it's a place where we share all the different learnings, all the activities that we're trying to do, and even stuff that didn't work out as expected. So sign up to the newsletter there. And also, I hesitate to do this, but we'll give it a try. Since we have a lot of people out of town, I was thinking about doing a road trip to Jamaica, Queens. If anyone wants to try that, we can assemble downstairs in the lobby. So the Jamaica Hackathon is tomorrow at 3 to 5 p.m. in Jamaica, Queens. You just take the E train, it goes straight to Jamaica. It takes about 40 minutes, maybe an hour. So I'm thinking we can just meet downstairs. We have to leave like 1:50 and 1:30-ish. And we can try that. So this is a QR code for Meetup. So if you want, you can RSVP for that. But the hackathons are always open. You can go there on your own at any time. And that is it. Thanks. Do we have time for questions?
We have about 7 minutes.
Okay. You at the beginning of the talk, I don't know whether you said it because I didn't quite catch it. How did you go from one person to that 3 to 5?
It started from 3 to 5 people, but then it grew into like 15 to 20 people.
So you had 3 friends to begin with.
Three strangers.
3 strangers. But okay, how did the 3 strangers get together?
They just saw the ad, and from what I gathered is that they always wanted to meet up locally to talk about technology, and they just said yes. They'll meet someone.
I mean, did you use Meetup or
yes?
what?
The first ad was, I think, on Meetup.
Okay.
Do you have a question from virtual attendee? Sorry. Question from the virtual attendee. Can a shared umbrella model truly work globally? Tech access, laws, regulations, etc. vary so much outside the U.S. How will Flushing as an umbrella manage that challenging landscape?
The 501c3 I think yes, we can't do a 501c3 in other countries and internationally, but the idea of forming these corporate sort of like government structures so that all the people in the same spirit of Flushing Tech and hackathons, where people just want to come together and build. So as much as we can do outside of that, so that anyone else doesn't have to do that. That's the model I'm thinking about.
Hey, so one thing is I'd be probably very interested to just like if you have any like data and analytics about like the participants and how they progressed and where they're at. I'd be super interested in that. But broadly, the reason I'd be interested in is something I'm passionate about, and you know, I do pro bono, sometimes paid, is like helping people get jobs in tech. And also a lot of people are coming to me. It's just like, oh, how do I find a project? How do I find an internship? Something like that. And one of the things that I generally suggest people do, if they don't like have an internship, is to do a hackathon. And what you're doing is super interesting to me because you have it regular and very focused. So I'm kind of wondering, like, and also you mentioned that some people post on LinkedIn, which is exactly kind of the direction I like to see people go. So like, what are your success stories look like, and what is the ratio? Is it like, yeah, I think you see where I'm going at with this.
Yeah, that's a good question. And that's why the voting app that I showed you earlier was super useful. All the projects goes into there. The timelines as to how those projects progress, the work that people put into it, throughout multiple hackathons, that reflects how they're growing, the stuff that they're interested in. All of that, their profiles are public, their projects are public. That might change. I don't know if people want their stuff like that out in the open. But yeah, the platform is there, and I think that's where we had it, is a place where people are able to share their progress and collaboration and growth in those local communities. And we'll see how that turns out. Thanks.
Hi, I'm part of an organization that's trying to get 501c3 status, mostly for fundraising reasons. It's like a little civic newsletter. But I'm curious, you mentioned you had specific norms, I think you said, or something like that, on your board. I'm curious what those are, if you've made your bylaws public, things like that.
Yeah. So I'm on a couple of corporate boards and one other nonprofit, and most of them follow. They have a way more long history than Flashing Tech. So they follow. They built up a lot of more corporate-y sort of like norms. They follow Robert's rules. Does anyone know what Robert's rules are? Okay, so Robert's rules are sort of a protocol for running a board meeting. A board meeting where people vote on very important decisions. And it's a bunch of rules. So in the same spirit of the hackathons, where again, we're just trying to get people to come and build stuff. How many of those things can we get rid of? So the question is, what are those norms? I think the norm is the lack of the norms, the lack of the Roberts rules that we try to, not try to, but we try to not follow. So our board meetings are very, very minimal. At most, you would probably get motions to the very important legal stuff that need to be minuted. That's the basement. That's the bare minimum that we try to have during the board meetings.
Hi, love local tech and organizing. It's amazing, and thank you for coming and giving your talk. I've spent so many years in like hackerspaces and makerspaces and things like that, and their governance tends to be quite anarchistic and not very corporate. And what you're describing here is kind of almost the antithesis of that. You've got lots of boards, you've got lots of meetings, you're passing motions, and I think it kind of follows on a little bit from the answer you gave to the last question. But why go down that route? And do you think that the only way to create communities is for people to follow that model, or do you think there's a way that in a more anarchistic way it could scale globally?
So I think the anarchistic way is more favorable because it gives more fertile ground for people to come up with their own structures to do what they want to do. What I have found though is that, and again, we don't have a ton of meetings. We have like one monthly board meeting, and we're hoping to slow that down to like a quarter after we have some traction. But still, we do have these structures. We still do have these meetings and these committees and these smaller boards. And what I noticed from that is that these smaller focus places encourage people to take ownership of stuff that they might be interested in. Otherwise, this anarchistic approach, it sort of like falls into the tragedy of the commons, where somebody else thinks that someone else is gonna sort of like organize this idea, this initiative. So that's one of the benefits. But again, I'm hoping that we shy away from too much of that and keep it as fertile as possible.
Thank you.
That's all the time we get. Okay. Thank you all.
All right, folks, that's all we have time for. Thank you, William Hudson. I'm sorry. Thank you for attending. Have a good day.
Thanks.
Thank you.
Ever wonder what purposes really large antennae are used for? Well, to tell us about that is Steve Bossert. Please give him a warm welcome.
Thank you, Al. Everyone can hear me good? It's 5 o'clock on Friday. Is everyone still awake? You got coffee in you? All right, you caffeinated? All right, good. All right, so yeah, huge antennas, death race to aliens. You have no idea what I'm about to present on. All right, so quick about me. Yeah, for the most part, most of my career and pre-career were always interested in electronics and wireless signals and stuff. Given presentations the past 3 hopes. Some of you have probably muddled through that with me. This year, I had to come up with something a little more interesting. So you'll see a little bit of a shout out to this guy in a white lab coat. The detour that I took the past year, I never thought that I'd ever find myself working for the ARRL, those that are not familiar. It's the Advocacy Group for Amateur Radio. It's kind of like the dork's biggest job achievement. So I took a detour, and I've already known John, but for those that are curious, the white lab coat guy is ARRL, and that's me and photoshopped in John in front of Newington, Connecticut headquarters. So breadcrumbs, what the heck am I doing here? So the last couple of years, if anyone's seen my presentations, they've been very RF centric. And in a way, I feel like I've kind of been giving like a little bit of a breadcrumb trail. And I was kind of waiting for this like AI thing to catch up. I'm not saying that I'm better than AI, but you know, I think that there were certain things that really could not be accomplished without a lot of the enhancements that we've seen in AI just within the last 24 months or so. So quick show of hands, who was in my presentation last year where I did reviewing projects on Git? More than a few? All right, cool. So for those that didn't sit through that, basically my premise on this presentation, assuming that everyone here knows what GitHub is, and if not, please leave. I'm kidding. What I did was I looked at on all the repositories on GitHub, which has the most stars, and figured that that's kind of like a democratic way to look at things. So I wanted to compare and contrast projects that are tagged with SDR and projects that are tagged with software-defined radio. You'd think that they're one and the same. They're not. Same thing with amateur radio, or some people call it ham radio. Same thing. They're not. But what was interesting was the number of stars for those projects for the top 10. You can see that up at the top. Everything on Git that relates to SDR or even software-defined radio, huge difference compared to amateur radio. But I think what's really exciting in the past year, thanks to things like Claude and vibe coding and all that other fun stuff, there's been like this major resurgence. And so like going and doing a search on Git right now for projects related to amateur radio is actually accelerated faster than it has in like the time that Git's been around. So I did this. Did a little bit of an update 2 months ago just to kind of see where things were trending, and I was right. If the top 10 SDR projects on Git right now, they weren't, of those top 10, 3 of them were not even in existence last year when I gave this presentation. So it just shows that giving some focus on like stars was actually kind of a smart thing. And now when you go to the starhistory.com website, which is where I generated some graphics and data points from, they have changed their model. I'm not saying I'm the one who broke it, but now it is like infinitely more annoying to try to do what I did last year. So that's where that bunny rabbit thing, I'm sure people recognize that kind of form from something called books back in the day when, yeah, anyway. So yeah, so wireless spectrum, you know, it's a colorful rainbow. You know, there's lots of people here at Hope that, you know, represent a really diverse, you know, part of I don't know if I'll call it a hobby, but just like lots of really cool stuff, right? And so one thing that I've always kind of thought hard about was how to give a presentation related to just antennas. Because when we talk about radio at any form, one thing that always seems to kind of get left out is antennas. If anyone's bought an SDR dongle at some point in their life recently or in the past 10 years, you get like these crappy telescoping little antennas and you're like, why can't I receive anything cool? Well, there's a reason, because it's a crappy antenna. It's not good for everything. And so there's different antennas for different things. And, you know, if we look at all the spectrum going from like super, super low to even like past light waves, you know, when you get into like X-rays and stuff, you know, there's different things. And that's what I kind of, you know, thought about for this topic on huge antennas, death rays to aliens. I think I kind of suckered a bunch of you in here just on the title alone. So I cover a wide array of spectrum. So just kind of going through some brief history, which is not going to be a very historical, it's going to be a very forward-looking presentation, but just to kind of put something in context. Who here was alive in 212 BC? Anyone? Okay, one person. All right, you look good for your age. So yeah, so there was like this guy Archimedes. Maybe some of you have heard of him, but you know, he was like the who am I not going to get in trouble for saying, like the Tesla of our age? I might get in trouble for that. Of like Elon Musk Tesla, not like the other Tesla. But, you know, so yeah, Archimedes had like a thing called a death ray. Like literally it was a thing where they mount mirrors and reflect the sun and, you know, catch ships on fire. I mean, this is like crazy level stuff. So fast forward a lot of years to 1904 AD. In an adjoining room, matter of fact, there's a Tesla presentation going on right now. So thanks for coming to my presentation. Haha on them. But I'm giving a shout out to them. So Tesla had a site on Long Island called Wardial. There's some people in the room right now that are very familiar with that. But all the people more familiar are in the other room. But yeah, you know, some guy named Nikola Tesla was doing crazy things. This site on Long Island actually never lived up to its hype, but the goal was to send wireless power, like crazy level stuff. So I'm sure there's been a lot more that's happened between 212 BC and, you know, 100 whatever years ago. But when we look today, this was an image of a military truck with a directed energy weapon on it. The point is, like, things have changed, but they haven't changed. But I can bet you that there was probably some AI being used on vehicles today. Archimedes did not have that back then. So again, there's been a lot of things. If you think of Archimedes as a type of antenna, yeah, he's just redirecting light waves, which is just super high frequency stuff, right? Again, it's like things are the same and not the same. So anyway, 4 topics. We'll save all the questions to the end. So I think I mentioned these in my blurb. So some things that I thought would apply: Earth-based radio telescopes, accenting the Earth part, radar systems, broadcast-ish antenna, and other stuff for 2000, Alex. Hopefully you get the reference on that. So, all right, so topic 1, Earth-based radio telescopes. And you might notice, if anyone can see the text, I have catchy little titles up on the top bar. So, yeah, this is not like a Star Wars thing. That's no moon. But it gave me a reason to throw an Ewok in here. So what am I talking about? I'm just going to limit it to 3. I did say I'm only going to talk about things that are current, but to put things in context, because I bet there's not a single person in the room that does not know what the Arecibo Space Telescope was. Any raises of hands for anyone who's never heard of the Arecibo Space Telescope in Puerto Rico? Okay, good. No hands. Thank you. All right, but that was decommissioned. You know, it was around for, you know, quite a long time, subject of all sorts of movies and whatever. But in 2020, it just had too much fatal damage. And, you know, it was just like, yeah, it's not just going to be worth building it again. But that thing was 305 meters. And I'll get into a little bit more about the why and what these things are used in the next slide. Then we move over to something called FAST, which is in China, which stands for a 500-meter aperture space telescope. I think that's a really cool acronym, and it's 500 meters. It was built in 2020, or I should say it was finalized in 20. It started construction in 2016. And then finally, we have the largest of this depression-based transit telescope, which I'll explain more in a minute, in Russia. Yeah, the Russians have been hiding this from some of us, maybe. Since 1977, this thing's been in existence. At 600 meters, started construction in 1968. So these are currently the 2 largest depression-based space telescopes in existence. And now I'll explain a little bit how they work. So you'd think, what do you have like these big deflectors for? Yeah, these are for receive. I don't want anyone to think, or at least I should hope that they're not doing this. I don't think that they're sending like ABBA's greatest hits to some far-flung civilization with these. You know, the benefit of having a natural depression is if you line it with reflective material to basically make a huge Can I say the A word? No? All right. Well, you know what I'm going to say. A huge blank telescope, if you build it into like a natural depression, you save a lot of costs. And then you hang the receiver at the center of the dish, and then you can receive all sorts of things. And you can change the direction of the receiver to kind of give it a little bit of a different feel. But essentially, it's a fixed point dish. So you're only going to be able to pass over parts of the sky once per day. But that's still very beneficial. So once a day, the sky is going to transit over that location, and whatever you're trying to receive can get captured. And Arecibo was doing this for many, many years. The benefit of this is you can map large areas of the sky. You know exactly that it's going to be the same area of the sky. Some of the ways that they utilize this is to monitor things like hydrogen gas across the universe, or tracking like radio bursts and pulsars, and just, you know, I guess waiting for the quote unquote wow signal of like, is ET going to reach out and tell us that they're going to hack our planet? I don't know. But again, the main thing here is that it's a relatively inexpensive and very non-mechanical way of building a big space telescope to capture signals from all sorts of places. So then we move over to a rotatable radio telescope. So here's 3 examples that I share. These are a lot smaller because making a 600-meter movable telescope would be quite a genius feat. So the largest ones up until recently have been around 100 meters. I'm sure everyone here is good on the whole metric to standard conversion thing, or do I need to do the times 300 feet? So yeah, these are big. One in Germany, radio telescope Eifelsberg, has been around since 1972. Green Bank radio telescope in the National Quiet Zone here in the United States. As a site, it's been around for a long time, but the current large one, the 100-meter dish, that's been operational since 2000, and it took them 10 years to build. The photos that I have here came from Google Maps, so I don't get sued for, you know, using somebody's photo without paying a price for it. You can see in the middle photo, hopefully some of you in the front rows, that's a shadow of the dish. So that's a huge shadow. So I think that's kind of cool. And then China, boy, they just have a lot of space out there to do all sorts of crazy projects. So like out in like the middle of the crazy desert, they're building a 120-meter dish. They started construction in 2024, and it should be operational by 2028. So if anyone's going to nuke the aliens, thank China. So they can move this around. And that's the benefit with these. So in terms of satellite terms, when you turn things like left and right, that's called azimuth. If you're going up and down, that's your elevation. And so this is all computer controlled with motors and, you know, all sorts of crazy stuff. And then it's all controlled where you can account for how fast the planet's spinning, so they could have it move opposite of the rotation of the planet if they wanted to really laser in on things. So just lots of really cool stuff in like the basement of these radio telescopes, even to like how they make sure that wires don't get pulled out, because if you're moving a 100-meter dish, you know, something probably is going to get snagged. So main use is very similar to depression-based telescopes, but of course you can do a lot more because you can move it. You don't have to wait for the planet. So up and down, left and right. You can track other things more smoothly. So if somebody wanted to examine Planet X or Galaxy, whatever, you know, these are what you do with that. And they're great for finding signals. So if it's aimed somewhere in the sky and you think that that might be really coming from that direction, or maybe not, well, guess what? They basically just rotate it 90 degrees to confirm that they're actually receiving something from outer space. So that's the benefit with these rotatable telescopes. And then we get into something that is called a very large array. So this is a series out in the west of the United States called the VLA. It's a series right now of 27 dishes that are each about 25 meters in diameter. I did like a little kind of zoomy thing there, but this is kind of really cool engineering. What you're looking at with these white dots, because you would have not seen the dishes otherwise, each of those tracks is a railroad that stretches 13 miles in either direction, and they can move all these satellite dishes on these tracks to change, you know, what orientations that they want. I think that's pretty cool. And if anyone remembers a real garbage movie from the 90s called The Arrival with Charlie Sheen, sorry, Charlie, I don't know him, but it's a cool movie, and like part of it had to do with him trying to replicate a VLA as a cable repairman, where he would take people's direct-to-home 20-inch dishes and through the magic of Hollywood, pretend that he was somehow able to sleeve them all together. And yeah, anyway, like I said, trashy 90s movie. But yeah, this has been around for quite a while. Built in 1973. It's been operational for 44 years or so. And the nice thing is, like, as they need tech upgrades, they just build another satellite dish and just wheel it out on the railroad tracks. So I don't know. Anyone here? Has anyone been out to the VLA? Okay, I'm going to find you later because I want to ask you questions. So thank you for volunteering. All right, and then we have something not in the United States. This is called the SKA MID. This is a multinational project. Most of it's in Australia. That's the dots. That is Australia, like part of the country where Mad Max probably spent some time. But their idea was to have like a 1 square kilometer, because they're metric, they're not standard, right? So 1 square kilometer, try to put as many dishes there in that square kilometer. It's basically up to like 200 dishes as the system. Some of it is in Australia, but as I said, international partners, going back to the whole Charlie Sheen, I guess down there, they found this a little late and said, hey, that's a good idea. So they got, all these dishes in other countries. South Africa is the second largest partner. And then they have some other ones spread out. The 7 founding members, you can see their flags at the bottom. There's also another 9 other countries. And then there's another 8 other countries that are planning to be part of this. Those 8 mostly are in Africa. So I think this is kind of cool. Like if they could actually get this thing all figured out, probably with some major machine learning and AI and, all sorts of super cool computer tech, it basically makes like the entire planet like one huge antenna. Taking questions at the end. Is that okay?
Totally, just about this.
Okay, cool. All right. So I'll pick on you after the other guy. So looking forward to the questions. I'm not an expert. I'm just pretending to be one on TV. So yeah, that's this. And I think I kind of already explained this. I'll just leave the words on the screen just for anyone who needs the words on the screen. But, some of the major benefits when you're spreading this out, it's like you can have like a 3,000-mile radio telescope, right? You could sleeve these all together. You can do hyper analysis. You can do a lot of really cool things to figure out where signals are coming from, or if you really want to amplify it in certain areas. So there's some really high resolution tracking that you can do. So it kind of, gives you the best of everything. It gives you the best of like those large depression ones. The costs for this is obviously a lot more. It also gives you all the ability to pan tilt and zoom if you want to be cheeky on that. So yeah, so that's what very large array radio telescopes are. So what if you all want to get into this and you're not like a out of work cable repair guy? What do you do? So here's the cool thing. There's lots of ways that you can go and build all sorts of things. I'm not going to get into like the infinite levels, but the easiest one is go on Google or whatever your favorite search engine is. Do a search for horn antenna. It's a really, really easy thing to build. You can go and spend money on weird supplies at Home Depot or Lowe's or whatever, and they'll probably wonder what the heck are you buying. So you can basically make a horn antenna out of fiberboard coated with aluminum foil and stuff. And where I currently work at ARRL, as part of the Teachers Institute, they have a module on basics of radio astronomy, and so. It's one thing to be part of amateur radio, but then when you see like people doing weird stuff in parking lots at like the mecca of amateur radio is kind of cool. So, during the summer months, they have, groups of teachers come in and, on the way in or out at lunch, you'll see like a bunch of these set up and they're tracking the sun and seeing like where 10 centimeter waves come from. And it's just all sorts of cool things. And so it's kind of an easy way to do it. And, if you wanted to do like long exposure, or any one of you that are into photography as an example, instead of using your camera, you're using an antenna to take pictures and think about whatever you've done in terms of like long exposure. We'll just leave this set up in your backyard and have it aimed in the same spot and record stuff and see what you capture. And the way that you're going to do that is connecting this to a software-defined radio. Those are pretty cheap. I bet everyone in this room probably has one or more. So you can get like an RTL SDR V3 for like 30, 40 bucks. You can get like a Hacker F Pro, which is a transceive capable SDR. So you're really only going to use the receive part. I would not advise you to use the 5 milliwatts worth of power to try to contact other planets, but you can. I'm not stopping you, but you know, you could. You could do all sorts of cool things. But yeah, a horn antenna, I think, is neat, and you can scale those to different frequencies and apertures and whatnot. But yeah, you could do research on that. So that's kind of the format for the 3 topics and kind of the bonus footage that I have at the end. All right, moving on to topic 2, radar systems. Anyone here, have you seen this in Cape Cod area? Show of hands. Has anyone driven past this? Okay. Of the people who rose their hands, do you know what it is? Okay, so like about a 50% downtick. So this is, if anyone's seen the movie Spaceballs, only one man would use Raspberry. It's Lone Star. So yeah, if you want to jam, good luck. You're not going to jam this radar because this is gigawatt power. So what actually this is, it's not like one single dish with one receiver or emitter. It's basically an array. So picture like 4,000 separate little dipoles cut for the different frequencies that they're using, and they phase them together. And so the magic of RF is when you phase things together, 1 + 1 in most cases with RF actually equals more than 2. So that's like cool. So if you've ever seen like ham radio antennas or other stuff, you know, for commercial reasons and wondered what they are, this is just taken it to an infinite level. And so the purpose of this radar system is for early warning. So if somebody was to try to launch nuclear missiles at us, ideally we'd have a couple minutes to go steal bread and peanut butter at Walmart, I guess. I don't know. But there's 5 sites spread over North America. The photo that I have here is the one to the furthest north up in Canada. And, you know, roughly these cover like 120 degrees. And what's interesting with these, the spectrum that they use is between the 420 to 450 megahertz range. How many amateur radio operators are here? A bunch? All right. So the nice thing is living in New York, we don't have to worry. We could use 70 centimeter spectrum and who cares? But our friends in Massachusetts and elsewhere, they can't. They're not allowed because it would potentially interfere with this mission critical gigawatt radar, and plus probably they're not going to work out too well because there's gigawatt radar there. So I think that's kind of interesting. It's also worth noting that 3,000 miles is the advertised range, but I've been told by very reputable sources that it goes much further. So if anyone ever gets a headache going out to Cape Cod, it's not from drinking too much, probably, or tell yourselves that. It might be from like standing in front of like the beam of the radar out there. So anyway, staying with the radar topic, everyone probably loves the weather. So NexRad, there's 160 sites. And so this is very different. You know, those sites for the early warning radar, they do what's called beam forming. So they can electronically steer things so it looks like it's physically pointing in one direction, but they can shift it in to the left and right and up and down just by some magic of electronic control. Whereas NexRad, you know, it's spinning around inside of a radome. There's 160 sites across the United States. And so you get all sorts of cool weather imagery and, you know, other things. And again, I didn't want to go into like an infinite, you know, presentation on the basics of radar. It's not the goal. But what I did want to get to is like showing what are some cool big things and then how could you replicate it? So this is a project I think that's been lighting up for everybody. I'm on the pre-buy, and it's like they keep pushing that release date back, and I'm like, damn it, you know, I just want my toy. So there's a thing called a quad RF, and so basically what the current version of this, and everyone feel free to stick your phone up and scan the QR code. It's just going to the crowd supply page. I'm not sending you to some sketchy URL, but basically this is the same basic idea as the large early warning radar using phased arrays. It's basically 4 antennas in the 5.8 gigahertz range, and you could do all sorts of things. You could visualize RF, you could track things, like you could do a lot of cool things. It's basically 4 antennas with a receiver and a Raspberry Pi strapped to it, and like one nice, easy to use thing. You could run around and do all sorts of shenanigans with this. So for anyone looking for an RF toy, this is kind of cool. Should be out sometime soon, I hope. But really, really cool project to look at. All right, topic 3, broadcast-ish antennas. Now, everyone remembers the little Ewok. Let's see if anyone can see the Ewok. I tried to do it to scale. So this is this cover photo is what's called a log periodic antenna, which the benefit is, hopefully I have this by scale, to appreciate how large what we're looking at. But basically the general idea is, think of like TV antennas from back in the day that, you know, maybe you had on your roof or your parents' roof, or, you know, some antenna that was not in use for 20 years that was hanging on by a thread or something. So this is the same idea, but just scaled for much lower frequency. So these typically are, you know, between like the 5 to 30 megahertz range. And so just having all these different elements, again, like a huge TV antenna, it gives you really broad coverage. The presentation earlier today on the HERMES project, you know, this is not like the antenna size that they're using, but these are the type of people, like in military and government, that are using these to cover broad frequency. So the left antenna is the world's largest log periodic. You can't really see it in the other photo. There's a series of 8 of these out at Offutt Air Force Base in the middle of the country here. It's the same kind of idea, but they're taking these log periodics and then phasing them together, you know, sort of like we looked at like satellite dishes. So if you wanted to beam an HF signal somewhere, you know, 4, 5, 6,000 miles or more around the world with like super signal, yeah, they can do that out of Offutt. And if anyone monitors the HF spectrum, frequencies like 8992 kilohertz, 11175 kilohertz, 13.2 megahertz, or 13200 kilohertz, those are the signals that are coming from here. The military wants to make sure a message gets through. Yeah, they turn the volume up to 11 and they have at it. So these are you know, some large broadcast type of an antenna. And maybe you might want to make one of these. Maybe you might want to buy one. You might not have the property to do one of those mega size ones, but the good people at the ARRL recently did a review on one of these, which is a commercial antenna, and it just published in our national magazine that came out this month. There might be some copies floating around over at the Wireless Village and Ham Radio World in the workshops. You can go and take a look, or chase John around in the white lab code and see if he'll give you a copy. I don't know, but we're saying, you know, we're keeping up on these things at ARRL. So again, this is cool that we had this coincidentally timed in time for this presentation. Moving on to broadcast things, and especially we all love free speech and all that fun stuff. Anyone familiar with WBCQ in Monticello, Maine? Who's listened to WBCQ since they came on the air? Who listened to the guy who's behind WBCQ when he was a radio pirate? So yeah, so this guy went from illegal to legal, which is actually a fun story. And so if anyone wants to read about that, and this huge antenna that they have called the Amphigon Array up in Monticello, Maine, which is not close to anything. It's way far. I've tried to convince my wife on a road trip to like stop on the way to Nova Scotia, and you can't do it. It's just not close to anything, but it's still pretty neat. So their frequencies are in like the 7 megahertz range or 40 meter-ish range for ham radio people, and they could rotate this thing, and it's crazy with what they have up there. But again, we probably don't have the space to build these things. But what we do have is the ability to buy wire, and you can make what's called a wire beam. And so K7 LED is this call sign. This past summer field day up in Washington State, wanted to have the most signal as possible. So with some creative use of some ropes and wires, basically created a highly directional antenna. And the benefit is when you're in Washington State, if you want to talk to everybody else across the United States, you're just aiming your antenna, you know, kind of cover everybody else, right? So they strung this up, kind of looks like a weird, axe murderer type of illuminated thing going on. But, if you want to build things like this, maybe you have like a friend or a second house up in the Catskills or whatever. Hey, if you want to make like a broadcast thing on the ham radio channels, go for it. I'm not saying that you should be involved in pirate radio broadcasting below the 40 meter band, which is an actual thing still. But it's been known that pirate radio people do things like antennas like this because you can't really see them. Or let's say if you were just looking for like the presentation from this morning, what if you're trying to get a signal out? You can have a backpack full of wire, and if you have the right time and motivation, you can set this up between a couple of trees and you can have a real killer signal with a very low power radio because you're letting the antenna do all the heavy lifting. And topics like this you can find in the ARRL antenna books. And then this one I'm super excited about. It's the worst possible photo, so I had to do some use of Microsoft Paint and lines. But basically, my friend Steve, N2JXL, who's a crazy RF guy to begin with what he does commercially, but in his spare time, he puts up huge kites. And if anyone has tried to launch a huge kite, you need to like lock yourself to the ground because you'll be pulled off into the air. So he just takes it like 9 steps further. So he makes antennas that are held up by kites on these low frequencies. He's done stuff in the 80 meter band at 3.8 megahertz, which is twice the size of the one that I have here. And you probably can't really see it well for scale because those the kites themselves are actually pretty large. But just putting this up and the feed line that connects to it, essentially like he has the best signal because he has this as high as he could possibly get it. And that's cool. So again, if you're looking for like some convergence on other crazy radio things, you could do that. All right, moving on to topic 4, other stuff for $2,000, Alex. All right, so with this, I kind of took a little bit of a local trivia tack. Let's see the photo. I'm not going to do the whole on my left, your left thing. The photo in the middle, does that look familiar to anyone? Anyone live in the Catskills? Have you seen that? Well, there was a large microwave network relay that spanned across vast distances back in the day. So these are exactly like those horns that I had on the earlier slide, but just in like a way different arrangement. And back then, it was easier to just, if they didn't have satellites or big networks of wires and fiber and stuff, they were shooting these huge long distance microwave links to transfer phone calls and stuff. And I've been told that radio intercept was possible. So if you really were like a secret agent, if you were able to somehow be in between the signals between these different sites, you could actually like listen to like 200,000 phone calls or something crazy like that. I don't know. But some of these sites are still around. They're not really in use. Some of them are. But again, just giving you some other ideas for some other large antennas. The other one that's not the Empire State, because everyone here in New York probably knows what the top of that looks like. So I'll hit that next. The other one is a pretty cool site in New Jersey. That is the Armstrong transmitter. They just ran a big kind of event on 40 megahertz, which was actually the original FM broadcast band. That wasn't the 88 to 108 megahertz that we know today. So they kind of spin that up every so often. So it's kind of in our backyard. So you got that down in Jersey. You got these different, horn antennas up in like Kingston, up in the Hudson Valley, and some other parts in Jersey and whatever. And then, of course, we have the Empire State Building. No big ape hanging off on this, but, it's a really complex antenna system. Lots of broadcasters up there operating in a real strange RF environment. So there's all sorts of big antennas all around us. So when you leave here at some point, look up. Takes up an entire city block, the Empire State Building. So look up, there's a lot of RF coming from there. And if anyone wants, I can show you a demo. I have a spectrum analyzer at the Villages table, and we could look at some of the different signals coming off of that in like the 500, 600, 700 megahertz range, which is kind of cool. And then we have amateur radio related moon bounce. I've covered this before. The guy on the black and white photo, Al, he recently passed away, but he was known for having like the largest dish to do moon bounce in New Jersey. So in North America, it was like him and this guy up in Alaska. So he had a big dish. It was a 30-meter dish. No, I'm sorry. It was a 10-meter dish, so it's 30 feet. Yeah, get the standards right. And then that other crazy lawn chair looking thing is like taking a lot of Yagi antennas, directional antennas, and mounting them and phasing them. And again, same thing. Lots of crazy RF. And if you wanted to make something like this, anyone seen this guy, Gabe? Save It for Parts. Pretty cool channel. I've 3D printed the exact same dish that he has. You could find the directions online, and then there's some commercial products on there. So that works pretty good, and you could do all sorts of neat things in L and S band. I had an article published a couple of years ago in 2600 on L band, so there's lots of cool things that you can do with that if you want to go scan around for things. Or if you don't want to build it, you could buy it. There's a project here. You could scan the QR if you just are one of those buy it now kind of people. So he also did a review on his YouTube channel. I'm not getting any kickbacks here, although I wouldn't mind, but just shouting out, he's a pretty good presenter. And wrapping things up here, learn more, come and visit. I hopefully kind of encouraged you to see, like, there's lots of RF, there's lots of applicability to amateur radio, but if you don't want amateur radio, that's fine. There's still other cool things that you could do just as a receive only and build cool things. We have a couple books available if you want to become a member of the ARRL. You can come and chat with us about that. We have some other swag that doesn't require that. If you're just a cool person, we might give you some stuff. So come on and swing by in the Villages area. And the last slide is signal intercept. And this is what kind of messed me up, because a friend of mine showed me his slides in advance. And I was like, I got to take a slightly different tack. But this, I think, acts as a good primer for this, because what Joe is going to go over tomorrow at 11 o'clock, no, Sunday at 11 o'clock, is using AI in the relation to amateur radio. So hopefully your takeaways from that, because he's light on the antenna stuff, hopefully this gives you an idea, because if you have a really cool antenna, you could do a lot of really even cooler stuff, because if you know if the signals are there, capture them and analyze them. So that's it. Thank you. And I think we're good on time, right? Yep.
Thank you very much. We do have time for some questions. Just line up at the microphone. I just want to remind you to keep your question in the form of a question. But yeah, if you have any questions, please ask.
Well, we know we had 2 question people from before. All right, Mr. Red Shirt. No? Okay. All right.
Do you know how they're correlating data in that South African radar array?
How are they
Are they doing any data sharing between sites?
They are, yeah, and that's the cool part about it, is the fact of just thinking about the distances between South Africa to Australia. They're kind of in that southern hemisphere kind of area, so that helps. But yeah, you know, they have like direct links, high speed data, low latency, but also some of what they have, if it's clearly time stamped, they don't need to do real time signal analysis. They can just do it deferred. They just want to capture it and then check it out later.
It's all government funded.
Yeah, I think National Science Foundation may have tossed some bucks their way, but yeah, for the most part, you know, it's all, you know, funded at the national level, and it also is really cool because you can see in real time how different countries are actually working together to solve cool problems.
So just to tie in the death rays and the aliens, where would HARP fit in terms of size relative to the antennas that you've mentioned today?
Yeah, so I really wanted to include HARP in here, but I think just because it's been around for such a long time, I didn't really want to bring it in. HARP, for those that are not familiar, is a project up in Alaska where they send high power RF up into the atmosphere. And there's all sorts of different theories as to what they're doing, changing weather patterns or whatever. But it's kind of the same idea, you know, phasing antennas. You could do a lot of cool things when you're combining antennas together. They have different spectrum that they use. Most of it's in the HF range. Fairly recently, I remember seeing something where they run like hey, we're going to be running HARP. If people want to go and find our signals, have at it. So you can actually monitor those. And there's also like another radar system I did not include in France called Graves, which is like the 143 megahertz range. And same thing, like you can monitor that too. I don't know if that really answers your question much, but HARP is like its own, like it's its own topic on its own, right? Like I think I could have easily killed 30 minutes on any one of my single slides. Bueller, anything else? No? Good? All right, thanks.
Thanks, Steve. Okay, so in 10 minutes in this room, we have Poisoning the Well, how decoys and misdirection protect privacy when opting out isn't enough. But yeah, that'll be at 6 o'clock in 10 minutes. You're free to go. All right, it's time to introduce the next speaker. I'm Al. I'm 19 years old. I'm 6'7", and I have a net worth of $73 million. Anyway, here to tell us about generating synthetic noise for your personal data, please welcome Rachel Vrabeck.
Okay, thank you, Alex. Okay, how many people here have tried to remove or opt out of data collection before? Nice. Okay. Oh no. We'll roll with it. So since 2020, I've been helping people submit over 5 million removal requests. In the last 2 years, I've become less satisfied with the level of protection that removing data from the internet gives people who are actually targeted. So general scrubbing can be effective, but the rise of social media attacks, AI systems, and new regulations require us all probably to adapt. I mentioned decoys and misdirection at the time of submitting this proposal, but I spent the summer with some very smart people in security and have come to realize that this falls into a 1980s military strategy called denial and deception. It sounds obvious, but one of the most effective privacy techniques is just to deny access to the data in the first place. And if it's not out there, you don't have to remove it. So the other thing is, if it does get out there, you want to make your attacker slip up, trigger a warning, or waste their time. This is a harder problem that involves sequencing methods, human and engine or agent optimization, and most challengingly, coordinating with the person we're trying to protect. Big note, this is all still very experimental, and there's a graveyard of dead tech projects attempting to do deception at scale. You can ask the Mozilla people about that. Okay, so how did we get here? Well, we spent almost $1 billion in protecting personal data over the last 15 years. I can do math. About 15 years ago, there was the initial emergence of the data removal industry, and it coincided with the rapid expansion of social media and also Snowden's revelations about the NSA. Then in 2018, we all found out about Cambridge Analytica and the Facebook involvement, revealing how little the maintainers of these systems cared about protecting people and their personal data. And at the same time, Europe enacted GDPR. And this actually was where I first got involved in this whole concept, because I was active in the 2016 presidential campaigns, and coming out of those had a lot of questions. So by 2018, we had done some research in this space and had started submitting our first of those 5 million removal requests. Then you had like 2019 to 2021. This was the pandemic era where nearly 1 billion new internet users came online. And the market for personal data protection grew with that surge in internet participation. So VCs saw that, and they asked themselves, can this be the next LifeLock? And so a small batch of companies emerged and evolved into the services you might see advertising on YouTube today. I benefited from some of that initial funding from Mozilla, but I haven't raised money since then. 2024, California has ramped up their CCPA protections to fine companies for violating their personal privacy. And at the same time, removal services have become so popular that Consumer Reports has decided to do investigation and publish a report on data removal efficacy. So some of you may have read that report from 2024. But that was 2 years ago, and it's 2026. And just this month, the California government launched their own removal tech called DROP. It's tied to Delete Act. And enforcement is the most critical piece here. It's the only thing the California government can do that no one else can. And they haven't started doing that. I talked to the folks at the California Privacy Agency, and they told me, they have to set up the systems, they have to submit the request, they have to track the violations, and then it has to be reported to the court system, and then the cases have to be made, and then you'll start seeing enforcement. So we'll talk about that maybe in 5 years. And then investment-wise, on the government side, California has deployed $5 million to building this system. They're going to continue funding it by fining data brokers and requiring them to pay $10,000 a year to register with the state of California if they qualify as a data broker. So it's a pretty nice cash machine they've built over there. And then private funding, in the last 12 months alone, there's been over $500 million deployed into companies in this category, mostly through growth equity, private equity, and debt equity. Okay, but like $500+ million going into protecting people, and removal rates have gotten worse. Oh no. Oh, there we go. Okay, I don't know what the rates were in 2010, but they were pretty good. People were operating with requests when they really needed them, right? The only people who were thinking in 2010, hey, I'm going to reach out to all these sites to get my data removed, are the people that like really think about it. And then by 2018, when we started doing this, they were also pretty good. Like people were responding to requests. There hadn't been these big systems built around rejecting them. In 2020, there were a ton of civil issues. Obviously, we're all pretty familiar with those. And that made other companies more sympathetic to removing people's data online, especially when like the only place to be during the pandemic was online. But in 2024, the same year as the Consumer Reports study came out, we started seeing pushback, and the data broker industry started lobbying against the regulation that was being passed and beginning to say no to a lot more requests. So we had to manage a lot of difficult sites. And while some companies in the space stopped reporting difficult removal rates or removal rates with difficult sites included, we continued to report on those sites that were just not responding to requests. And you kind of had this situation where people were like in a rat race to say they were, or like in an arms race to say that they were reporting the highest success rates and then just ignoring huge categories of risk. And that's pretty much what Consumer Reports revealed. And at the time, it was pretty shitty, but they were on the right track. Now in 2026, an honest reflection of our system's ability to keep data deleted is very concerning. And I think it reflects what is going on industry-wide. Our 90-day removal rate, not just across brokers, but across X, Google, OpenAI, is now down to 48%. This is like a 90-day removal period. This is all we do. And it's not just us tracking this data. Like, thank goodness we have folks like Bloomberg reporting on California, the state of California's efficacy rates too. And they just came out with a piece at the end of July, highlighting the millions of denials that have been tracked publicly through the California system. And like I said before, you have all this exposure on the internet. It only takes one thing to be right, an attacker to get the information once. And so you can't really be satisfied with a bunch of denials. And so, yeah, it only takes one exposure to call into question all the work that we're doing. Okay, what keeps us up at night? Like I said, it's that problem. It only takes one exposure to make 99% of our work effective. And so we've started to think about this problem as a team on how do we make these attackers spend more time, more money to be right. So we're buying time and signals. This is the team I work with. It's Colleen, Michaela, Stephen, Hannah, Nikita, Joe, and Ash. We're all publicly listed on LinkedIn, so I'm not doxing anybody here. But like 5 million requests, a team of 8 people. This is like an existential question for us. How do we restructure our work as engineers, data scientists, and marketers and researchers so that we feel like our work is worthwhile and we have the will to keep going? How do we set members' expectations around what is possible and how much it will cost? How do we actually disrupt personal attacks in a measurable way? And for the last 6 months, we've been piloting decoys and other deception techniques internally with our own team and externally with some of our more targeted members who have volunteered their time, their safety, and their feedback to help us learn. What I mean by decoys ranges from like email masking to burner phone numbers to address confidentiality programs, and I'll get into the details here in a second. We've also been referencing other work in this field because this is not a new field, like I mentioned, like Caleb Sema, Michael Bazell, Rachel Toback, Troy Hunt, and just a lot of other conversations happening here around what it means to track personal data on the internet, disrupt attacks, and add noise to a system that is increasingly hard to remove yourself from. Okay, I'd like to talk through all of our clients' cases, but I can't do that considering how badly they're being targeted for their work. So instead, we get Colleen, our newest team member and head of customer success. She joined about 6 months ago, and it was a good opportunity to test these deception techniques in a fresh way and to see how the landscape has changed with what's working and what's not working. So we'll follow Colleen's story through this talk, showcasing what we've tested, scaled, thrown away, and started again on, and what's worked and what hasn't. And then we'll highlight other examples from our customers as we go. 7 techniques that we've distilled so far, and you can use these at your own risk. 1, mapping visible systems and assuming permanence. 2, using masks when probing for those systems' weaknesses. 3, befriending your county assessor. 4, creating noise with profiles on trusted platforms. 5, leveraging protected identities. 6, new identity creation. And 7, qualifying for your address confidentiality programs. Okay. So Colleen lives in Arizona, and it's one of the objectively worst places for privacy in the United States. Sorry if anyone's from Arizona here. And despite having worked at the Bureau, hunting down child abusers, her information is very out there. Whenever we onboard a new person to Canary, we talk about joining the company, testing our methods, getting feedback on the software with new eyes, and debriefing on their own attack surface and threat model. So for Colleen, she kind of always knew this was a risk. In fact, she employed a lot of the tactics we now use while she was at the FBI, but she was never told that there was something she could really do about it. She also never felt personally attacked during her time at the Bureau. So we met her when she was working at BugCrowd with a bunch of hackers on their platform, and she said it was sort of a light bulb moment to think about this disruption. So we have a system that's pretty good at harvesting data to show you your risks across social media, search, aggregators like data brokers. That's what is sort of hard to see here, but you have a bit of like a radar system. So plotting the types of exposures we're finding across those sources against low risk scores to high risk scores as you get closer to your target. And we agreed that her home address exposure was the most concerning thing she'd want to prevent so that her family wouldn't be impacted by her work. Okay. So for Colleen, the bright spots on this map represent the address exposure that we came across that rejected removals. And the dark spots are the removals that we're making progress on or were completed. And you can see that we are removing data, but it only takes 1 exposure. So as these sites are investing in blocking requests, now that they have clearly defined legal loopholes to do so, the cost of removing data increases. A few examples. It's like the ChatGPT logo there, OpenAI, cyber background checks, and Radaris. After 3 to 6 months of trying removals, we start to assume permanence on those records without some other significant change to the approach or the improvement of the situation.
It's been glitching in all the talks. Just let it be. There's nothing.
Okay, thanks. Okay, so we're still mapping visible systems and assuming permanence, the first technique. We don't have enough time to go through all three of those examples, OpenAI, Radaris, and cyber background checks. So I'm just going to focus on this one, cyber background checks. So we're going to do a deep dive here. We challenged ourselves to find a way to manipulate the results positioned on page 1 of Google and cyber background checks since those removals were being rejected. Google was caching the result, exposing Colleen's home address, and you could search it up with just her name. So this made it to one of the high priority things to fix because, yeah. Again, you only need to be right once. So then we mapped where the data was flowing. Turns out, this is not just a single site. It's a site that's a member of a network of data. They were developing a tool called Skip Sherpa, which is mostly a developer tool for background checks. Then they also were powering another tool called People Finders, which also fed Truth Finders, which then fed a property database called Property Reach, and then was overall managed by Informio, which is an identity verification provider. Robert Miller seems to be the chairman of the whole operation. I have a little screenshot of his LinkedIn there. Hello, Robert. He's getting paid every possible way for this data under companies that claim to do background checks, property checks, and identity flows through Informio. And what's really interesting about this is the state of California actually pays a company called Socure in their data removal process to do identity checks. So California is not owning that information technology. They are outsourcing it to a company that's very similar to Informio. But when you check the data broker registry on California, Informio is registered as a data broker, but Socure is not. So you can start to just see how this model breaks down where everyone's like, oh, I just wish the government would handle this. And it's like, okay, cool, the government's handling it, but this is how the government's handling it. So yeah, when removal isn't an option, our goal is to intercept the data flow somewhere in this diagram to inject noise, inaccuracy, or alterations. That leads us to technique 2, using masks when you're probing that system for a weakness. We started probing the network and trying to probe a system without a mask means you're going to expose your identity immediately and trigger an alarm when you contact them. So it kind of depends on how intense you want to be with how you mask your information, depending on the complexity of the system. Obviously, a temporary email address that's just a throwaway is pretty easy to just go to a website and generate, but it's not very believable. And then getting down to using the person's actual email and account, so kind of operating it as a third party is very difficult for a lot of different reasons. But that is the most believable way to kind of start intercepting. We didn't believe this data network was very sophisticated. So they were using automated bots for support and likely very low trained offshore human labor. And so we started with easy and cheap masks that worked pretty well and then worked our way down the list. So we started to use temp emails, which allowed us to kind of get some of that information about the organization, like who was involved, whether systems were automated or not. And then we started to get blocked. And so then we decided to jump to using a personal Gmail to try to get the information faster. So you can kind of see the email generators at the top there. You can go through the hoops of generating Proton mails. Managed Gmails are pretty good. So that's where we landed here. That being said, this is a specific case, and generating Gmails, most of you maybe have done this, is getting harder and harder and harder. Google knows how valuable a Gmail address is, and they've made it very difficult to automate. So we used to, just a couple years ago, maybe even months ago, be able to build Twilio workflows to interact with text-based 2FA, but now they're doing physical QR codes that require you to text back authorization. And so getting a single permission Gmail is actually, there's a lot of friction there now. So it's slow, but it really works. So if whatever you're doing makes it worthwhile to spend that time, you might want to do that. I'm pretty sure there is a way to hack this, but we're still figuring that out. Luckily, we never needed to use Colleen's personal email, but in some cases, like a social media platform, you might decide to do that. And then I will note another technique we've used in the past here for email masking is personal domains and just buying up a bunch of domains online. We were running thousands at one point. This could be a whole nother talk. If you are interested in how to do that at scale, you can talk to me after. And just taking a step back here to demonstrate why a mask is useful. These systems are professional aggregators of information. Many of these systems have no moral issues with turning any information you send them in an email or the email itself into a new data package. So using a mask goes beyond just the fear of being blacklisted or triggering an alarm, like I mentioned before. You don't want to become their target. So when we run this at scale, 5 million requests, we are figuring out the inputs, who you're sending, or who you're sending to, how it's sent, what the email says, obviously the content. You send it, and then you map the outcomes of that request. So you could get a denial, you could get a malicious response, you could get actually the removal outcome you want, or you get partial compliance. So that's kind of the framework we follow as we're measuring the efficacy of masking. And just to show the data here, because I don't think people talk about this being a problem in general, but don't measure it. So we took a sample of our 2025 emails. So there's 925 unique emails generated, 23,000 requests sent. And of those 23,000 requests, 12,000 led to malicious responses. You want to do this obviously at a site-by-site level. So which sites are sending malicious responses? But at the global level, that's 51%. So it's very common to try to contact a site that is harvesting your data and then have a malicious response come back, or have that data being passed to a different actor who sends a malicious response. Okay, so after probing the system, it turns out most of the data is collected by scraping unprotected county assessor databases for property records. And I think most people know that. And Arizona has zero proactive protections against it. So the third technique is, how do you befriend your county assessor? We traced Colleen's information to the treasurer's office and the county assessor's website. And in our interviews this year with other members on our service, about 25 mentioned being in a relationship with their county assessor, in a consensual relationship with their county assessor, about gaining some level of privacy on their home records. The line we're hearing from more and more sites, again, in terms of this increase in denial rates, is your records do not show you are living in a state with privacy regulation, so you are not eligible to opt out. And like back in 2020, when we were really ramping this up, we never saw that because there were still humans on the other side who understood that this stuff really mattered. So digging into the automated portal for Colleen's County, or hang on, not here yet. Okay. So digging into the automated portal for Colleen's County, you can see there's actually a way to update your mailing address. Changing an address in Arizona requires proof of ID. But after that, the address is updated and mail starts getting routed to the new address, and the record listed is different. So this essentially wipes out most records that are being aggregated at the levels that we kind of showed before on that map. All the search engines, the AI engines, they're just kind of trolling these sources. If you can kind of take it off the board or replace it, like you would in this case with a different address, that changes, the downstream. But it requires maintaining a second address. So that would be a hassle for Colleen given her relative threat model, right? She's a customer success person at a tech startup. There's no real targeting happening to her right now. So we're not going to go this route. But again, like I mentioned, over the last 6 months, we talked to 25 people who have gone this route and said it's worked really well. But the problem with scaling this is there are 3,144 counties in the United States. So it's very effective, but it's very niche in terms of what you might need to do. We've seen success in Virginia, Oklahoma, Tennessee, Wisconsin, Montana, and a couple others, but highly experimental. We've seen like once you do this, maybe 3 months for the data to refresh. Okay, this is mostly a good time check for me to make sure we're tracking. We've covered 3 of 7 techniques, 4 to go. I promise the next 4 are a little bit faster. So because we decided not to pursue the county assessor updates, we wanted to see if any additional profiles across trusted platforms could somehow feed noise into the system. We wanted to simulate Colleen moving to California, where she does have privacy rights. Step 1 was to purchase a home on Zillow in Sacramento. For the case here, we just adopted this address across a series of profiles with the images, but we didn't do anything here to manipulate property records in California, purchase records, deeds, or any other records that might mess with someone else's ownership. And I don't encourage or condone anyone doing that because that would be very illegal. But with the new location selected, we could start sending requests to sites to update the address on file. This has worked in the past for us. They were rejected this time with cyber background checks and that data network specifically. But in 2024, we saw a lot of success with this method. But again, with the automated data loops checking identities on the back end, this has gotten less and less effective. But we started seeding this information across other trusted platforms we know are scraped for PII. So we created a duplicate LinkedIn profile with the slight change in location, and that was really easy. So if you haven't done that, just try it. It's really fun, really easy. No validation required. Masked email present. Decoy address present. And we affiliated Colleen with Canary too, and we were never notified. So if you're protecting a company from this type of decoy placement by malicious people using your profiles for interviews or whatever, you might want to look at this too. So, okay, we created this about 6 weeks ago for Colleen and haven't yet seen the new information propagate. But with other clients that have had 3 to 6 months of these profiles present, we've seen the data show up in the locations we'd expect. So that's this profile feeding hiring databases like Signal Hire, and then Signal Hire feeding Google and ChatGPT, and then that profile feeding something like a cyber background checks. So it takes time, but you start to see where these systems can feed other systems and then provide authenticity to the information that you've placed. Okay, technique 5, leveraging protected identities. Again, I've mentioned Colleen's customer success tech, not directly under threat. I didn't think technique 5 would work. But while we waited to see if the data scrapers would populate from the other profiles, we looked more closely into the Arizona legal code and noticed that being a peace officer can include FBI agents. And peace officers have special rights to privacy under Arizona law. And Colleen is a former FBI agent. So the law states that if you're a current agent, you can have these protection. But we decided to try our luck. Like I literally sat down with Colleen. I was like, I don't think this will work. We were like, well, we'll try it. And so we tried it with cyber background checks first, because that's the target. But as we were probing these companies, we discovered that Skip Sherpa, cyber background checks, and Truth Finders all had automated support systems. And so there was no human customer support agent responding to any escalations or appeals. But when we appealed to Property Reach, the property records company, we got a human rejection. And so we crafted an appeal that referenced the former peace officer status and mentioned escalating concerns. And that worked. Within 24 hours, the data had been removed. And it hadn't just been removed from property reach, it had been removed from the entire network. So all those sites I listed before, completely wiped. Well, sorry, all of the sites in this network. Here are the other protected identities eligible under that law in Arizona. In the case of Colleen, that technique worked. We found a human with empathy who was able to ignore regulation and system level rules to take this action. We didn't have to provide proof, by the way. And again, I never advocate for anyone misrepresenting your information or committing fraud. But you can look at these identities for your state and try to map them onto you, your team, or your family members, and then really push the boundaries. With Colleen, it was a former status. And with others, it might be proximity to a field or a legal case. Anything to bring context to a request, if you have someone on the line who is capable of finding an exception and has a heartbeat. This is something we've actually gotten very good at because we work directly with our customers and we just are able to map context on trying to find that gray area as we work our way through systems. It takes creativity, but it works. The problem, again, going back to like the general shift in the industry, is you're finding less and less, or like fewer and fewer humans. You're starting to see a lot of these systems being orchestrated by hard rules, regulatory loopholes like the identity verification players, and then they lead to, for regular people, just endless automated rejection. So that's where our deception work with Colleen ended. It was fairly successful, and we'll continue letting the accounts that we've placed mature and see what happens. And Colleen continues to keep a fairly low profile, but what if she was publishing a book or going on tour or participating in a political campaign? She'd want to start creating new identities for fans and followers who do not need to trace her to her legal name and family and home address. And we'd want to make these profiles really loud, because having these profiles leading in your online presence makes the first step of denial easier and ultimately requires less targeted deception. If monitored appropriately, these can be early signals for someone trying to dig in further to your actual identity. So just 2 weeks after the masked email for Colleen was created on Gmail, 2 weeks after we created that email, it had received 60 emails. We didn't placed it, we had only placed it on her LinkedIn profile. Most of them were spam and promotions, but a few were targeted profile views being triggered by that LinkedIn profile. And so similar data can come through DM and social media platforms as well if you set up these identities. And it can be really noisy, but it can also be very useful in terms of pulling signals with some light scripting. We've tracked Reddit, PayPal, LinkedIn, Instagram, some other social accounts. Creating them is the easy part, but maintaining them and not slipping up on that core data you want to protect is very hard. If you want to manufacture one of these, making it as close to reality is going to be the best way to go, because it's difficult to generate randomness and difficult to convince humans to keep up with the story. AI is extremely good at generating these profiles. You can see some of the images that were generated as we were thinking about setting these up for Colleen. Creating and burning these can be very expensive, so it depends on how believable you want these accounts to be, but just keep that in mind if someone does start targeting it as a fake account, burning it and creating a new one can be very hard. But at the end of the day, placing a decoy is better than just trying to stay hidden, because people love mystery, people love a challenge. And so if you have a decoy out there directing traffic from someone who's trying to find you, it's better to have a place for them to go versus just having this big mystery unfold on the internet. So these are the profiles. This is like creating entirely new identities, similar to trade names like you might see with businesses. And I think we're going to see this evolve in the next couple years, but there just is no good tooling for this yet. So something we're thinking about. You can also try to do things entirely anonymously. I mentioned Caleb Sema before. He says that he bought a car anonymously in a recent blog post. So if you're interested in reading about that, I can share that with you. But again, people are very bad at this. They out themselves. Caleb outed himself with his car. I accidentally outed myself using one of these when I booked a dinner reservation. Even Mitt Romney has outed himself when he was running that fake X or Twitter account. And then finally, escalations happen. Our final technique is state address confidentiality programs. It's obviously not affected if you're targeted by law enforcement or government, but it can be extremely useful when we experiment with this, where people's eligibility qualifies them, like abortion access movement participation, if they've been a victim of domestic violence, or if they are active in law enforcement. So I already kind of mapped this out, but public records are often the source of feeding these targeted attacks. And so if you need to do something bigger than just going to your county assessor, this is a way to do that at a larger scale and have the state on your side as you're trying to get these things fixed quickly. But you need to be willing to relocate, route your mail through a government proxy, and experience delays in mail delivery. So each state has laws that outline exceptions and qualifications, and some states have no laws. So on the left, that's the shame list. Boo, no program. And then on the right, if you're from Minnesota, you literally can enroll for any professional reason. And I just don't think people understand that, actually some states want to provide protection for people here. And then obviously there are other states like New York or California where you have to prove and qualify that you're an abortion worker. But it's pretty interesting options for people to think about if protecting somebody at this level is important. I would point you to the Safety Net Project. That's where I got most of this information. They're a great resource for finding out if you qualify in your state, who to reach out to. There are a lot of victim advocacy programs that you can work through. And we've been experimenting with supporting some folks on that. All right, so those are the techniques. Before you pick a deception technique, consider its difficulty, effectiveness, prevalence for the people you are ultimately trying to help. Feel free to take a screenshot of that or a photo of that. I think mapping's a no-brainer. Most people already are doing that. It's like just Recon 101. And then obviously the address confidentiality programs are very hard and not very prevalent, but are extremely effective. And then one bonus technique, proving you're human. These are all the CAPTCHA types that we've run into doing this work. My favorite one, my favorite one is this bee flies around and you have to tell them which flower the bee hasn't landed on. And that's how they know you're human. All right, thank you.
So we do have some time for questions. You can walk up to the microphone over there. I just ask that you remember to put your question in the form of a question. We have about 9 minutes or so for questions.
Hello. My question is, I'm familiar with Michael Bizel's techniques regarding addresses. I'm curious, in your experience, does having a PO box offer enough obfuscation of an address, or do you need to go through setting up a trust, buying a house in a trust? I guess it depends on your threat model, but I'm just kind of curious what you've seen going through that experience.
I've seen that identity laws no longer allow you to list a PO box on your ID.
Yeah.
So we kind of stopped recommending that for certain cases. In general, it might help with spam. Yeah. And then that county assessor technique, you can't switch your address to a PO box. Yeah.
Thank you for effectively describing the daisy chaining of data and how it's disseminated throughout all of these organizations and companies. But I think some more public visibility on this might be really useful. And I'm wondering if you know of any reporters, journalists who have done any stories, or have you worked with anyone to describe some of the daisy chaining of data that goes on out there and have written about it?
Oh yeah, like too many to note. Your face belongs to us. I'm gonna forget. New York Times reporter. I forget her name. Other reporters doing research around this, like Yael Grau was really big on this for a while. She sort of stepped out of the. She maintains the data broker opt-out list. Even just the Bloomberg reporter we were working with earlier this year, Cassandra Coyer. I can send you like a list of 100 people. There are a lot of people doing good reporting work. Yeah.
That's awesome. Another question. You mentioned when you were trying to get people opted out, essentially, and you mentioned receiving malicious responses from the companies. What does a malicious response mean in that context?
Oh, advertising.
Got it.
Like you send them an opt-out request and they've obviously stored your email on their marketing list. And then also malicious is like phishing attempts. So probably not from the domain of the company that you sent the email to, but somehow your email ends up on a phishing list.
Thanks so much for your talk. I wonder if you know of anyone doing research for poisoning identity verification systems, or how to kind of try and access that data that's been harvested by various, like, for example, for myself, there were 2 different banking applications that I had to do, and unfortunately they strong-armed me into doing the identity verification. I'm wondering what I can do to kind of claw that back.
Clawing back. Well, again, removal and poisoning are 2 different things. Right. So, that's really tough. I don't know. Maybe we could talk about it after. I mean, I like these systems are so well protected now. Again, like Socure not even having to be registered on the California broker list is how like bad this is. Yeah, I might have to think about that one. Obviously, like there's credit correction rights and stuff. So if there's something wrong on your credit file, you can go to the big 3 and say, hey, this is wrong, and get it corrected. I wonder if there's similar processes for identity verification systems, but I'm not entirely sure.
I was wondering if we could get this guy, Robert Miller, with Cyber Background Check's home address. I actually, what I wanted to ask, you had South Dakota on the shit list.
Oh, yeah.
I'm sure they don't have privacy protections, but they do have this nomad identity thing where you can literally make your address on your driver's license a trailer park.
Oh.
An RV park, I should say.
I should have that up here.
I just thought.
No,
I wondered if you had messed with that, but I guess not.
No, I mean, again, this is experimental, so this is great to know. Thank you.
And then more of a general question, but I don't know if you're allowed to shill. Could you talk about price structures for Canary services?
Am I allowed to talk about that? Maybe you can talk to me after if you're interested. Yeah.
Texas also allows nomad status. So
Okay, nomad status. We'll put that in part 2.
All right, everyone, let's thank Rachel again. Thanks. Okay. Try saying this 3 times fast. Fully homomorphic encryption, fully homomorphic encryption, fully homomorphic. Almost got it that time. All right. Well, to tell us about fully homomorphic encryption, please give a warm welcome to Vishak.
Hello, everybody.
Sorry, one technical note, we're having difficulties for the online viewers. We are not able to get the screen streamed directly, but online viewers will still be able to watch it over his shoulder on the webcam. Sorry about that.
Hello again. Friday, 7 p.m. Instead of dinner, you guys are at a talk about fully homomorphic encryption, so you're all certified nerds. And I'm grateful that you're here. But do check out Koreatown. So one of the crises of our time is we're all sort of disaffected by the present, and we're having trouble imagining a better future. But one thing to consider is a potential future where everything is encrypted, right? Always on encryption. And at a conference like HOPE, I don't have to go into why that's a good thing, right? Like if everything is encrypted at all times, we're all fundamentally more secure, we're more free, and we overall have a good time. So for people who work with encryption, encrypting stuff is easy, but then you have to, you can protect your data by encrypting it, but then at some point you have to operate on it. So you have to decrypt it. So that is a long persistent problem in the world of privacy and security. But we have a possibility now of changing this and doing things in a fundamentally more secure manner. And that's what I'm here to talk about today. And that's why we're talking about fully homomorphic encryption. So one note, I'm a builder, I tinker with stuff. I play with fully homomorphic encryption, or FHE. I'm not an academic, I'm not a researcher. This talk is focused on building with FHE. There are many smart people at HOPE, and I'm sure if you have a very theoretical or very technical question, we can find people to answer them. And I am using FHE in my own work. I work on an app called Monadic DNA, and it uses FHE. So this all comes from my practical hands-on experience of working with FHE. So, you know, this is HOPE. I don't need to tell you guys a lot about this. This is a fundamental problem of our time. All our data, every kind of data, is sold, breached, and it's farmed. And we're in this grand conference over 3 days, and we're trying to find ways of protecting ourselves, of doing things in a better way. So I think this is one of the potential futures. And if we can make this work, I think we're going to be in a fundamentally better place. So with that said, let's still review the current paradigm. What happens if you use an app like Facebook or Instagram or whatever? The app provides you a service, which is an endless stream of content that you can look at all day. But in return, you know, the data is stored on their server. It's convenience. But the moment your data in clear text is stored somewhere else, the person storing it has direct access to it, and they effectively own it, right? Possession is something of the law. So that's the current paradigm, and it's not great, as we've seen. So there's a variety of pets or privacy-enhancing technologies today that for the first time are performant, scaled, and developer-friendly enough that they can be used to do things in a better way. So today I'm focusing on FHE, but I think it's good to mention the others as well. So MPC, or multi-party compute, lets a variety of counterparties operate on data without any one counterparty having access to all of the data, right? So you can run some computation on a cluster, and no participant in the cluster will be able to decode the data unless, you know, the whole cluster is corrupt. So MPC is pretty powerful. It's great for doing collaborative computation, right? Like you can bring data in from a bunch of different sources and people can compute on it. Then there's zero knowledge proofs, ZK, where it's all about verifiable computation. So you send your data off somewhere, someone operates on it. Not only do they return the result, but they also return a mathematical receipt, which absolutely establishes beyond all reproach that indeed a certain computation was performed on a certain piece of data with full mathematical certainty. So in combination, MPC and ZK with FHE offer a new paradigm in which we can build a fundamentally new class of applications. And hopefully, I'd hope maybe 3 to 5 years from now, we're going to be talking about this stuff as if, it's just plain bread from the supermarket. So this brings us to fully homomorphic encryption, FHE. That's what we're here to talk about today. So let's switch to FHE. So FHE, as I said, lets you run code on data without decrypting it, without looking at it. Once the data has been secured by the user, right? Like, let's say, there's some biographical information about yourself that you're sending off to the government or a giant corporation. They'll still be able to operate on it. They'll still be able to kind of approve or deny you or whatever, but they won't be able to decrypt the information that you've sent. And I think that's pretty powerful, as you can imagine. You can prove all kinds of things about yourself, or you can gain all kinds of useful insights about yourself without ceding your data to governments or giant corporations or people who are not necessarily the best at handling your data. So how is this possible? Well, a lot of complicated math. And as I said, we're not getting into the math today, but this is something that has been speculated upon for decades, right? Back in 1978, for the first time, at least on record, people first started speculating on whether such operations were possible, right? Like under the hood, it's a bunch of integer operations. Can we take a bunch of integers or basic logic gates and operate upon them in a manner that they're encrypted without decrypting and still performing computations? So proposed in 1978, but finally invented in 2009. So, it took 31 years, but we did it. People were really happy, but the initial versions of homomorphic encryption, while academically interesting, they were not super performant or super useful in day-to-day life. So over the years, many different schemes of FHE have been invented. It doesn't matter precisely what they are, but 2012, we had BGV, BFV. This is for very precise math where you can easily compare numbers. So for databases, you can have encrypted data, operate on it without decrypting the data. So I believe MongoDB uses, or there is a module for MongoDB, which is a very popular commercially available database. Using the magic of FHE, you're able to store encrypted data and run queries against it. There's also CKKS. It's named after these, I believe, these Korean researchers. And that's really good for basically linear algebra, which means it's good for machine learning. So obviously, right now, machine learning under encryption is not going to be anywhere near as performant as plain old machine learning. But as you know, machine learning, artificial intelligence in general has become a very important fixture in our lives for many, many different reasons. Algorithms make decisions on our finances, basically on our lives. And also a lot of people I hear are using LLMs out there. So all this can be done more securely if this stuff scales, which we'll talk about later. And then finally, there's TFHE. That's a thing that I personally use a lot. And it's good for writing arbitrary programs. So you can put, a bunch of if-then logic. It's kind of like coding for the ENIAC, or you see the first vestiges of this new way of writing code. But you can take arbitrary business logic, or you can take arbitrary algorithms, and you can implement them in FHE land. So that's generally the overview. So let's kind of take a little technical digression. So I realize the screen is small. Everything may not be visible. And I'm happy to provide the slides to anyone who's interested. But can you guys see this all the way back, more or less? Okay. So I don't want to spend too much time on this, but generally how it works is you can imagine a client-server architecture where there's a bunch of users, right? So there's a bunch of users on the left. Doesn't matter how many. We're zooming into one user on the right side. What does the user do? They generate a key pair. So for normal applications, we're all used to having public and private keys. Under TFHE and certain varieties of FHE, you generate a client key and a server key. The client key you keep to yourself, like your private key. Do not ever give it to anyone. The server key goes to the server. It's still linked to you, but it goes to the server. And anytime you need to perform some operation, you take your data, you encrypt it using your client key, which is only known to yourself. You send the data off to the server, and presumably you have already sent your server key to the server. And then on the server side, all they have to do is use the server key, and they're able to run an FHE program to compute a result without decrypting the data. And then they return the result. In this case, it's 85, whatever. It goes back. And then the client, using their client key, is able to decrypt the encrypted result. So the result is only viewable to you or the user and no one else. So I don't know how well I conveyed it, but basically, there's not a lot of overhead, right? Like imagine writing an application using this stuff. Well, for every user, you generate a couple of keys, you shoot one key over to the server, and then you just encrypt data on the client side, send it to the server, you just store it, maybe they keep it transiently, but they're able to compute on it and send you the result. It's not that difficult if you just kind of ignore the diagram. A little bit of code. So on the client side, this is some Rust code using the TFHE RS library. So on the client side, you generate some keys, you encrypt it using the client key that I told you about, you send it to the server, and then once you receive data from the server, you can decrypt it using your client key. And then on the server side, like I said, I think the code is pretty self-explanatory if you can see it, but the server just uses the server key to run some code. What I should have done is shown some Rust code for an actual computation, but it's just Rust code. Like the SDKs, they just support people writing programs in Rust, and they just compile into FHE land. So basically, as a developer, you don't have to learn anything fundamentally new. As long as you know Rust, or in certain cases Python, you're good to go. So Apple, whom a lot of people like, they use FHE. So are they using it extensively? No. But are they using it in production for stuff that you guys use? Everyone who has an iPhone here, you're kind of de facto using it. If you use the Photos app, the way that it recognizes landmarks nearby without compromising your privacy is by using homomorphic encryption. So if you scan the QR code, blog post explains it more, you can have a look. And then, the other people, Google, they use FHE. So truth be told, I'm not 100% sure whether they still have a production deployment. They certainly put out a bunch of tools, compilers, developer tooling, etc. But at some point, the password breach tool, I think, used FHE. So again, QR code if you want more information. And you want to ensure that I'm not just making all this up because it sounds rather implausible. So you should use FHE. And I'll tell you why. Because it's actually practicable right now. Like it sounds a little bit like magic, like the first time I heard about it, I thought it must be either academic or it must be a little bit BS, like people make all kinds of claims. And then I wrote some code. I'll tell you about it. So FHE as a technique has come a long way. A lot of times stuff gets invented in academia, and it's great. And maybe some people get tenure, but it just kind of languishes, right? And it takes a long time for it to hit production. And the internet famously started as ARPANET, DARPANET, blah blah blah. And by the time Al Gore invented the information superhighway, 25 years had passed. But here, the blockchain industry raised massive amounts of funding through various means. Wink. But there were a lot of privacy nerds in the blockchain industry. So a lot of money was spent on formal verification, advanced cryptography techniques, blah 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 blah. So a lot of that money which we assume went to offshore locations, but actually a lot of money went into pretty meritorious research. So that really accelerated the development of FHE as a practical day-to-day library. And then Zama is a company built around FHE, Zama.ai, and they raised $150 million in total. Some of that went into research. Phoenix is another company that raised $22 million. They're also doing some interesting work. There were other companies like Sunscreen that also, they raised funding and they worked on FHE implementation. And then, Google, Microsoft, Apple are also doing their bit. So the result is not only do we have a proper developer experience, but we're doing really well on benchmarks with every passing year. And by we, I mean, like the people of planet Earth. So this progress has really come a long way. So between 2009 and 2020, I would say 2023, we came a really long way from something that was a toy to something that could be used for a real application. So I'm going to talk a little bit about the things that have made FHE easy and the things that are making it hard. And I hope there are some developers at least over here that kind of hear what I say and at least give it a shot, right? Like you have free time, you're at a conference, like you have some time to kill. So why not spend a little bit on this stuff? So one thing that's really great is the proliferation of mobile devices, right? Like everyone has a mobile device. And most mobile devices now have really good secure enclaves. They're really battle tested, they're productionized. We know we can really trust them. So it makes key management really easy, right? So remember, for using FHE, you need client keys, server keys, blah, 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 blah. Well, generating keys becomes really easy on your mobile device, which, by 1985 standards are supercomputers. So you generate the key and it goes into a secure enclave. No other app steals your keys. It's all very nicely secured. So this makes the user experience really good because you don't really have to do anything extraordinary. You generate the key, put it in the enclave, boom, like you're on your way. So Android, iOS, all the other sundry OSs, they all kind of support it at I believe, the hardware layer. So that's really good. And then the secure enclaves, in many cases, they have cloud sync. So your iOS, the thing, I forget the name, but it synchronizes across your devices. So as an app developer, you can generate keys in one instance of a user's app. They move phones, well, it just magically ports over to your same app on the user's other device. So with a lot of privacy apps, there's a lot of friction with keys, right? Like remember when we were all having key exchange parties and ceremonies and stuff like that? It was just really impracticable, right? Like it's just really hard to work with keys unless it's kind of supported in the device that everybody uses for 9 to 10 hours a day. So that's a huge plus. That's really good. And if you're in the audience and you're kind of skeptical, I don't blame you, because I think without being a mathematician, you can imagine that computing on encrypted data is very, very expensive. And you know what? Conceptually, you're right. Like compared to computing on clear text, it is very expensive. But about a couple of years ago, I did my first benchmarking of an FHE app. I was playing with genetic data, right? So I took 2 million rows of genetic data, right? And I encrypted it using my client key. And I did it on an M1 Mac Mini, 8 megabytes of memory. Like, it was the cheapest Mac Mini I could buy. So I ran this experiment encrypting the payload, 2 million rows of plain text. It took about 2 minutes. Now, in most cases, you don't have 2 million rows of data to encrypt. In most cases, you have, I don't know, name, age, date of birth, place of birth, I don't know, like 10 little things. But even with a substantial data set, 2 minutes, not so bad, not so bad. And then I ran some algorithms. This is 2 years ago, my first foray, and I was able to iterate through an entire data set of 2 million rows in 2 minutes. So this is, you can imagine if you did the same experiment at that point on the server, with a lot of cores and resources, it would run really fast. So this is basically the worst case. So I believe apps written using FHE are performant enough now that if you're building an app that kind of qualifies, you're going to have a good time. Your users are going to have a good time. So if you are an app developer, you want to build a truly privacy-preserving app, I think it is worth your time. But there are issues, right? Like you are taking a blob of data and then you're encrypting it in a manner that it's still useful, right? Like if you obfuscate something to make it useless to other people, that's really easy. But if you're encrypting something and obfuscating it in a manner that's still useful to other people, that's really hard. So ciphertext, the encrypted version of the data that you're protecting, that gets really big. So I took a couple of years ago, or maybe it's been 3 years, time flies, 5 megabytes of genomic data, it blew up to 300 megabytes after encryption and serialization, which means by the time the data made it to the server side, it blew up to 300 megabytes. And the server keys that I told you about, any app provider has to store server keys, 1 server key per user. If you're lucky enough to have 1 million users, well, 30 megabytes per million users, someone do the math, that is non-trivial. Having said that, storage is not exactly super expensive these days. It does keep getting cheaper. I know the Micron stock's going up, but I think overall, directionally, storage just keeps getting cheaper. However, in order to compute on data, you do have to load it into memory. So these giant blobs of encrypted data on the server side, you have to load them into memory. And this is back to the old days. If you coded at all in the 80s, you had to be very, very parsimonious with memory, right? Like you had only so much memory and you had to do a really good job with it. And in a sense, we're kind of back to that, right? Like you have to be very cognizant of how your app uses memory and handles it. So if you have a very successful app with 1 million users and they're sending stuff all the time to your server, well, you better have a lot of memory, or you better write something that's really, really, really memory efficient. And in recent years, because compute has become so cheap, we kind of have lost a little bit the art of extremely parsimonious coding. But it is something that we have done before. It is within our remit, and we can do that again. But just be aware that this issue does exist. So we're talking a lot about developers and users. So user experience is really important. A lot of times in a technical discussion, user experience kind of gets left behind. So always the question is, oh yeah, fancy new technology, but are people going to use it? So first, a disclaimer. There's always going to be friction with always encrypted data, right? Like it's always going to be a little bit more awkward to use something that's relatively new and more secure. It's just easier to use something insecure. But the question is the friction insurmountable, or is it something that people are willing to use for benefit that they can recognize? So key management, as I said, is solved. It seems pretty good for the user experience, unlike PGP or many other things that were tried before. And ultimately, server-side compute times are good. If you throw enough compute at it, you will be pretty responsive to the user. Now, maybe it's not so great for sub-second, super low latency apps, but for everything else, I think we're there. And remember, most of the penalty is when the big blob of data goes from the client's or the user's device to the server, and that's a one-time penalty, right? Like you can imagine whatever the app, most of the data gets sent off in one shot, and then after that, it's all just like incremental uploads. So as long as your user is patient for once, then they're good. Like they don't have to suffer. And I recently did this, like outside of the FHE world, I bought a smart scale. It was from one of the more privacy conscious providers, and it needed 10 minutes of pairing. But I want it to be in better shape, so I spend 10 minutes, and then after that, it's working like a charm. So I appeal to that and say that good UX is indeed possible. Also, one of the most wonderful things here is, once again, just like machine learning or video games before that, hardware acceleration comes to the rescue. So if you had an Atari 2600, there were only so many games you could run, and then people moved to like PCXTs and da-da-da-da, but still, right, something was missing, and then people start putting video cards in there. They start opening them up and putting video cards, and then you could play more fancy games, right? So it's somewhat similar over here, right? Like just as for machine learning, the widespread prevalence of GPUs really was an unlock. It's the same thing over here. Like there's GPUs everywhere. They're in people's devices all over the world. They're on server farms. They're in data centers, and so on. And FPGAs, which are, for lack of a better explanation, printed circuit boards, they're also pretty pervasive in finance, healthcare, even in AI now. So we understand really well how to use hardware acceleration to bring performance to niche and high value computations. So just as there are data centers for AI, or there were some efforts to run accelerated video games on the server side. Companies like Niobium, they're offering FHE clouds. So they take the core FHE algorithms, and then they use ASICs, FPGAs, GPUs, and that brings a 10x, 100x, sometimes 1000x acceleration, depending on the kind of code you're running. So this is particularly good for machine learning, a lot of linear algebra, matrix multiplication. You can take that stuff. You can take the core algorithm, and you can really offer it as a cloud service. So Niobium is a company. I'm not related to them, so I'm not shilling. These are just some companies that have solutions. So Belfort is a company based in Belgium. In my experience, they deliver a 10x speed up to my genomic workflows. But otherwise, for machine learning workflows, sometimes they have 100x acceleration, in some cases 1000x. Zama itself, they use GPU-based acceleration. They claim they're going for 10,000x acceleration in the next couple of years. Niobium, we talked about. So orders of magnitude of improvement. I would say 2 orders of magnitude improvement has already happened, and several more orders of magnitude improvement are reasonable to expect. Beyond the corporate hype, it is credible that this is going to happen soon. And they said the same thing with the cloud originally. They say the same thing with AI. They're saying the same. The story as old as time itself, right? With scales, the unit economics improve, and scaling is its own virtuous cycle. So a lot of really good work being done on hardware. So basically, all I'm trying to say is, if you're building an app that uses FHE, do try one of the acceleration solutions, because you're going to have a much, much better time. So one must make certain mental adjustments. So, if you really want to optimize, or I don't know how it is these days, but back in the day, if you really wanted to optimize a video game, at some point you'd have to exit your nice playpen in C++ or whatever, C, C++, and you'd have to descend to the Hades of assembly land, and you'd start writing in assembly. And why was it so niche to write in assembly? Because the mental model is different. You deal with registers, you deal with pushing and popping data, blah, 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 blah. It's hard. It's not easy to write in assembly. Therefore, only a small proportion of even game developers write or wrote assembly. But once you get used to it, you start coding as if it's your natural coding environment, right? You go slightly deranged, but you find yourself productively writing assembly code. So there are some mental adjustments, so this may be a bit specific to TFHE. There are other FHE schemes with their own trade-offs. So the common mental adjustments are lookups. So let's say you have a hash table and you want to look up the value of a key. Well, that's not a O of 1 lookup. That's a linear scan. Why? Because equality is hard to handle. So there's something called bootstrapping. Let's not get into what it is, but basically precision has to be maintained somehow. People dealing with floating point numbers might be familiar with the struggles of actually representing and proving the equality of numbers. But equality is hard under certain schemes. So saying that comparing the results of two calculations and saying that indeed the two numbers are equal is actually a little bit fraught. It's possible to do, and at some point it becomes natural, but you have to kind of train yourself to figure this stuff out on the fly. But yeah, the mind adapts. The human mind, very ingenious. But honestly, it's a type of derangement. Once you start coding in FHE land enough, it is very hard to go back to writing normal code. Something about working within constraints makes it really hard to be released from the constraints, right? Like you're used to being inside the monkey cage. Now they let you out and there's a blue sky and you're like, what do I do? But which is to say that you do get adjusted really fast and you have a good time. And remember, you're still coding in Rust, you're still coding in Python. So it's not like you have to do something fundamentally new. You start like, you have to start like blowing into vacuum tubes or whatever. No, it's just, you're still doing what you normally do. Yeah, so one of the issues is there's a lot of vendor lock-in. So there are many different FHE schemes and there's many different libraries. This is a screenshot from the Wikipedia article on FHE, on homomorphic encryption. And you can see there's many, many different libraries and there's many, many different schemes. So we have a complex grid of implementations. So what does this mean? It's really hard. So you really, like you take it for granted when you use regular encryption libraries that once you encrypt something, pretty much anyone in any other language will be able to decrypt it based on off-the-shelf libraries. But here, it really depends on which library you use. There is a standard open library called OpenFHE, but it may or may not have the latest and greatest, right? Like you want to deliver a successful application, you're going to use the library that actually works for you. But then you're locked into a vendor. You maybe, for commercial purposes, sometimes you pay a license fee. And you really hope and pray that the vendor is still around in 10 years. Otherwise, you're going to have to write some math code. Maybe not the worst thing. But yeah, there's not really been any real effort to standardize, Like you take all this data, you encrypt it, and then you kind of change libraries or you change cloud or whatever. You just want stuff to work. At this point, it's not really possible. It is a pain point. There's no good solutions at the moment, but hoping this gets better in the future. And then most of the time, this is not an issue, right? Like most of the time you build apps where people are just doing stuff that involves their own data, right? Like Facebook, maybe that's not a great example, but yeah, like a astrology app. People are just looking at their own astrology. You're not looking at the aggregate horoscope for New York. Although now that I say it, maybe that's a great idea. But it's hard to do with FHE because, like I said, every blob of data is encrypted with an individual user's client key. Now you can do many different things. You can use a common key for many users, blah blah blah. Complex key exchange. You can use trusted intermediaries, but you kind of like undermine why you're taking all these pains to use this really nerdy thing called fully homomorphic encryption. So that's not great. But Neobium, which has its own encrypted cloud called the Fog, they support machine learning workflows. So that is acting on aggregate data. So that might be a good approach. I can't say, but that is a problem. And sometimes maybe it's a good thing that you can't operate on aggregate data, right? Sometimes it's good that the government or a big corporation, they're only able to do your thing for you and not able to just kind of scan over 10 million people's data and then like make accurate predictions about them. So maybe it's not a bug, maybe it's a feature. But yeah, just before you start working on that encrypted ML app, just want to let you know, you may not have a great time. In fact, you will not have a good time. So little demo. So I don't mean to shill, but I've only built one app. So, and this is an alpha. It's not, no money's involved over here. So I'm just going to play it I just want to let you guys know, in full disclosure, some bits are sped up because this is a time-bound presentation, right? So there's only so much time we can spend. So a lot of people have used 23andMe. They gave their most precious genetic data over to these people in Palo Alto, and it turned out to be a not so great thing. But this is a demo which shows what you can do with FHE, right? Like, can we take our genetic data, upload it somewhere, and then you get insights without the service provider being able to peer into your genetic data and be able to do bad stuff with it. So keys are being generated, like I said, client key, server key. Key gets stuck into the secure enclave of your iPhone or whatever, Android device, whatever. So that happened, keys got generated. So now I regretfully did 23andMe a long time ago, so I'm providing my 23andMe data to this app. So that's getting encrypted. So like I said before, even a 5 megabyte payload can blow up into 200 megabytes. So that's essentially what's happening over here. So you can see the encryption process takes a little bit of time. It's not great, but it's not horrible. And it just keeps getting better. It just keeps getting faster and faster every 6 months. So my data as a user just got encrypted locally on my device, and now it's being uploaded to the server. So as you can see, to make it realistic, when I recorded this video, I used a not so great mobile connection, just so you don't see 5 bars LTE and think, being very optimistic. So this is a very humble connection, and the data is being uploaded. So just to be clear, this has been sped up. I don't know if it's 2x or 5x, but I did speed it up, just full disclosure. So data is on the server. Huzzah. I said huzzah. Any moment now. Yay. Okay, so my encrypted data is now on the server. So now we're inside this app experience, and now as a user, I'm able to run all these reports on the server, right? Like, I want to know what's my lactose intolerance like, what's my muscle performance, or whatever. In reality, these are trite insights that 23andMe and stuff used to provide back in the day. But it's possible to much, much more. But since I'm not shilling, I won't tell you more. We're just replicating what 23andMe or any other service does. A little bit of processing. So this, right now, what you're seeing is on the video that the data is being analyzed on the server. So it's not being decrypted. Some algorithms are running on the server to find out my traits. And they just got calculated, and now my app is telling me that I may not be able to taste bitter flavors and I'm meant for sprinting, which, I think that's more or less right. I've never tried sprinting, so I can't say. I used to drink a lot of coffee, like a lot, unhealthy amounts. And that's why today I'm doing FHE stuff. So that was the demo. So you see, is there like, I'm not, this is real. You can use FHE to build an app. So here's some resources for FHE. You can scan the QR code. It'll take you to the FHE community, FHE.org community page. Now, here's a few things to note. FHE.org is very academically oriented, and I have been to academic FHE conferences before. I have presented as the local humble developer, and so if you want to build something, I would rather go to the Zama docs and start building with their library, TFHE-RS. And then if you like it, then you can pick a library that works for you. So OpenFHE is a library that is truly open source and is sort of a standard just between you and all of you guys and those watching from home and me. Just between us, it's maybe not cooked for prime time, but hopefully it gets there soon. And obviously, if you're a gigabrain, very smart person, then please contribute to the library. I think this is something very important to do because, as I said, this imagined future where everything stays encrypted at all times using privacy enhancing technologies, it is perhaps one of the solutions for us to kind of break out of the current morass and just be somewhere fundamentally better. So I think, a lot of things pay really well, but maybe not FHE yet, but I think this is really worth working on. So please, if you're very smart, make these libraries better. So that's a lot about FHE. Please, I want to leave some time for questions. If you scan the QR code that goes to my blog, I have some articles up about using MPC, FHE, and stuff like that in the real world. And just to show a little bit, I work on something called, I contribute to Monadic DNA. Not saying you should use it. It exists. Make of that what you will. And you can follow me on the socials. So questions, if any. Thank you.
So I'm curious about the trade-offs involved in between having to do a lot of extra upfront processing at the client device. Presumably you're doing that because you don't want to have to do all the heavy lifting, and that's why you're sending it to the server in the first place. But if you're compensating for that by, for example, you said most of the time we're talking about relatively small amounts of data, like a username or whatever it is. You don't ever want the server to know what that is, and it's a small amount of data. In those use cases, why not just do the processing on the client device? Why go through all of these extra steps to have it done at the server?
I think that's a fantastic question. And honestly, if you're building privacy-conscious applications, you should try to do as much local processing as possible. Now, there's some issues with local processing, which is why most apps are not locally processed. So the number one thing from a UI UX perspective is asynchronous stuff. So you do want people, you can't have people just kind of hold their device and it be online all the time, right? Interestingly, on iOS, your app can get maybe 15 minutes of background time before it's horribly murdered. So you have to do asynchronous processing, right? Sending notifications and stuff like that. You have to do it on the server side. So that's why you have to pay the tax of doing all this processing, sending payloads off. And, if you could just do everything on the client side, we wouldn't be in the position we're in right now, FHE or not. And just for UI, UX, better engagement, server-side processing is needed, and hence FHE is a solution.
I'm going to pepper you with questions, and you can just answer the ones that you find are important.
Okay.
But kind of going off of the client versus server side question, is it possible? It seems like it's not really ideal to do streaming, let alone like threading from multiple devices or data sources. What is like the most advanced application of that that uses FHE, and is it just too unwieldy for a beginner to FHE to even try? And then the other questions are, you mentioned with Apple Photos, like they use HE, not FHE, and so how much does the F really add? And if we
Wait,
just
let me answer those
okay,
two because
okay.
I'm kind of losing context, and then you can keep going on. So the first one was streaming and that kind of thing. Well, like in theory it's possible, but I think the libraries are really just very, very Spartan, like they're built in a way that it'll get you up, started, running, and effective. And the cost of these libraries having a security vulnerability is really high, because at the end of the day, a single large breach would be really, really bad for the company or the industry or what have you. So threading, threading you can use to handle requests from many, many users at the same time, right? For a genomic application, you can, if you want to offer people an insight into their cardiovascular risk, well, you can run a million threads, right? Over many instances. But streaming, I feel that's a bit off. That's not really available at the moment. And then what was the second question?
HE versus FHE, and can
right.
you, yeah.
Well, okay, so Apple can get a little bit annoying on terminology. Initially they insisted on calling it Apple Intelligence, although it had the same initials as. So, to the best of my knowledge, from what I can glean, they do indeed use FHE. But yeah, you're right. Like you do not need to, if to really use fully homomorphic encryption to have basically encrypted mathematical operations. But I do think, from what I know, that they are using FHE.
Okay, and then my last is I think it's really funny that you use 23andMe data, which is like the most privacy, like devastatingly. Anyway, so like the pain point there is, I guess, that the thing that does the sequencing has to upload your data to something. Do you know of any sequencing stuff that just immediately encrypts the data? Like
I can't shill, so like I'll answer your question in person.
Okay.
But yes. Okay, well, see me in person, because that would be shilling.
I'm curious about use cases other than genomics. It certainly, I can see why and how genomics could be, a very popular FHE kind of early stage use case. What else have you seen? What other kinds of software or hardware or whatever is there that is really kind of seeing a real opportunity?
Yeah,
with
let me
FHE?
be descriptive first, and then I'll be normative. So descriptively, it is definitely used for decentralized finance. So Zama, I think they have for decentralized finance protocols, they're using shielded pools, and they have, I think one of their pools has maybe order of magnitude $10 million in it, which doesn't sound very impressive, but $10 million is still, basically $10 million more than currently available to me. So that's still really good. And previously, I did work in finance for a bit, and we did some POCs using FHE for confidential trading. So one imagines that a lot of that is going on, and as the decentralized finance effort, as it scales more, I think it's going to be more common. I think in healthcare in general, there's a big opportunity because there's so much sensitive data that's leaked all the time, and it doesn't need to be, because like I know we have extensive health files, but it's actually not that much data, right? Like it's not that much data. Like it's okay to encrypt it. Like it's okay if your hospital has to do a computation on your data and it takes 2 minutes, unless like you're in the ICU. So healthcare is an excellent domain. Like we don't want our healthcare data leaked. And then consumer finance, right? Don't want it leaked. Very trivial data. And then I'll just say normatively that we do have the option of using rules and regulations to encrypt all the things, try to keep everything encrypted at all times, right? Like even if there's a performance penalty, like it might be a civic good to enforce that.
And I'm afraid that's all the time we have for questions, but you can find Vishaka out in the hallway. Thank you very much. Let's all give him a hand again.
right. Should be an HDMI on here too.
Hello. Okay. Hello, everyone. I'm Elix. The talk is Wardialing IPv4, What's on HTTP? It's a story about a website project I started in the beginning of the year. Let me just go ahead here. Oh. So, yeah, if you had a monkey type IP addresses into a web browser, how long would it take them to find a website, a login page, a dashboard, your smart fridge? So, why am I doing this talk? After I started working on the project, I realized that it's just a remix of a bunch of ideas and things that people had already done. When I started, I hadn't even thought about things like Shodan, Census, or Rapid7, and these folks that are, scanning the entire internet in, a matter of a day or whatever. I was partially inspired though by things like I always stand like ScanRand. I remember it was a really big thing when ScanRand was released, and the ability to scan large amounts of IP space in a short period of time. Oh, sure. There's a very similar. I realized after someone had made the comparison to Shodan that sorry. John Matherly, the creator of Shodan, had done a TED Talk in 2014, and it was kind of like Fuen's because his original motivation was very similar. It was just kind of curiosity, and so the results that I started to see, I found very exciting. I was very giddy to just see what was updated on it. And I first attended Hope almost 25 years ago in 2002, and the opportunity to speak and to give back is, I appreciate it very much and wanted to share the excitement that I'd found while I was creating this thing. And it was a giant learning journey as well. So in the first few weeks of generating IP addresses and taking screenshots, I found some things that were just super statistically improbable. It didn't seem to make sense that, within 4 to 6 weeks of generating just random IP addresses and taking screenshots, I was finding things that, there's 3.8 billion, I think, or 4.8 billion usable IPv4 addresses. So if you were just punching in numbers, the chances of hitting some of these websites didn't seem to make sense. I'll be interleaving each of the my bullets, the textual content with screenshots of things that I actually found. So the main thing that the program does is there are agents that capture screenshots, and you get a live feed of them as it goes. But so please don't get mad if I talk about or show your web server, but it's just hitting the default pages. So, but just going by IP address, there's no vhosts or anything. There's no host header being delivered with the HTTP requests. So it's only what the default vhost is. And I found one of the things that came up in the first couple of weeks was the 2600 website, which I thought was really strange. But I don't think it's actually it's strange. It was up to date, but looking at the stuff, it's the GeoIP assigns it to a Japanese net block, and it does redirect to SSL, but the CN was for a maxping.de, like a German FQDN. So I thought that was weird. Like, I'm pretty sure it's not. I mean, 2600 has always been like false.2600.com. So it's very strange that this random IP had up-to-date mirror with one broken image and the other images all loaded. So I'm not entirely sure what's going on there. I want to start with a little quick history lesson that in 1991, the University of Minnesota brought the first popular hypertext to the internet with Gopher. That was where I started on the internet, but I'll get to that in a minute. But it's by 1993, so University of Minnesota changed their licensing and started to charge for the Gopher server, and it was definitely a different time because everyone just said, oh no, and bounced from Gopher. Around the same time, coincidentally, was when the web was starting to gain some traction, and Mosaic was released and changed everything, and the Gopher decline started to really really decay at that point. HTTPS didn't gain traction until later on, but Gopher also has been making comeback. There's the stuff like the Tildeverse, people running flogs. There's a couple of nice like blog aggregators on Gopher Space, which is pretty cool. And the small internet is a movement that is also worth researching in itself. Yeah, this talk is pretty much going to be a bunch of rabbit holes. I'm going to try to move things along quickly, but yeah, I'll make the slide deck available after the fact because I'm going to just touch on and throw a lot of things out there as we go. One of the things that got Steve Jackson Games, the top is not showing, so we don't see the logo, but that popped up and really within the first couple of weeks as well. They have a neat tie-in to hacker history, which is worth a look. It really just made me start giggling when I saw it pop up on the dashboard because they had a part in hacker history with the Secret Service battle who thought that their card game was something, a manual for computer hacking, and yeah, that was just another thing that made me very interested in continuing running this thing and seeing where it would go. ICB, I saw the ICB website pop up, which is the predecessor to IRC. It's a super old like talker type protocol, almost similar to like D-Dial or some of the really old school like line by line kind of chat. It wasn't, I think it was line by line, I'm not sure, but it predates IRC very slightly. So yeah, around the time that Gopher was decaying, my local library started offering a dial-in thing with their card catalog where you could get Gopher access. And I was in elementary school at the time, and my elementary school said, hey, we have access to the internet, and it was Gopher. But I didn't know that Gopher was decaying at the time, but that was the new internet. And I was like, wow, this is amazing. So I got very familiar with all the stuff that was on there. That soon got the addition of links as the web was getting released, and I realized that they would let you follow telnet links to other like free nets or other BBSs and MUDs and things. I wound up like eventually making an Angel Fire page through links that would just had a bunch of telnet : / links to all of my, because the only access I had online was via the free library dial-up service. So I would use it to connect to MUDs. I made a plain HTML page with all of my favorite MUDs, and eventually I found like free shell accounts, and there's things like, back in the day, there was nether.net, and I remember clearly public.lank.ru, which was very interesting, filling out their subscription form via links, because it didn't render the Cyrillic character set at all, so it was very much guessing what all the form things meant. But also like free shells and SDF.org, which is still around. but all of those were like my way of getting to anything, because then I found out, oh, you can get a shell account and then type telnet in the thing and do it yourself instead. I didn't really know much about what I was doing back then, but I knew how to play MUDs. Then in 3 years later, a kind stranger introduced me to 2600. I was sitting there reading the Cyberpunk handbook, the real Cyberpunk fake book by Are You Serious, which is a hilarious read. But I was very young and sitting there giggling, and some guy walked up in a green trench coat. I remember the very tall guy with long hair in a green trench coat came up and said, "Don't read that, read this." And he handed me a copy of 2600, and it was kind of a wrap from there. Everything kind of started to take off. I didn't get cable modem or graphical internet till a few years later. But over the course of all that, I developed this long, slow process where I would seek out random BBSs and MUDs on the internet using Nmap. One of the things that really surprised me was the first MUD I ever played, Nightfall, which has been online since 1990 and got me into LP MUDs. Also found a 68K Mac. This is actually running on a Quadra 700 68K Mac Club website. It looks like it actually has a POTS line connected to it as well, which is pretty cool. But my first real desktop PC was a 68K Mac. This really cool BBS popped up on there, which is the Alka Holiday BBS. They had really great ANSI collection, and I saw the Topaz font, which is the original Amiga font, and I was just sold immediately. But it's down now, actually. It looks like it was running on a Raspberry Pi. I tried sending a message to the admin saying, "Hey, what happened? Your thing is down now." But I've got a screenshot and a record of it on my thing. It was up recently, well, earlier this year, but unfortunately it's no more. I found a lot of things like that. So yeah, my process to look for random BBSs, I would usually do like a nmap-ir where it would generate random IP addresses, and I would give it a few arbitrary port numbers of just things that like a MUD or a BBS would use. I'd be pretty noisy back then. I would just throw a whole bunch of them out there. I would set it running to output in a greppable format, and I would like leave for work, and I would like set it in a bash in a for loop to run infinitely and run it for like a week while I went to work, and then eventually I would come back and I would come back to it, and I would just make like a loop that would go through the things that were open, or it would be a multi-phase process that was just pretty clunky, where I would grep out the open stuff and then do like a netcat loop that would output all of the banners to maybe like pipe echo a couple of carriage returns or some stuff to try to elicit output, and then I would wind up with a huge text file after. I would also let that go for like a week and just let it run in serial, and it was a long, slow process, and eventually like grepping out the things that were too common, like user access verification, the traditional Cisco banner, which used to be one of the most common things, but not so much anymore. But as you would grep out more and more of the not interesting things, all the boring and login prompts and stuff like that, the interesting stuff bubbles to the top. It's called NetStumbler, which got your Pringles can ready. It gave me a chuckle to see NetStumbler come up on there. So every few years I would get the itch and I would revisit the process. That's why it's so kind of fuzzy in my mind, because I would do it slightly different each time, and I never really, I don't know, it would be so long and arduous. But I like it because it kind of gives you a sense of the demographics of the internet. Like I was able to mention like user access verification as being like Cisco had most market share for network gear back then, and yeah, Cisco had a big chunk of open. But as the times change, you see different things about the surface area of the internet and what things are populating it. So I started to sketch out the automation of it in Jupyter Lab, following the old approach, and then came out with a what's the word? Sorry, like a mock-up, like just a dummy page that of what it might look like with real results, but it was just a static web page. I was using sub-processes to grok the output, but I realized that was reinventing the wheel, so I started looking at different Python libraries that let you leverage Nmap. I wound up settling on libnmap, which I found actually uses the nmap -x, the XML output of it, gives you way more information than anything like most of the normal output options or anything you see at the console. You wouldn't have an idea that Nmap actually has all this stuff going on under the hood. The other thing that jumped out was that I was just getting mostly HTTP responses, so I was like, damn, everything runs HTTP these days. And I found insecure.org, the actual Nmap site, popped up, and that gave me a chuckle. So after seeing so much HTTP, I had done a little bit with Selenium, and the main thing that I did with it was like outputting screenshots throughout the process to, oh, where did the browser get stuck at? What's on the screen? Oh, take a screenshot. Okay. So it's like, I know how to do that. So that was when after seeing that the vast majority of things now speaking HTTP on the surface, ditched the search for MUDs and BBSs and figured, let's just see where this goes with taking screenshots of everything. I added port 80 into the mix, but still was, throwing some arbitrary random ports in there, like 3,000, 4,000, 5,000, like the common things that got open for HTTP listeners, also like 8080 or 8888. And then I was like, this would make a great thumbnail gallery. That's where I got ahead of myself about the mock-up, but that's where I created kind of a flat page of the dashboard. I also was like, what else can I enrich this data with to make it more interesting? So getting like the whois information. I really like the idea of visualizing all the IPv4 space. So wanted to incorporate that. And of course, I love statistics, so it was like, what other statistics can I get from it? That was the early dashboard and the early visualizations of the IPv4 space. Yeah, so the IPv4, any 4-octet IP address can be represented as a long int. So, and with this, by converting them into a long integer, you can use the first 16 bits on one axis, and the basically half the IP address is the first half is the bottom, and then the second half is the y-axis. So the like 0 through 255 would be across the bottom. I found out, since I'm seeking HTTP now, I realized that I could explicitly use Nmap to identify what things are speaking HTTP. The -SV is way more complicated than I had expected. It has a whole internal database of like what protocols are expected or statistically popular for a given port. Like, for example, I don't know, 1080 is usually like HTTP proxy server, but it could also be running anything. Any port could be running any service, but it's not going to waste the time fingerprinting or trying different protocols on it. But long story short, I went with level 4 makes sure that it sends all the HTTP probes all the time. Everything above it is noisier. I wound up taking the whole Nmap source and ragging an AI with it, so that way, and asking it about, how does this work and what's to be able to come up with that. So then I had ideas about how I wanted it to be designed. I needed to ditch the batch approach, and I went with a client server front end, where the clients would be scanning. I could run any number of clients, and then there would be a web front end that would receive the payloads. I wanted to do certain things to ensure the validity of it. So like the agent will sign and compress the results when it submits them. And I was playing with the idea of making it anyone can run the agent, and maybe trying to gamify the results. So like, oh, get your favorite port on the dashboard or something like that. But you would have to get a whole lot of results for it to, show on the dashboard. But it was just, my mind was racing with ways that were places I could go with it. I needed to use a database. I'd done a bit of work with traditional relational databases over the years, and I did not feel like wearing the DBA hat right now. I was really excited with the stuff that I was seeing, so I didn't want to think too much or plan ahead, and just kind of like going with what doors opened in front of me, or, I can do this without much impact, or without much like cost. So, I went with MongoDB. Not having to plan schema is fun. I'd used it in the past for quick and dirty local things, and you can just add a new property to a document, or you can kind of make it up as you go along. I did have to come back and pay the piper eventually. So yeah, I was at that point I had switched to total vibe coding. I was like, okay, this is the architect. I gave a good explanation of the architecture and the points that I knew of what I wanted. I used a combination of JetBrains, ChatGPT, Open Web UI with all the different backends. I used like the various Claude models, GLM, Perplexity, for questions and things. I would give it chunks of the code, and I'm looking to make this feature. I would I didn't exactly do a scientific method or A/B testing, but I probably should have. I was just sort of getting a feel for what is strong at what, or if I didn't like the way one thing did something, I would take it to another one and try and go from there. It did make me think about OPSEC. While it was great for getting stuff done and making it getting code that I didn't feel too bad about. It was terrible for information disclosure. I'm pretty sure that every vendor has a full copy of the code base at this point because of how much I've pivoted between them. That did lead me to a thought about a way that one could securely practice OPSEC while vibe coding if you architected your code so that the modules were in such a way that each vendor was only exposed to a isolated chunk or a particular a non-functional snippet of the code, and maybe even taking a RAID striping type approach, just going out on a limb there, that you only serve one piece of a particular function module to each vendor, and stagger that in a way that nobody ever gets a fully functional copy of your code. That was just a little side idea. I wanted to publish it, and I was thinking about the stuff about making a dashboard or having the dashboard be gamified, sort of, or what that would actually look like. I started to have some ethical concerns about doing that, even though it just started finding innocent stuff, and the other services out there are more ethically ambiguous, showing CVEs and things like that and not just targeting web ports. So I felt okay about that. That was also where the idea of what's on HTTP, I could use the spin of, hey, these things are only the main count is what doesn't result in a HTTPS redirect. I found that at the end, if I wait 15 seconds before taking a screenshot, and then check the DOM location of the web browser, I would be able to tell if it resulted in a HTTPS redirect or not. So regardless of the type, going by status code isn't always going to work, because you could have JavaScript that's doing the redirect, or a meta refresh wouldn't get picked up by that. So I was like, oh, this is a cool way to find out what things result in HTTPS. As I was playing around with the whole thing, I thought of the LL Cool J song, Mama Said Knock You Out, and it was, don't call it a botnet instead of don't call it a comeback. But it had a whole little theme song that not a whole thing, but it had a snippet of some AI generated lyrics that I thought would make a cool theme song, but I just couldn't get it right. So I made a landing page with a TV frame and had it only show valid status results that resulted in a non-HTTPS page. And so it looks something like this. That was a real result. And that was actually a real default website of somebody's. It wasn't a webcam or anything. It was just like they had an image on the default page. There's a lot of random things like that I thought are pretty cool. But yeah. I started to get concerned. What if I record bad stuff? I was concerned about like NSFW or worse things getting recorded. Somebody else also pointed out the cool idea that my idea of this is that each service would have a permalink and the screenshots would be stored indefinitely. So somebody was like, this actually could, like, going out on a limb, be like evidence of that could help solve a crime or something. I'm like, yeah, that's actually a valid idea. But I also had the concern, I was getting overly cautious about, oh, what if somebody says, well, I got the picture from what's on http.com. And so I always had liked stenography, but I didn't have a good use case for it. So then I realized, oh, well, I could use that here and encode, the original origin and a little bit of info about it into each screenshot. I was using compressed JPEGs at the time, which was manageable. I was also just kind of shoving them into the Mongo database. So it was a big base 64 blobs of everything. And that was okay. I was getting by with compressed JPEGs in base 64, but I had to switch to lossless to do the Stega encoding. So that got was a little bit of a pain. I found, for example, some bad stuff. This looks like somebody's QNAP NAS that got ransomware. Some of these are also fake. I've seen some, so it's possible that somebody just made, like I've seen takedown notices where somebody just made their web page that this domain has been seized. Another ransomware thing. This one was interesting because they don't actually put their Bitcoin address, but they have a Tox ID that they want to be messaged. This, I don't know, this is definitely fake and very, very old because the prices are all multiple Bitcoin, and it's apparently a bunch of students. It's like, oh, you can buy they're selling student logins to somewhere, and the names are very funny. There's Azan Butt and Ernest Sapernik. I don't know, I was very curious as to how old that is. And then also this is all the bunch of NSFW thumbnail galleries and things that I censored with the Iga emoji. So in making the dashboard, I hate front-end stuff because, you're keeping up with the current browser whims and, oh, this content header is, but with AI, it was pretty doable. I just went through many iterations when, I found out that infinite scrolling is just an illusion cast by anchors and pagination. I never really knew how infinite scrolling worked. It was just pretty cool, but that was something I really wanted on this, to be able to kind of scroll down in the early days of it. I was kind of scrolling. I would wake up the next day and check it and, keep scrolling until I got to the results that I remembered that I've seen before. Like I could actually keep up to it. So I felt like kind of like I was like immersed in the internet sort of, because it always had a full page, like several pages of results to look at. Now it's going a bit faster due to improvements that I'll get to. Yeah, so I made, as it was expanding, I made enhancements to the network map and wanted to have it be interactive so you could like zoom in and see stats on the who is blocks and things like that. I also added voting for, nobody's using it at this point though, so nobody's still using it yet. Maybe that'll change after this, but I thought everything that I found really cool, I would give a thumbs up, and everything that I was like, oh man, this shouldn't be on the internet, I would give it a thumbs down. And then, so right now I kind of was using it as my bookmarks for stuff I thought was really cool, and I would just stack the votes and give things multiple votes, because it's not really voting on anything when it's just me. Eventually I added favorites to it. Yeah, there's an early screenshot of some of the stats on the dashboard. The top products I found very interesting, because I didn't realize how much Hikvision cameras. They have a very interesting Wikipedia article, but they're on the top services of what I've found. So they have a very significant portion of cameras out on the internet. Yeah, as I mentioned, I was thinking about gamifying the dashboard and having the agents. So one of the things about that, they wound up being good in the long run, is I wanted the agents to be able to pass through arbitrary nmap options to specify your own ports or timing. And I also decided to have the agents pull a central blacklist so I could address any complaints, or also make sure that some of the stranger RFC 19 addresses weren't, or not RFC 1918, but outside of RFC 1918, the other special use IP ranges for like multicast or different things that were there were a lot more than I realized. Yeah, Zombocom, I saw is one of the results that I found surprising. Watching the network map fill in over time was really cool, because kind of get a feel for how much of the IPv4 space had been touched. So I was originally using, after I started doing more development on it, instead of I was putting it on a dedicated server that I had, and I was running a Dockerized MongoDB, but it wasn't very stable, and it kept crashing every few minutes. Instead of moving it to another machine or a cloud provider, I just kept making the code more resilient, and I went through that for a while, and everything is made with like it'll buffer and retry when a connection is available, all the various components. It paid off in the long run. Eventually, I did get a corrupted database. It was too large to get a backup, so every time it ran fine and would execute queries very quickly. But for the couple of minutes after, I only had maybe 300,000 or 500,000 records at that point. But it wouldn't stay up long enough, so it was like, okay, we've got to migrate this somewhere else. I had used like the AWS database providers, and I've used like Oracle has a MySQL HeatWave, which was really cool. So I was looking for a Mongo cloud provider, which there aren't really much options out there. Yeah, the only offering really is MongoDB Atlas, which has been pretty cool. They only pair though. They'll get direct connections with AWS, Azure, or Google Cloud. So I figured I gotta dust off one of my accounts and give one of those a try. I don't generally self-host my stuff, and professionally I've used, like VMware type cloud providers or things like that. I haven't really done too much with those kind of software defined automation, like server automation in that sense, in a while. I had done some stuff with AWS, and in Hope 2020, I had done Sam Brown had a CTF with GCP, or there was a little piece of it that involved GCP, and so I was pretty familiar with that. I wasn't going to go with Azure. Yeah, I wanted to not. I was hoping to reuse the existing infra that I had to just stand up the web server, the front end on existing machine, but I had to go with a cloud provider. Oracle has a generous free tier with cheap ARM instances, so I figured I could use that for the agents possibly. And I found one of the Sam Bones. He's done a bunch of CTFs and things, and this was not related to the Hope 2020 CTF, so it was from something else he had done that looks like possibly a student had defaced or made a copy of it. But with what I mentioned, using Oracle for the ARM nodes, but there's no Selenium WebDriver builds for ARM, so that was problematic. I'd asked my LLMs about it, and they said that Playwright was way better than, and I found out that is kind of the industry standard now, so I moved to Playwright, and it was very easy to port everything. I mean, AI did the porting, but when I looked at the before and after, I was like, oh, the calls are practically the same, so it was very simple and easy to drop in there. So I've been using very inexpensive ARM nodes for the agents that are doing the scanning. Passing through the Nmap options was wise. I was running agents on all of my existing infrastructure, so like things that I use for like a web server, like VPSs that I had for like shell accounts or whatever, like those, I was having all of them on different providers, like do submit results, which I ran into, I got complained. I got some nasty grams because of that. But being able to tweak the Nmap things, I was, told them what I was doing. Hey, this is a research project. I'm scanning the internet, doing a census type thing, and let me know if you see any further issues. And I would, tune my options. I found that some providers actually trigger. They have outbound scan detection, not just so. Yeah, there's a thing called ScanSnarf NG, which is pretty interesting if you search for it. But yeah, there's a provider that is running some interesting IPS type thing, or IDS, that I think goes homebrewed. After moving to Atlas, it started to step on all of my terrible AI generated queries. It was doing very expensive full scans of the database and calculating statistics. It was quick on my machine, but on the cloud, they also tend to throttle your different types of operations, like scanning. The scans are generally bad, and they would stop. All of my queries would get stopped. I had done a bunch of migrations and things for different companies, but over time, and some of them had the unfortunate of running cold fusion. And one of the tools that I had used with a lot of very bad developers who, want to create things and may have really good ideas, but are not familiar with databases. And I helped them a lot of times, like standing up their code on new servers. And one of the tools for that that I used a lot was Fusion Reactor, and I realized that the query and analyzers in Atlas was very much like Fusion Reactor, and I was like, oh, this is great. And as soon as I did that, realized that I could tell the AI what things to point to. Also, as it was getting bigger, I realized that we can't just calculate all the stats in real time all the time, so I started to have more of a big data lens on things, roll up tables with incremental statistics that would happen every few times. I found out that the advantage of a full 3-node replica set in MongoDB lets you do change streaming, so that worked out really cool. That's when I started to really dig in and was like, what other features can I use if I'm gonna have to pay for this? Let's see what bells and whistles we can do. The change streaming let me get live updates to the dashboard easier. Also wanted to add the search feature still needs a lot of work, but I started to realize that the basics of MongoDB queries with aggregations suited totally to what I wanted to do or what I found interesting. The things that bubble up that are as things start to bubble up, I could add additional exclude terms and find the interesting stuff. It also has a full text indexing, so it's like, oh, cool, if I capture the full text of every page, I can index that use the full text indexing. They have an online archive, which I was using to save costs for a very short period of time because it was not effective for my use case here. It's more like for things that you're willing to pay a lot to go back in time to search for, but I'll touch on that more. Yeah, I'd been storing the screenshots as base64 in Mongo, which was getting really expensive. At that point, I realized I can't keep it in the database, and that was a bad idea to begin with, so I moved it to Cloudflare R2, which was really great. I had some issues with, in the beginning, it was kind of choking R2, but I wound up adding a placeholder image of like a static to fit in with the TV theme of this channel hasn't been tuned yet kind of idea. Maddox, the best page on the universe. That was very surprised also to see. It's also interesting that these are all like default web pages. Yeah, so rolling off old results to the online archive got really expensive. The storage was cheap, but I wound up doing I was working on a tool to look for orphaned records and like, oh, I have a screenshot that's not in the database, or oh, I have a record that doesn't have a screenshot. And that was I'm watching the costs and was like, what's going on? And realized that working on that was scanning the database multiple times, and every row scanned was incurred a charge, as well as database, there's like access fees as well. So I realized that, oh crap, I've been chucking all my data into this Roach Motel. Like I have to pay. It's being held ransom now. Like I'll have to pay to get it out. And so I did ate the cost for one last time and did a full scan and exported it. And I figured, okay, I can use my own backend server and take the same approach of rolling off old results. So that became a manual process at that point. Well, programmatic, but I would have to trigger it manually, or now I'll probably cron it, but added a GeoIP lookup and wanted to do a world map, which I thought was, I still haven't done anything with it yet, but MongoDB does geospatial queries. So by having the Latin long of each of the results in there, I should also be able to do like geographical searches based on the GeoIP, which, GeoIP isn't that reliable, but I've just from a concept, I feel like it would be pretty neat. I found other things, like there were things, that I would keep doing. Oh, sorry. Oh crap! It's still. Oh man. I'm sorry. Yeah, no. I'm just gonna try and speed through a little bit. Yeah, I added perceptual hashing, which I thought was really interesting. Use a an algorithm to calculate basically a rough hash of the visual of the image. I split that bit field and indexed each chunk, so you can use Hamming distance to find neighbors to the things that are visually similar to the screenshot that you're looking at. And a friend also recommended using DOM hashing, so by stripping all the content out of the HTML tags and then hashing the result, you get a unique identifier of the structure of the page. So that also wound up being interesting. I posted it to Y Combinator a few times, and only one post got visibility, and it had nothing to do with the service at all. It was just that people started discussing the arguing over HTTP versus HTTPS, and that got me a bunch of clicks that only lasted a day, which was kind of funny. I've seen lots of crazy things. You can ask me about it after the talk. This is something really great that I'll just leave up there for a minute. If anybody Googles that IP address, there's a Reddit thread talking about the origins of it. A crazy webcam shot that I found. I'm not really sure what was going on there, but lucky timing, I guess. The future, I'm not sure about a source release, though. I mentioned the theme song. I have an idea for a peer-to-peer branch where there would be no centralized front end or centralized anything. And if we use RQLite is like a SQLite implementation that's distributed, that can be distributed. And I have an idea for how that could be implemented. Also, the idea of automatic tagging, or maybe when something's tagged, it automatically like post to a social media feed or something, or yeah, I have ideas. Found some cool demo scene archives and attrition.org, which is one of the first like hacking sites that I found. They used to run the or I think still runs the defaced site archive. This was an actual demo that was ported, or some demo scene stuff. But, anyway, yeah, the site is whatsonhttp.com. Don't know where I'm going with it yet, but open to questions.
I have a question. Did you ever consider using archive.org for some of your data?
What's that? What site?
Archive, the Internet Archive, archive.org.
Oh, huh. I feel like I might flood them with a lot of nonsense, like because the vast majority.
You would never match what Jason Scott puts on there.
What's that?
You would never match what Jason Scott uploads.
No, but that's an interesting idea, that maybe excluding the excluding default sites with a bunch of filters, and then something that would be prone to automatic tagging could potentially also go to archive.org. I like that idea. I found a lot of interesting personal blogs and people like travel blogs that just drop off after a certain year or something like that, where yeah, I could see a lot of value sending those things to archive.org.
Cool. If anybody else wants to ask any questions, or if you're watching on the stream, please post your questions into the matrix. Anybody else wants to ask questions, come on cue over here at the mic and we can ask our speaker.
Were you inspired by Google Dorks?
I mean, they hadn't really crossed my mind, no, but yeah, I can see the similarities. Thanks, everyone.
Hey friends, if we could come in and find our seats, we're going to get started in about 2 minutes. If you have a ham, please turn the volume down. If you have a phone, please mute the phone. Yeah, we'll be back in about 2 minutes. Good evening, friends. I'm here to introduce our friend Gui, who is going to talk about Welcome to Waveflower, Radial Oscilloscope for visualizing harmonics and music.
Thank you for the introduction. Take the mic off here. So I want to thank Hope organizers for putting up this awesome event. And I would get to do fun tech stuff, right? So for the talk that I want to close towards the end of the night here, I want it to be a little bit fun, right? You guys had a long day probably. So we'll start with some basics, and then we'll do some music stuff. So Waveflower is my kind of like the concept that I created, and I'll go into all the basics and stuff, but basically it's a visualization, right? So so let me introduce myself. My name is Gui. It's pronounced as like a gooey chocolate chip cookie. In case you don't know how to pronounce it. It's actually my last name. So I was a 7-year software engineer in distributed cloud storage. But this year I really started going just completely different direction, right? I did some workshops on music theory, sound design. I did some live code music back in April in Chicago. And right now I'm working as a freelance tech consultant. So there's that. A lot of technical stuff for sure, but a lot of fun stuff too. And you can see here in the photo, that's actually live code. In case you're not familiar with live coding, that's okay. This talk is not about live coding at all. But there is some code that allows me to do what I can do and what I can show you guys. So the basics, right? Waveflower is, it can be hard to explain to someone who hasn't really have basic or kind of understanding of music theory, or like how audio signals work, or like the physics of like, you know, a waveform, or that complex of like, you know, but if you're in music production, you're probably familiar with sound design, right? So I want to kind of level set everything. So we start with the sine wave. I'm sure most of you have seen this shape before in calculus or high school, or just common knowledge, right? On the x-axis you have time, on the y-axis you have amplitude. And this signal is one periodic sine wave that completes within 1 t, right? This is really simple to understand, and amplitude shows how, you know, how strong the signal is, right? The higher it goes, the stronger the signal. And so the basic idea around oscilloscopes, as you see here, the basic form of oscilloscope is in linear, or a Cartesian, right? XY. What if we turn into a polar transformation? And if you're done calculus, you've probably also seen this shape. It's called a circle. But what's interesting about this is that by transforming a sine signal into a polar form where the x-axis goes in radial format, you will get a perfect circle. And you guys know why that is? You don't have to answer me, that's okay. It's just a rhetorical question, because it's like a chicken and egg question, right? Does the sine wave come first or the circle come first? But I argue that the circle came first, because when the wheel was invented, the people didn't know about sine waves. But if you if you if you hang if you kind of hook a string on a wheel with like a chalk, and the wheel moves, right? The chalk will kind of draw a sine curve, right? So it's like the reverse. So we got history. We got science wrong. I'm just kidding. And this is where the interesting part comes, right? What if the signal, the frequency increases? In this case, it's sine of 2t, which means the frequency doubles. So what this means is that in a single period, instead of just one oscillation, you have two oscillations. And also, if you learn calculus, you probably have seen this shape before. It's called like the four petal or the rose, or like butterfly, all these like really fun shapes. And you're like, all these like, why do all these shapes exist? Like, it's kind of like the same concept. Like you trace it in the polar format, it kind of wraps around itself, and it becomes this symmetrical form, which is beautiful. And now you might ask, like, so what does it have to do with sound or music or just signals, right? And it's the same question I asked myself, and I've actually, through preparing this presentation, I found some realization that, oh, I'm actually teaching something that's really basic here that most of us haven't been introduced to, that it's really easy to be overlooked. But once you see it, you can sort of understand it in like a more fundamental way. And how many of you here have a musical background? Wow. Most of you here have musical background. That's awesome. We can have fun then. So in the musical system, we call these an octave. And do you know why this is the case? When you play a bass key in C, and then you play an octave higher, it's double the frequency, right? And so sine 2t is an octave, when you think about it that way. This is probably the first concept that's outside of technical mathematical concept that I just introduced you, that kind of like help you draw connect the dots between mathematics and music theory. But if you don't have music theory, if you have never learned music theory before, this might be new to you, but it's actually pretty simple to understand. And if you already have a background in mathematics, or more of like a technical background, like to think about ways in a more technical way, then I can help you to use that knowledge to build an understanding of music theory. So, so the first thing that I found out that I wrote my tool was actually to draw 2D shapes. It wasn't really about all the complex, the musical harmonics, or like advanced concepts like chords and all that. Of course, there's a second part to that. The first thing I really wanted to do is to draw shapes using sound. And while you can do that using an oscilloscope, or like a XY, like they call it the Lissajou, which is like you have X axis one signal and then Y axis a second signal. And you can draw like crazy shapes with that, which is fine, but that kind of misses the whole point, because it's actually really hard to see what's going on. And I've looked through Google or the whole internet, I couldn't find a tool that is able to express that for me. And that's why I wrote my own tool. So the basic premise of like the basic concept of how to draw a shape using these very simple functions, as you can see here, is called additive synthesis. And if you know what in sound design is, it's basically just stacking waveforms together to form more complex waveforms, right? In other words, addition. You're just adding two or more signals together to produce a new signal that is more complex than the first two, right? Or in this case, 3 signals. So, so what's the first signal? It's called a square wave. Most of you have seen the square wave. It's called a square because it looks like a square, right? At the linear form. But when you transform into a polar format, it looks like a pinwheel. So, and then the chicken egg question comes like, if the polar form was discovered first, it wouldn't be called a square wave, it would be called a pinwheel wave, right? And the second one, likewise, you have what you call the triangle wave, right? But in polar form, it's like a butterfly or like a flower that has, you know, the edges a little bit sharp because of obviously the vertices, right? And the third one was just it's either inverted sine wave or just actually shifted half a period so that it's shifted 90 degrees in polar form. So when you add these 3 waves together, like who can make a quick guess on what the final shape would be? The polar, yeah, polar. Pinwheel with petals sticking out. Oh yeah, we just went through this. Pinwheels with petals sticking out. That's correct. That's correct for the first 2 waveforms. What happens if we add the third one then? With the sine wave. So there's going to be more. You're saying there's going to be like more petals, or like it's a trick question. you get a square. And it's more of like reverse engineering, right? Like I have a pattern in my head. I wanted to make a 2-dimensional square pattern that I can actually call it a square wave, like an actual square, not just some kind of jagged sawtooth that looks like a square. I want an actual square, and I want to draw it. So I reverse engineer and see which shapes can like lead me there. So I got the first half of the shape, and then I compensate with a negative half sine wave, and it kind of like it squishes or like it protrudes kind of like the middle section out a little bit if you want to see it that way. But then in polar format, it's kind of like, it actually straightens it out, right? So sine waves are really useful for like straightening out curves. So I'm gonna do a quick demo on shapes, which is gonna kind of help with giving you guys a little bit more a real experience of how it sounds like, right? So in here, there's a bunch of code that you don't really need to read, but basically these are just shapes, right? Mol is like the frequency ratio. In this case, it's just 2, and then each one of these is just the amplitude ratio of each one of those signals, which by combining them will form the shape that I wanted. So so right now we have the base period set at C3. which is 130.81 hertz, and that is a middle C. If you guys know about music theory, and when I play, it's pretty much expected, right? It's a middle C, and it sounds a lot like a square-ish tone because it's a square. But actually, it's kind of like doing all these funny things when you see it in the regular oscilloscope. But it's still like a square, right? So we can just call this a square. Other shapes I can make. Can I make a hexagon? I can. And hexagon is 1/2 or 3/2. And I'll go into these ratios in just a second, right? But I'll show you all the shapes that I can draw with this one. I can draw it's called decagon. I think it has 10 sides on it. Octagon, 8-sided. And then we have our hexagon. And then what other shapes have I missed? Circle, yeah, you've seen like the circle, which is just the root, right? It's actually a square wave. A square wave forms a semicircle, if you think about it that way. And what other shapes have I missed? Pentagon. Yeah, I have a star too, which is very similar to pentagon. It's just different ratios of the amplitudes. Just kind of like squishing things to kind of make it straight. I try to make it like perfect lines, but I actually can't. I think I might be missing something here. What about triangle? Can't actually draw. I'm still struggling with drawing like a perfect triangle, but this is like the closest thing I can draw. So I'm just gonna uncomment everything to kind of play these shapes in sequence. And then let's just skip the last two, shall we? So I'm gonna play this and you guys can tell me what it is. Oh, I didn't make this right. Okay. Okay. There's your musical skill. And so, with our musical skill on hand, we can start composing, right? Shall we? So we can make a whole song like there's no notes, no anything, just ratios, which I'll go into a little bit in detail about that. But you can see like really symmetrical shapes form the foundations of music theory, and it's not a coincidence. But most of us have not been taught to see it that way. We just think, oh, it's a scale because it's on the piano. It's all these notes we have to learn. We have to learn, you know, we have to learn the scales. We have to learn what the chord in the C major is, and it gets all into this very kind of mechanical way of thinking, or just like non-intuitive way of thinking about music, which I think it's a bit sad that I think music theory should be more fun and should involve a lot more play and like using shapes to kind of involve multiple senses, that when you see the shape, you hear it, you understand, and when you feel the note, when you have multi-sensory input, it forms a really strong association, right? And yep, second half of the, right. Second half is a little bit more technical, but of course, once we have the basics layout, it's a little bit, we can do a lot more interesting stuff. And I want to go into harmony, right? And it's a very specific reasons why I chose a heart shape here of harmony. So what is musical harmony, right? Musical harmony is basically just two or more tones playing together at really specific frequency ratios, right? There's nothing here about notes, right? There's nothing here about scales. There's nothing here about piano lessons. They're just frequency ratios. And I'll go into a little bit about why this is the case. With the idea of consonance. Any frequency, take any frequency intervals, right? It can either be consonant or dissonant, or sometimes a little bit in between, where we can't, like, not quite sure where it is. And we call that jazz in music theory. We can directly visualize this. So let's take a really basic example, right? We have the basic one period sine waveform. It's a 1-to-1 frequency ratio, and therefore it's a circle. And then we have our second waveform, which is a 3-to-2 frequency ratio, which is 1.5 sine, right? It doesn't quite complete on the second oscillation. It kind of stops halfway there. But when you add these two waveforms together, it forms a third shape. And with a linear oscilloscope, it's a little bit hard to guess what the final shape is, right? You can see here in the bottom. It's kind of like a roller coaster a little bit, but you can see that it's also like quite symmetrical, right? So it's also symmetrical on the in the linear format, and it actually it's symmetrical just within 2 cycles. Within 2 cycles, you get a full cycle of that symmetry. It's much easier to visualize it in the radial format. You can see that a circle plus a, what do you call, the flower of life, if you will, it becomes this kind of protruded a little bit here upwards because of the circle. And it's called, in music theory, we call this a major chord. With the idea that simple, stable patterns are generally consonant. And major chords are like the most consonant that you can ever get. And I'm going to go into more demo here, just kind of get you guys have a feel of it, what it means by harmony, right? So let's not do this. Okay. Okay, so we have our basic root frequency, and all these ratios were actually the same as before, but I just organize it in the order of scales, right? And we call it a certain name, right? Like major fifth. So this is just playing, you can call it playing two notes or two frequencies together, but why is it called a major fifth? Why is it not called major 3 seconds or 3/2? It's because it's based in Western harmony, Western musical harmony. Each octave is divided equally 12 ways, and a full tone is actually 2 steps, right? And then if you get like 5 full steps, it's like a call it fifth. But in this case, there's nothing really fifth about it. And as you can see, it's very consonant. It feels pure. It feels innocent. It feels balanced. But I can also do something that it's a little bit more dissonant, if you will. So actually, before I do that, let's try this. A root note, a root frequency, sorry, with a we call it major third, but it's actually a 5/4 frequency ratio. And these are really simple ratios. It's kind of just like going up, the numbers. You got 1:1, and then 3:2, 4:3, and then 5:4, which is this one. It gives us a heart shape. Not a coincidence, right? How did nature design harmony to be heart shapes? Which are sine waves, right? And I can play more than 2 frequencies together. And this is your whole major a major triad. But if I shift the second one a little bit lower, right? You feel a bit dissonant. There's just a little bit dissonant in that, and the pattern is unstable, right? And in this case, we call this a minor chord. It kind of evokes feelings of sadness to it. It's not quite as pure as we have earlier, right? It's a little bit unstable, and the same way we feel in a lot of music, in a lot of songs, when the minor chord is played, we feel unresolved, a little bit edgy, right? Just like we see with the patterns here. Okay, we still have time. Cool. So I think, if you play a major second, this is actually a pretty stable shape. It's just that my JavaScript program didn't have as many frames stacked together. I think there's like 5 frames stacked together, but it's actually formed like a full pattern here. That's pretty nice. And it's interesting that sometimes if you do major second, and we call this a major seventh, you kind of see that the 2 patterns, wait, hold on. Actually, let me just do the major 7. it's also really wobbly and like forms kind of the same pattern as the major second. But if I play these two together, it kind of forms a more stable pattern because of the nature of how, you know, the waves interfere. And it's now it's more of kind of like a major fifth a little bit. You add in a major fifth, it becomes a six-sided pattern that's actually quite stable. And in C major, we call this a G major chord. Right? It feels pure. It feels like full of joy. The other one that I want to show you is the fourth, which is a very consonant. It's a consonant interval, actually. And it goes with 6, yeah. It's also very consonant, and this is the fourth chord, which is F major if you're on the C key, right? So, oh yeah, before we move on, there is though one interval that is, it's a little sad that because in Western harmony, an octave is divided in 12 equal steps. We actually miss out a very simple ratio. It's a 7/4 if you kind of quantize it within an octave. It's actually the 7th harmonic, right? Which in the harmonic series, it's the 7th frequency. So if you get the base frequency, you multiply by 7, you will get this interval. And by itself, it's a little bit, it feels out of tune. But we see a stable pattern. So it's like, then it becomes the question of like, is it actually consonant or dissonant? And this is where it comes into like, oh, it depends on the culture and all that. If you're brought up with a lot of Western music, this might sound dissonant. But if you're in other countries, this might sound more consonant. But if I play more notes together, and becomes jazzy. Normally in the jazz, you will play the minor 7th, which is actually the more complex ratio. That is quite dissonant, right? So jazz is kind of the play between consonant and dissonant. You kind of make it a little bit in between and let the listener decide. Oh, something's happening out there. But the 7/4 is more mysterious. Even though it exists in nature as like the 7th sine wave in every tonal sound, like my voice, right? If I sing a note, the 7th sine wave is the 7/4. Okay, so before we wrap this up, there's a last demo here which I try to experiment with. I'm just gonna play it a little bit. Actually, see if I can split this into 2. Right there. So I'm gonna play this real quick. Since we got our major and minor chords, you know, all set up, we have our harmonies here, right? And then we'll add the first one. It's a little bit too loud, the first one. Let me adjust half the gain in the first one. Or you can just make it. Actually, I haven't done this in the live setting before. So pardon me if I need to sync this up a little bit. It should take 5 minutes. Okay. Let's do a little bit faster, shall we? Oh, what happened to the shape now? I think this one might be interfering with the first one. It's interesting anyways. All right, that's it for the demo. So now you've learned basic music theory all without having to know anything about note scales or piano lessons. Hooray! Thank you. And I'll open the floor for questions.
Everybody, if you are a remote participant, please go into the Matrix channel and @tag manchicken, and I will make sure that I get your questions. If you're in the audience, please queue up for questions here. Come on.
Well, first question, as an aspiring radial oscilloscope performer, where is your technology? Is it ready for distribution? Is it available on GitHub? How can people explore this world themselves?
Yeah, if you go to waveflower.org, which is my website, you can just click on the app, and then it brings you to the app, right? In the basic format, you can already play really basic waveforms, right? But the interesting stuff is using what I call Livecoding techniques, which is just patterns that's written plain JavaScript syntax that allows me to do a sequence of just various things, right? So this is the license for this is APGL 3.0, which is the same as the Livecoding tool being used here, which is called Strudel, which is very popular because it imports from Strudel, right? Imports from Strudel, and you just have to append the syntax _scope parenthesis to make it to work. So it's the code base. It's basically in the app folder, right? And everything is open sourced. So yeah. Did that answer your question?
Yes, very cool.
Thank you. Go ahead. That's a good question.
Just out of curiosity.
Yes.
Do you think it'd be possible to turn in existing audio
Yes.
into a polar coordinate visualization? Because I think that'd also be pretty cool.
Yeah. there's a choose file here. I can choose an MP3. Well, let's pick a song if I have MP3 audio. There you go. Which song do I want to pick? Yeah, maybe let's just do. I don't have my own songs here. That's interesting. So yeah, you can actually put like a. Oh, it's because all of my files are in a different format. I think I have some OGG files here. So yeah, you can actually visualize MP3 files or any audio files if you want, right? Like, does this actually do anything? Yeah, it does. Yeah. And I can also try to match the frequency. I have actually no idea where this song came from. I just randomly playing it. So you can see the waveform is being displayed here, and you can play with the periodic base interval to kind of change how fast or how slow one oscillation goes. Right. This is just in seconds. In 1 over, it's matching the note. So yeah, if you have a signal that plays in specifically this frequency, it's gonna draw a circle or something like that, right? So yeah, you can absolutely do that. It's already included in this program.
All right, everybody, let's give it up for GUI.
Thank you. Thank you. And before I go, I will be also presenting in the Symmetry Music and Art Festival on October 2nd and 3rd. That's going to be in Fairfield, Iowa. I'll be doing an intro to sound design with Livecoding as well. Where to find me? You can find me on my website, livecode.nyc, Discord, my Instagram handle, and there's my email for any general inquiries, or if you have a cool idea, you want to collaborate or do whatever, I'd love to hear from you. So yeah, thanks for coming.